Alrighty, so this is going to be done with my hearing aid uh, microphone. Okay, so these are planning cooling designs, which I've got a couple going on in my head, for what it's worth. Alrighty, so there's a few of them. One of them I wrote down last night just because I wanted to more than anything. And the other one I came up with a while ago, but decided to more or less uh, never really write it down, I guess. Talked about it briefly on my YouTube channel a while back. That was that. So this one says, see, this is the one I wrote down on my Google Keep Notes. Cooling using a radiator that uses flexible check valve pumps in the tubes, like the veins in our legs with our muscles moving. Yeah, you do the whole the lifting your calf muscles. They have these little flaps effectively, so that way blood doesn't go back down. Those are our version inside of our body as a biological check valve. That is also a bit of a pump, as long as you move around and use your calf muscles. Which is also why when we stand up, we happen to move around a little bit to catch our balance. It seems to help out with the blood. And that seems to help out with the dizziness in your head, which is the balance kind of point there. At least, so it's been theorized by people that are PhDs and medical doctors and researchers. So if you want to challenge me, go challenge them. Anyways, to pump fluid around with a segmented hard outer tube that can be moved and flexed to base the pumps inside of the tubes on so they can remain able to push harder with greater force of flow and pressure. Now, they're flexible diaphragms, just like with our legs, right? And so they have these little flaps effectively, and they'll open up. And if you know anything, I don't know what the hell that pump type is called. I don't really give a fuck what it's called. Sunny something, the 3D printer person that did electroplating on plastic, knows because they did one and they said the word and I totally forgot about it. But I call them undulational pumps or biomechanical pumps because that's what they are. They're all pumps in our body are biomechanical, undulational, volume size pumps. They change the volume of a given area and it's segmented with valves. That's all it does. So, this is the same thing. All right. Now, these have small coils, like electromagnetic, right? I don't need a magnet in there. Fuck magnets. Screw magnets. They repulse each other, right? And piezoelectric lines. Kind of like, our muscles. Just touch your skin. There's a muscle underneath that. You dummy. I'm laughing a little bit at that because it's like, no, they're muscles now. Yeah, it's basically little small piezoelectric filaments that are connected surrounding a given type of structure, kind of like a Chinese finger trap. And then when you apply electricity, they mechanically move, actually. That is the whole point of piezoelectrics. They can both make electricity when you apply a mechanical force, but they can also apply a mechanical force when you apply electricity, which means that they can move and contract in dynamic spots. So that's why they're called filaments or lines. Embedded in a rigid diaphragm that allows for movement with applied electricity will work to dynamically compress and move the diaphragms for maximal efficiency throughout the two tubes here. Right, because there's an inlet and an outlet for the radiator, because it's supposed to be an AIO kind of thing. for what it's worth. The diaphragms have to be soft, yet rigid, like an erect penis. That's right. I went there. I went there. So, to properly seal and move for best pressure and flow performance. Just like a penis, it will need an internal volume change to help with a contraction using internal piezoelectric filaments connected to a softer material, i.e., the undulational muscle kind of style of pump, sort of like what we see with octopi and squids. So, now, this allows for dynamic seals during multiple pumping movements while allowing for greater pump flow velocity, pressure, and outright, I said static pressure after this, and I wrote it down. I didn't read that. But I think what I meant was less boundary layer loss. So that's what that would be. And it reduces total heat input from the pumps while using less electricity to perform the same action. They're very efficient. That's the whole point of them. They're extraordinarily efficient at what they do, and you need a lot less electricity to do it. So that's a good thing. You're going to want that. So while using less electricity to perform the same action. They said micro analog computer setups in the outer tubes. Of course, the diaphragm tube that's in the inside that holds all the flow of water and whatnot, right, is still there. Okay, but it's like this was both a part, but it has to like have something rigid around it. Sort of like our veins and arteries. We have a structure that's around our veins and arteries that's more rigid than the actual vein and artery. Anyways, so the micro analog computer setups and the outside, so that way we can apply voltage where necessary, right? And let's see here, then a digital main controller digital computer that's on the radiator to remove heat away from where the CPU cooler is. That way, it, of course, is as far away from the actual main cooling part as possible. So, the basic way to think about this is gravity helps. So, any amount of where you start on one side for the outflow first, that'll help with the pump of the inflow side to the radiator. So outflow from radiator is inflow to CPU, then inflow to radiator, or outflow from CPU is usually the best way to go about it. That gives you a bit of a push. That then means you got pressure. That then means you can add that secondary pump on the other tube to help the whole thing out. Because why would you only use one? You can get more flow and pressure. And if one were to fail, you have another one. Seems like a normal thing to do. So, and then that allows for the digital main to dynamically place to the analog voltage and applied, sequence and patterning for the pumps to work as best as they can for the given heat that they're detecting and sensing at the radiator level and at the CPU level. All right, so that way one fails, you have another one to go back to. Redundancy is the name of the game here. All right, so it also helps out with heat removal. So dynamic change. It helps out with pump consistency, dynamic change of the given pump, diaphragm. So if it's going to contract and get wider, if it's going to head towards its center to seal, head toward outside, because it can get thicker, right? Change its volume, but also it can squeeze inwards, and the whole thing can do multiple different dynamic pumping undulational actions, like the smooth muscle tissue on our intestines, right? To move things. which, yes, think millipede with their little tiny little, bug arms as they move forward, or like how a snake moves, where it wiggles and then it moves, right? All sort of the same thing. Or even an ejaculation of a penis. It's basically the same. I know, I'm going there. It's basically the same for the pump. I'm not even kidding. It's essentially the same thing. So there's that. You know. Let's see here. Let's see here. And a reduction for the need of complex chips and programming for its performance. So it reduces heat, makes it easier. You can have multiple pumps instead of just one pump, multiple pumps throughout the tubes, which is the whole point. I didn't say that, but that's the point of the design. It's to have multiple pumps throughout the tube, or 3, maybe 5. Odd numbers are usually best for this, just because there's a middle, and that middle then is something that you can base off of the length of the tube from there. So you can get segments, and then you can connect them, and then that would make it easier for you to like open it up. If you wanted to replace something, then it's easier to do it. So you can get away with fewer, of course, but then you put more strain on every individual pump. So my whole thing is multiple redundancies are good, because scary things fail all the time. It sucks. It's terrible. It's the worst. But that means complex chips and programming are no longer as necessary, because we have the analog, and it's only able to input certain amounts regardless of what it does, right? Because it's only able to contract, it's only able to bend in, it's only able to do certain movements no matter what. So it's just timing and adding it to that at any given point. And those are just analog computers, sort of like how we know octopi and octopuses and squids and more all have that kind of a thing where they have an analog. But I like to think of it kind of like we have a spine, and a spine will immediately react to certain strong stimulus in a immediate pull away manner. So sort of a similar thing. This is a automatic reaction that we're going to dynamically input, that will then give us more efficiency and more performance. But should that fail, we will both be able to know if it fails, but we still have the main digital computer. Or if the digital computer fails, it'll still automatically do it, like your heartbeat, baser brain stuff, and it'll still keep pumping, and you can replace that. So that's the hope on that, and it should work pretty easily. The hope here then for manufacturing, because we're talking about regular kind of stuff, it should weigh less, perform better, use less material, and overall be easier to manufacture, thanks to already pre-built parts available, combined with easy assembly. So, but research and development is needed to come out with a great, reliable product that stays in the market while being cheap enough to have volume of sales. That's what I wrote down. So, basic premise, it's got to hit the market and be viable in terms of the amount of heat dissipation and the amount of reliability and the amount of expense, right? So if it doesn't have any of that, then nobody will buy it anyways, and it wouldn't matter how unique it is. It's just what it is. So pre-built, those segmented little outer tubes, yeah, I know those are flexible, like, for like lights or whatever, right? Like this, basically the same thing. It's just a little bit better on the, sliding and stiff. We're thinking hardline-ish, you know what I mean? Where it's like, no, bend, but it's pretty solid where it's at, right? It comes like an AAO pre-filled, but very much repairable, very much. Here is another pump, or like extra tube if that's what you're looking for, right? Um, so there's that, and then the lines will just need to be like little, 4-pin or 3-pin, fan lines, right? So then like another little flexible tube over that, right? So that'll work. And then the radiators, no offense to radiator manufacturers, but a bit of a dime a dozen. You're kind of everywhere. There's a bunch of radiators out there for designs. I'm sure you could just buy that in bulk order pretty easily. I'm not going hard on fin density. I'm not going hard on material. I'm not going, there's no massive design change there. None of that is really happening at all. So that's the point of that. I mean, cheap, efficient, fast, get it done, get it out, that kind of thing. But it's good, sort of thing, right? And then fans, same kind of deal, like injection mold or something, right? I've been looking into other designs. I'll talk about that later in a little bit for my other cooling design that I have. But same premise, you can buy fans pretty cheaply now. So that's what that would be. And then the cooling blocks, the water blocks. Right, that one's a little bit contentious because, of course, we'd be buying it from someone else. Um, so there is that, right? My idea turned into the Styropyro version of get it done well. So like they have fairly cheap laser, engravers and you know powerful pulse to pretty consistent laser, you know um, power types, right? So, a way to put it is they're not technically meant for cutting things, but we're not cutting anything. We're ablating away a certain amount of material, and then we get into the engraving. So a way to think about it is it's more powerful, right? And it would be able to cut through it if we were to leave it around, and on it for a long period of time. But instead, it's more of a consistent going over and over and over and over and over and over and over, and what comes out is a very smooth, very like formed, water block, right, with lots of micro channels and surface area as a result, right? And hopefully this one I've been seeing for the die, or when screw it on or bolt it on, depending on your persuasion of thought there. So, because it's like it's not a bolt, but it's not, but it is kind of like a bolt because there's a nut on the other side. But it is kind of like a screw, but it's not the same thread thing. It's not really meant for screws and bolts are kind of similar. And a screw, like you don't have a bolt, but you can always put a bolt on a screw if you get the right thread count. I don't know really what to talk about on that one. Anyways, moving on. But that's what that is. So, weird thoughts there though, with yours truly. But yeah, no, basic, kind of you get a block of copper, right? But copper's expensive, so it's kind of what it is for me. Yeah, it's like no, it's a pump. It's a flexible, rubber, that kind of thing. So it's like it's not going to be too expensive to build that because piezoelectrics are pretty much everywhere, right? And embedding coils like PCB way. I've seen so many people do like these little micro fans controllers that have like little coils embedded into the PCB, right? And I thought that was so fucking awesome. But when I think about it, I'm also like, you can do that for a lot of different materials, honestly. And I saw Alex Steele do like this little overhang, they had a tap in gold, right? and then like I get a gold inlay, but that means I then, kind of press it down around the sides and, it's stuck. But it's like, that's a tracer. What he's talking about is a tracer. It's the old way of doing a tracing on a anything, basically, in any kind of metal or something. So I'm like, he's got a tracer there. I mean, you can do that with almost anything. So turned into, there's a way to injection mold piezoelectrics with like a little bit of like some conduit between them and like the correct like diaphragm-y kind of stiff, firm rubber kind of material, and then just put a bigger amount of material over that once you get it set up, and then you mold that and you kind of like build it up a little bit, right? And there it is. It's flexing. It's going to flex. It's going to undulate. There's some squish and compress and expand, and it's a pump. It's pretty cheap, actually. Yeah. We don't want it to be hard, except for in the right places. So I have to build it up a little thicker with a little stiffer material, and so that would be more of a plasticky, silicone, kind of version, I suppose, right? So yeah, it's research development for what it's worth that I'm talking about. But the back to the micro channel kind of thing for the water block. It's like, well, you just described that with the laser. It's like, yeah, but I want to get around the lack of stiff. That's my problem. Like, I have a problem with the stiffness of the blocks that are often out there on the market. So it's like, you need to be as thin as possible, no matter what. It's got to be as thin as possible, because that's like the best thing to do. And I'm like, but that's basically like foil. What you're talking about is foil here. Not to be mean, but that's effectively all you've been talking about is foil. So I'm like, I wonder if I can get work hardened copper. Oh, that's brittle. What's this about? What is this? That's annoying as fuck. I hate this. So I turned into, so this is some like, cheap steel. It's really stiff though. Like chromoly, some kind of stiff tool steel, but it's thin amounts, right? Then I'm gonna build like basically a box, right? And then I got the one slug, and just put it in there, weld it a little bit, get with the laser again, like a nice little. What's any element or chemical that effectively goes into steel and copper? Then hit it with a laser in those little areas. Just get fucking weld. I want you to weld. Get it in a nice little vacuum chamber. It's like a small little thing. Bzzz, and just fucking weld it. Just weld already. It's like I can have it overhang the copper slug for that steel body, right? But I only need a little bit of tool steel. So it's like it can be pretty decently small when it's structured the right way, and I press it all together and I weld it all together. Then it's like much, much harder, much stronger, much stiffer, right? But that also means I'm making multiple parts. It's like, yeah, that's the thing. That's what my issue was. It was like, well, this is going to be the majority of the expense here, but it's like kind of, it is a kind of, it's like that's the assembly. It'd be pretty cheap to assemble because it'd be pretty quick to assemble, right? And it'd be automatic. But then it's like, if I could get away with something else, I would, like that. The moment I could, the moment I could get away with something else, I would do it. So I've been looking into rigidity structure designs for both copper and aluminum. And it's like, you don't want to add aluminum. Steel will never really matter that much with aluminum because it's not really going to, care, basically. But I then looked into like, what's polycrystalline diamond? There's this guy that does all the 3D printing on YouTube. He talked about this polycrystalline 3D printer head, right? As it gets hot, it lasts for a really long time. You can do like multiple different types of filaments that even have metal in them. Cool, right? So I was like, that's perfect. That's like they literally show like this little slug, this little flat part of a polycrystalline diamond that they make, and I'm like, how thin could you make that? Like, how thin? Like, come on. Like, seriously, like, it was only like $80 for this little 3D print, and they had to do a whole bunch. Like, how thin? How thin are we talking about here? Like, like I only need it to be about like maybe a millimeter, millimeter and a half. Like, what's that like fine limit? You know what I mean? Like, you can build, I'll just get it shaped, right, to like just about the right kind of thickness and the right size, all the little micro channels, everything. It's like, screw this copper business. That's expensive. You know what I mean? Like, this is also expensive, just FYI. In every way, it's going to be expensive. But for me, it's worth it because heat transfer goes way up. So, worth it in that sense. Like, the moment it's there, it's worth it. But, yeah, it's that thing. Yeah, it's like, well, okay, so copper is easier, right? But it's like, I got a laser and I know how to use it. Like, I know for a fact it'll burn the shit out of that, and I can shape that. So then steel is way easier, by all accounts, way easier. You know what I mean? Like, ship it with a little bit of a lapping compound or something, right? Just like, hey guys, here's a block to lap it against. Like, get this flatter and thinner. Got a little adjustable, kind of like, you know, not bolt, but it's kind of on the bolt. You know what I mean? It's like a stud kind of thing where it's like, all right, we're going to get it a little bit closer. We're going to make sure it's definitely touching the, I usually call it a heat shield because it seems like it, but it's not. But the heat spreader, right? So like, all right, so it's touching, it's got great landing pressure, it's stiff, it's consistent across everything. The only problem I end up having is, of course, that's a thing that's in the way of me cooling it. So it's another heat transfer problem. You know what I mean? So make sure that this is super flat. It's got the micro channels. It's going to be a slug. It's just a literal circle slug thing that they ship, or they make, really. It's a good way to put it. So I was like, all right, so then I can just get it shaped the right way. That's more than good enough. It's be quite strong for all of my needs. If I can get it slightly bigger, I can get Threadripper on there or Sapphire Lake. So I can easily cool the bigger server or massive CAD simulation chips that you need. Cool them more efficiently too, for what it's worth. But it's like, lapping compound and a lapping block. And it's like, yes, well, that's not going to be the cheap one. As I walk away slinking, Stover, it's not going to be the cheap one though. As I hold like a box or something. So it's not gonna be, you don't want that. You want this one. That's the one that you want. Because otherwise, it really is. It's just two parts. I then stick the slug in the bottom part, and I just clamp it down. Get some bolts there. That way, it's got the O-ring seal. You can take it out if you need to ever clean it. Right? Super simple, fast, easy. And then it's like, here's a nice little torque wrench. It's like, right? But it's like, no, you need to make sure to have it click the one time. That's all you're looking for. It's like, click, click, cross pattern, right? And then the nice little overhang, kind of double arch sort of thing, where it's like, it's an oval, but it rests against the motherboard, right? In between, we don't want it to press, like, really pretty much any pressure on the tracers, but we do want it to rest a little bit on that. And then the overhang then gets like that little, the next arch above that, like a little bolt that'll go to that, and then all that means is that it evens out mounting pressure across the entire block, which is a good thing. You're gonna want that. So it's like you got the four corners and you got the in between that you bolt down, and then that'll solidify pressure across the entire thing. But of course, got the correct torque that we're looking for, and it has to be shipped with the correct sizing for either direct die or the heat spreader, right? And so there are going to be little lines and threads for that for what it's worth. But of course, the asterisk is for most motherboards. For it's like, please check. Please, hey, little goes a long way here. You can't expect me to be like, yes, I know every motherboard and every combo and all the things. Please don't do that. Please. Anyways, but that means it can also be shifted. So like it'll have the holes, but then you can move the holes. So that way it can be offset for the AMD or anything that might come out in the future. So that's the whole hope, right? Of course, then that's so I have to cut this side off, and then I have to do another slug, and I have to cut that, and that's the big chongos, as I like to call them, CPUs or GPUs, because, well, might as well. The moment you hear me, it's like, what's so impossible about the GPU cooling? I'm just wondering. Anybody else? Maybe. All I have to do is stick it there. I just need the right block. And then, just get a basic kind of air shroud for the VRM and, memory and stuff. Or you can get a basic kind of full block. Although that one is its own hard one to do, because there's a reason why you pay for that. You're paying a premium for that. But it's well, this is a modification of the block, right? And then all I need technically from that is I want to get a blower, but a blower, nobody really likes blowers anymore. I'm a big fan of blowers, though. That's the problem for me. Yeah, it's a genuine issue that I have. It's they're way more efficient for what they are. The problem is they sound kind of like ass, but it's but they're fucking phenomenally better. If you can just move air across and then out, they're better. Just outright, better thermally efficient. They do sound kind of rough, but there are some things you could do. So I've turned into a weirdo a little bit. It spins, but it goes up and down, right? So it's it's going to spin, but instead of the blower kind of, or a regular fan, it turns into it spins. Yes, it's sucking it in, but then it's sealing it up one side, and then it has a channel for it to go one direction. So it's building up pressure, and then it releases pressure out, right? But it's always kind of blowing a little bit in. So it dynamically oscillates as a result and allows for quieter sound operation, better static pressure, and higher flow rate than a typical blower. But that also means it's both hub and the outside fans mounted effectively. So, I mean, I'll do it, but I don't know if other people will, right? It's that kind of thing. It's just instead of a gear, which I don't want to use a gear, it's a direct drive. But then I have a drum. I don't want to use a drum. But that turned into, well, no, because electromagnetic interference sucks, so I'm not going to do that. Screw these ideas of freaking magnets. I don't want to do that either. Magnets kind of suck in that regard. So, and shockingly, it turned into, well, it's not doing that. Yeah, right. It's no, it's on the outside. Yes, it is. No, I know. But yeah, so like the center still has to have a hub, but like that hub has to be connected to something, right? It has to be connected to something somewhere, right? That's the thing. Uh, so, long and the short of it turned into I've got stators, and this is counter rotating to the stators, and that's one of the reasons why it goes up and down, and that allows for a shaft to spin a differential effectively, is what that is, which is the gear in the inside, and then the outside, of course, is spinning, but of course that spins as well the outside fan, which has to have a center for that to work that it balances off of. So two little plates then have to move. They have to counter rotate. They go up and down based upon where the fan blades are and the shape of where those plates are. And so that'll open it up and allow for air to go in both from the outside as it will curve back towards the front, right, towards the other side of the chip or the blower. Anyways, the fan, right? But that's a parabolic curve. And it's like, well, that's perfect because like right in there, that's going to be where my motor is, so that'll be fine, right? And then that'll curve over, and that's the little shroud actually to help move that. And then the other side is just straight blowing, but it doesn't do it all the time, and they'll have a bit of a pressure that can build up in between and on the outside as that can expand a little bit uh, for the shroud, right? So it's like a little bit of a volume, and then it blows. And so like it's always blowing, but it just gets pulses, right? And oscillation pulses combine as pressure waves that are destructively interfered to the given sound pressure that's there, but it also means more static pressure and more outright volume. So that was the whole deal. But it's like, all right, so to get like a little tiny, and it's like, yeah, well, so this is for RC stuff apparently, and it's it works though. So I don't care. Like, look away! Don't look at us as we do this. You know what I mean? It's just like a weirdly shaped gear. It's gonna be a whole thing, but like all of it kind of like works. And I was like, you don't want a gear though. I was like, no, well there isn't a gear touching any of that stuff. It's just direct, friction kind of thing, right? But then, yeah, there is a gear in there. So there is that for the hub, but like, that's sealed now. So I don't have to worry about it, and it'll last the lifetime of your card for like decades, but like you probably won't use that for decades. So I'm just saying, there you go, it's good. Meanwhile, the answer for most other people, I'll just get a fan and then I'll tilt it slightly and have it go from a 45 into like long channel, right? Make it, like 90 or whatever millimeter it is, and then just memory, coolie, all that stuff, and then block. And I'm like, yeah, that's great. Mine's smaller and more compact, for what it's worth. It puts out way more air than you, and much more quietly, along with using less energy. So that's good. I think mine's pretty cool. But yours is also cool, but I think mine's cool. So, me. So, to each their own on that one. But it's like, yeah, no, it'd be a slight modification, and it'd be a little bit of a slight modification to a blower design. That way there's more surface fin area for a blower, which is going to be an odd style blower. So it'll suck it in, but also push it out, but then also just kind of flow it as well. You know what I mean? So it's flowing and pushing out, right? So it's the destructive interference stuff that helps with everything. It's the outright pressure, right? That acts like its own version of a check valve, like a Tesla valve. So that helps out with, any static pressure coming back, as it will be able to keep pushing it in at different RPM for the fan, right? But It's also, here's my nice 280 millimeter design. Look at this big trunker that's on the side panel of of, of your case here. Same thing with the side panel for your CPU. It's right next to each other. Yeah, and then it was all like, well, since I want to go instead of like a full AAO, but unless maybe you do. So then it's just like, oh, well, you can split them, sure. And then you have one in the front, or one on one side panel, one on the other side panel, right? Or maybe you want a bigger, 4, right? Like a 4, but it's stacked. So just combine them, right? I got the pumps anyways, right? And then it's like, well, I only need it here, and so then it flows into this, goes into that. That's the one pump into another, or just put tubes there, right? And it'll work. Yeah, one single fan there. Oh wait, you mean my big ginormous 200 millimeter or something fan? Yeah, this is a big chunker fan, right? It blows through onto them, and all the VRMs seems cool. I'm just throwing it out there, man. It seems pretty cool. Look at my cool. It's got a mushroom and a little velocity stack. It's got the little horn, kind of velocity looking stack. And it's got a nice little mushroom dome. It's sucking in air from the bottom and at the top as it comes in into my big old fan. But it's like, no, I'm a weirdo again. I want to put a fan on the market. This is cooling designs with me. So it's like, well, I designed this blower, right? So let me just look at this. Super fast. Like you can kind of see where my head goes because it's like, well, how much more could I get in terms of outright surface area of that fan and like flow, like ease of flow, right? And static pressure, right? If I were just to, make that hub a little smaller, right? Make it connect from like a circle that's on the outside, right? That's a little different, right? Because it's like, all right, well, no, I have to have a plate somewhere, right? And it's like, yeah. But like, I already have a hub there. I have to have. And those are going to be stators, anyways. So I only technically need them to intersect in between, right? From the center hub, which would be, kind of like a part of that, like where it'll be connected to the hub, but they're bearings now, right? And then the circle outside is kind of almost like the actual, like, you're going to bolt it down almost, but it's connected. It's another type of fluidic bearing. Well, in this case, it's a vacuum and low pressure fluid, right? So that way it's very low friction, and I can use that friction thing again, right? Like at the 4 corners, because like, well, I already have to have a hole there anyways to mount something. So it's like, well, that's 4 motors with a small, they can be really small now. And if I do a little bit of a gear, just a little bit, I have to have hub connected. So it's like that those stators were the blades that interconnect. I only need them to head in towards the center where those stators are, right? As that then means it acts like a one way, then a counter rotate, then a counter rotate, which will help with outright flow velocity, pressure, but noise. Noise is the whole thing for me. It like reduces dramatically the amount of energy used because each one helps each other out. And it's a lighter fan blade now, but it acts like it's a larger one because, of course, I have 2 stators now. Put it a little bit on the thicker side, just a smidge, just a scotch smidge, just a little bit. Just instead of 25, 27, maybe 30 at most. You know what I mean? All right. I don't need them to go through massive amounts of electricity. So that means I can get away with like a slightly higher voltage, right? Because like higher volt, but lower amp, or maybe I want to do lower amp. You know what I mean? I think it all depends on like, do you want to use electromagnetic repulsive motors, or do you want to use like more of that magnet, right? Like magnets increase cost. The moment that happens, but so does copper. So like thinner, voltage. So it's a catch-22. I think, of course, that balance, right? So, and they only usually give you like the 12 volt to work with and the pulse width balance relation, right? But the point is, however that ultimately works out, it's just a small little thing that allows for very high flow, static pressure, big, massive fan blade surface area, probably the largest you can really kind of get for what it's worth. So, but it's also the equivalent of, look, my PC is flat, and right, and it'll slide, like a little overhang, and it's just floating in there, and these are my little stands, right, and then I got my nice, it's a definite mushroom tree thing, it's a velocity stack. It's very cool on it. Like honestly, I think it'll look really cool. But it's like, all right, so then I just have to have it flow out. Besides like the air shroud, which I can basically get a PCIe riser, stick it underneath like a little mini ATX, right, and then that'll work, right. I just gotta have that extra airflow not just go outwards, but it curves back down just a little bit and it flows out, so that way it's a little bit on the bent side. Like I want it to be a little bit more round because that'll help out right with flow surface area. So total surface area volume for, like, let's say it was a valve, a nozzle, right? Like it comes out more easily, flows more easily, and then I still have more than enough air at the bottom for the graphics card, blower. Put a nice little domey kind of style of, air filter there because it'll look cool. It's all it's for. It's just I want it to look cool. That's literally it. I just need it to look cool. I want it to look cool. I need it to look cool. It's all about looking cool. Because nobody's going to buy it. I think ultimately speaking, it doesn't look cool. So there's that, right? But that's what that was, because that's pretty easy to make, like for what it's worth. Yeah. So let's see here. Right. So next cooler design, because that's a part of the cooler design. That's a whole thing. Here, I gotta make coffee really fast. We're gonna do that real quick. You're gonna hear me because I actually have to do laundry today, even though today is not Sunday, but it's still laundry day. So gotta get the laundry done. Next cooler design is a micro or mini style air conditioning heat pump unit, basically. Yeah, I know. But it's like, behold, it will work, but also it's a little bit different than you might think. And it's like, they've been done before. I'm like, yeah, no, they have that. Do remember it's about 100, 20 to 140 millimeter, or whatever it is, right? But that's the whole reason why AIOs and air coolers are so close. It's a 120, right? And then it's the same 120 just up there. And even if there's water and it's more, I guess, efficient because of its density at transferring heat, it didn't change that because the heat pipes are right there, then it doesn't matter. It's faster and it's closer and it doesn't have to travel as far, so it's more efficient at transferring heat away, that kind of thing. So the only way to get around it is more surface area. That's why the D15 is so impressive for most people. It's a bigger surface area. So the first initial thought is almost always the kind of same thing where it's like, I'll just, attach it at the top or something. The heat pipes will be a thermal siphon. It's like, yeah, I mean, it does work that way, but kind of. Like, the moment you think about that, it's like, well, then just add a pump, right? Just add a pump at the top, put some reservoirs at the sides for like extra, airflow or lower pressure or higher pressure for the refrigerant you're using. And then it was like, well, why don't you use water? And it's like, okay, I'll try water and I'll use electricity for electrostatic, and it'll be in a lower pressure and it'll go off into the radiator surface area kind of thing for what it's worth, which is not that bad. Like, that'll work. But it's like, right, why are you using electrostatic? Oh, and there's magnets there too. Let me tell you. What? Yes. So, it's like, that's a pump, that's a Stirling pump, but of course, instead I'm charging it, right, while then basically breaking off the bonds of water, which of course causes it to do its little exothermic phase change, which I already did a phase change, so then I did an even extra phase change. But of course, that heat has to go somewhere, and generally speaking, you want, oxygen and hydrogen to combine again, because that's kind of your coolant. And it's like, yes, congrats. Yes, that's the radiator. That's our compressor radiator. It's a Stirling effect, of course, right? Like the standard Stirling thing. But while I do get sub-zero temperatures, Fahrenheit in this instance, and C all day, right? It's like, yeah, but of course I'm pushing energy into this. Like, it's the Lorentz force, magnetohydrodynamics, using pressure differentials, because of course it's on a lower pressure, and then it's going to expand to its phase change, and of course now it's more molecularized. It's got a greater surface area. So as a result, that means a catalytic conversion of breaking apart hydrogen and oxygen becomes more easy to do with less outright amounts of energy input, because it's already statically going through, we're applying a voltage, an electrostatic voltage through that given catalyst that also increases and improves the efficiency of the given cleave action, chemically speaking. Now, the problem is, of course, it's water, so great and everything, but it eventually will corrode everything. But the electrostatic seems to help, apparently, with the corrosion issues. But the problem is, of course, lots of things are more than just corrosion. Like, shocker, right? So, I need to kind of create a vacuum area for it to go into that's already got a decent amount of electrostatic plasma-ish kind of thing going on. So that's kind of what that would be. So, good old French press here. This is the 60, this is decaf, so this is 60 grams in, and then 750 grams of water, milliliters in this instance, of water, right? And that seems to be the right kind of call for most decaf. That seems to be the right sort of ratio, so to speak. But also heat. So 80 degrees, roughly, give or take a degree or something like that, is the go-to, I'll say. Like, it's the right call to go with 80. Is the big, sort of secret, I suppose, if you want to get good decaf. So there's that. Now, I use a gooseneck kettle that I have to heat up on my, of course, electric burner stove, and it's not exactly super efficient, but it gets the job done. That's what it is. Now, as for like this, it's like, well, why wouldn't you do it? It's like, well, I can do it fairly cheaply, sort of. Like, honestly, it's a sort of. Like, the cheapest one I was able to make was like an $80 like version, which that one's actually just refrigerant. With the like the slightly thicker kind of fan that's in the center. That's a 140 kind of thing, and then it's got the smaller hub on the outside kind of thing for higher pressure and outright efficiency of flow, which means fin density was able to go up And the shroud, the fan shroud kind of stuff is literally the heat sink and the reservoir sides. So the pump, the compressor in this instance, is a double counter-rotating pump at the top. That's going to go from where it's at, of course, getting heated up, right? Then it has to go through a little bit of a cooling, but then I need it to go back to compression, sort of a thing. But it's like I need it to then get recooled after compression, right? Whole thing again. So like everything is tightly packaged and managed in this small little area, right? But all doable, nothing not doable, right? But it was like, well, if I use one side, it's like, no, 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 don't do that. No, no, no. No, the chiller has to be the cooler block, but it's like the compressors, of course, add in heat. The counter rotating then turned into like, well, I'll just have like one little axle gear and I'll spin. One is a certain statically fixed a angle blade that rotates, and then the other one, which is like from out to center, so from outside to center, then from center to outside, that changes its blade angle. That allows for more efficiency. That then has to go and get cooled a little bit, right? And then it goes towards the CPU plate, because of course I don't want that heat anywhere near my stuff. That's what that is. So rather tight, compact little thing is $80 United States dollars. So it's more expensive for you Europeans because you have less inflation than us. And or do you have more? Anyways, things cost more over there. That's just all I know. Why wouldn't you know? Because it really is a bit of a weird one, because it's like, well, technically speaking, it would be more inflation, but then it's not really more inflation because it's technically more things cost more thanks to various geopolitical things going on, which isn't inflation, but we have inflation, which is pretty fucking terrible. But then you do have some inflation over there in Europe. This whole thing is a complicated topic. Let's not get into that. So, moving on. 2, okay, that's the basic premise that I started with. And then eventually evolved into, well, now we're using electrostatic. And it's like, yeah, well, the heat from the phase change boiling off into where the reservoir areas are, of course, is what that is. Like the heat's going somewhere. It's not going somewhere. If you didn't know that, you should know now. But it's like, right. But of course, that heat then got basically slightly doubled in a way. It's not really. Like a good way to put it is the energy from that heat got used to effectively help break apart bonds, chemical bonds, more easily with a given material being used, and the vacuum and the pressures and the volts and the magnets that have to be involved in this. So there's that. Right, but now I don't need a compressor. The compressor's gone. The compressor is literally the heat generated by the recombination of the two elements, making the chemical H2O, otherwise known as water, right? And of course the heat gets dissipated, right? It's pressurized where it's at, higher up, and then it gets depressurized as it goes lower down, as it gets condensed, as it's also then able to flow from a even higher pressure, where it's at where the cooler plate is, to an even lower pressure, which is where the reservoirs are, which of course all acts like a thermal siphon check valve in its own right, but it's a magneto-hydrodynamic electrostatic pump that uses thermal siphon heat differential Stirling engine pump cycles. So a lot of fancy words that effectively mean it always flows the same way, and it has multiple phase changes. It has one phase change into another phase change, which then does a phase change that then goes into doing work energy for its given phase change, which then, upon doing work energy, does more work energy after that phase change by doing cooling, which is work energy, which then goes into doing more work energy, and the whole cycle repeats itself. which is fine. No big deal for what it's worth, except it's kind of a big deal. You're getting Sub-Zero. Yeah, no, but it's a 140 millimeter. And it likes to eventually corrode things, so I'm not a big fan of it for what it's worth. Although it's now separatable and things can be replaced. It's far more expensive. Yeah, it's about 120 bucks, 150 bucks. Because like the materials are what they are, yeah, and the electricity I have to pump through those given materials is what it is, and I have to have the correct circuitry to make the right voltage, to make the right amperage, to make all of that, which means it's not just a single 4-pin fan, right, which I will have, but like I also need to add in multiple fan controllers, but as well as a actual PCIe 4-pin or 6-pin or something like that that allows for me to get the correct outright total electricity used where I need it to be. So it's a work in progress on that one, even though I'm already getting sub-zero temperatures. So, there's that. I'm not going to get into, the sub-zeros of like, really multi-stage cooling stuff for what it's worth. So I don't get that. But still pretty good though, I say personally, and it's working. It's working out fairly well. It's doing its business. It's but this is just with like the knowledge I have for thermodynamics and phase change and work energy and dissipation and heat dissipation for a given total surface area. Because instead of it being heat pipes that are connected with some like basic fins around, these are vapor chamber heat pipe combos. They have to be vapor chamber fins, and they have to also be different than just regular hollow fins with some pipes connected in between. They have to have a given type of structure inside with the pipes, and that's the Stirling engine kind of design change. So they have to combine, they have to lift something. Upon lifting that, of course, it goes to a lower pressure, and then during that given movement, that also helps with exchange of heat, right? So work energy is being performed. That also helps with the pumping action and the static pressure of the whole thing, and the Stirling engine, and the metal sponge of most Stirling engines designs, because that is a metal sponge for what it is worth. So, but it's like, no, I don't want it to do the thing that you think. My metal sponge is essentially the CPU. I need this to be more cooling than anything else. But that then has piezoelectrics and enough contact to allow for electricity to help for the given type of thing I'm doing. But we're talking about charging some capacitors for the circuits more than anything, because I still have to add all that extra electricity. But it's like a little bit of waste heat generated into electricity for work energy is a good thing in this sense. So that's what that is. But yeah, that's the whole like it has to separate as it separates, which is a filter, but that's fine. That's charge differentials for what it's worth. And as it cleaves, it's like, well, you can separate that and then recombine it right where you need to. That also helps with valving, for that to work and do its job, and heat exchange as it does this. So whole thing works just fine, but that's another reason why it's more expensive. It's just factually the case going to be more expensive. There's nothing you can do about it. But it's also better for cooling, and it's the same size for what it's worth. But the only reason why is because I have a technicality-wise 3-phase thermosiphon Stirling engine resonance frequency cooler that's a heat pump AC kind of unit thing, which is a bit odd to say, but still is what it is. Right? So that'll work in terms of like micro sized heat pumps in terms of what I'm looking for. Maybe not so much for others. Granted, they also have a much higher degree of money being willing to be spent. So usually for me, that turns into, yeah, but like actually, I can't get anyone to spend $2,000-$3,000 on like these little micro military style fucking heat pump things that people are like, yes, no, but they in the military. I'm like, sure. Let me just move on from that, because there's no way in hell I'll get someone to fucking do that. Let me go get like $3,000 for my tiny little pump. Oh my god, so real, yeah, so rough. But for what it's worth, that's just where it's at on that side of things. Let's do the cooking timer. It's real quick because I'm going to be leaving at 11, and it is currently 10:30. Shoo. There's that. I kind of get this done quickly. Now, the other design elephant in the room is, while it works, and while definitely it's more expensive, and I don't care what anyone says, it's going to have to be more expensive. And it's cool and everything. I don't think that it'd be worth it just because of the corrosion problem, and it's not really necessary to get to sub-zero most often. You know what I mean? Like it's really not necessary in the slightest for all intents and purposes. It really genuinely just doesn't really need to get there. But if you do need to get it there, okay. Like it's for those that need that. It's going to be a chunk. It's a chunk, like not a small chunk. This is a chunk of an air cooler. Okay, this is not like a little, oh man, I'm going to move all my weight from my AIO all the way over to here with my water and everything, Like, no, this is a chunk. This is chunk beef. Massive. It's a big boy. So I stir this. This thing's only 140 millimeter. Yeah, no, it's a dense 140 millimeter, I'll tell you. It is a chunk for a reason. It's a hefty boy. So that's what that has to be. But compact as a result of that. So, and then the refrigerant still gets you into the sub-ambient. Whatever ambient is for you, you are going to be sub-ambient. So in the, let's say it was 20C, which is pretty cold. So there's that. But you'll get down below 20C. And how far depends greatly on your altitude, your fan RPM, your compressor RPM, and everything else. So even the refrigerant used, although because I'm already thinking about like the little polycrystalline diamond plate, right? It's like, everything's basically just going to be based around that, right? Like it's a pretty decent thermal efficiency, right? So, but it's stiff. That's the main reason why. It's as good. I haven't checked it in a while, but it's supposed to be better than diamond, right? Like depending on how they do it. So, and we're talking about thin thickness, microchannel, all that. So, materials change pretty dramatically depending on their thickness. Like, steel can actually be pretty decent heat dissipator, right? It doesn't transfer as well as copper. I'm not going to say that, but the moment it gets thin enough, it'll do it pretty well. So that's kind of what that turns into. That's material design stuff, though. So, but that's the whole point. Good fast transfer, high stiffness. It weighs a decent amount. It has a pretty decent thickness to its density because it has to. So there's that. Stop the timer. That should be good enough for the amount of time here, which was 1:15 on the clock. Left So I would do the paper filter, but the paper filter likes to actually not seal for some stupid darn reason, and I don't really actually know why. Um, so there's that. But I have a French press that is different than what Lance Hedrick has, and so it doesn't like to do it the same way for some darn reason. And so there's that. So and I still have to press it fairly slow for what it's worth for this to even work anyways. So there's a bunch of this going on right now. So yeah, that's the thing. But yeah, no. Let's see here. That design uses like an entire trick effectively to do any of its work energy removal or heat energy. Because heat energy is work energy just in a roundabout way. But of course, when you're talking about a thermosiphon for cooling, then the work energy is, of course, the cooling action of the given design. So, right? Kind of weird. But usually we think about it movement, but heat is movement. So, kind of like splitting hairs for some people, right? In the business of the physics realm of things, because it's effectively the same thing, even though people will argue so hard for way too long about it not being the same thing. And I get bothered by it for what it's worth, because it's like, it's not. And I'm like, it's the same. Work energy is movement. So as a result, yes, but bigger movement. And it's like, well, it's still, what's the size? And does it move this or that? Since it's moving things, which thing does it need to move? And then you get into the debate of like large amounts of physicists and engineers and scientists until eventually you end up realizing everybody just sort of agreed to stop fucking yelling at each other and they didn't want to have the argument anymore. And that's how we just decided to use these words to mean these specific things, and we just sort of left it alone. But, don't tell them that, because otherwise they'll get all upset about you, saying things that are factually the case. But, whatever is basically how I do that. Yeah, but then the other one was like, oh, all right, I'll just make that my version of was it fucking the thing with the stuff for the fucking liquid cooler AAO, but it's an air cooler now. It's like they've done that in the past, and I'm like, yo, I know, right? The problem is they didn't really do it right. Like a lot of people know that they didn't do it right. You know what I mean? Like, a lot of people like the idea and the concept, but make tiny little pumps, and it's like, oh yeah, no, the pumps are doable now. Back in the day they weren't as doable. Now they're doable. That's the whole point. Like we like the fact that pumps are now actually doable, especially when it's like, well, the pump can now be placed differently. Instead of like on the cooler itself, you can put it on the sides, or you can put it at the top. And we're talking about like a little AC pump here, like, well, you can have a counter-rotating pump, which is set up for this specific refrigerant that is set up for this specific application, so then it becomes optimally made. And then you don't have to worry about it being weird. Yeah, no, I just have a reusable, filter, effectively, pour-over filter. That's a basket filter. And so, like, it still allows for a damn good amount of silt to go through, but I don't care because the boulders are gone, man. The boulders. I hate the boulders. Boulders suck. So, coffee talk with yours truly while we're designing coolers. Because that's what this is about. Like, I'm only here, like, literally, to, like, I'm just making this specifically just so that way it's like, here's the process, the thought process I go through. Because, like, how did you come up with this? I thought really hard about it while I did things. And then I came up with this. And that's the whole gist of that, basically. There isn't anything else going on, honestly speaking. Just a lot of thinking and mulling it over for my designs. So, nothing else there. That's good coffee. All right. I'm using Seattle's best decaf right now, so there's that. All right, so let's see here. Then the other one was like, all right, so if I make it what an AIO, right? Yeah, because it's like, well, then I'll just have to make the radiator get split into two 120s effectively. Yeah, basically. It's not even a joke. I'm not kidding. Yeah, it's like we have radiator pumps. I get a decent, block, and that's basically all you need, I guess, for what it's worth, for it to work. Um, and strap it down, make it work really extraordinarily proficiently well. But the problem I have is like, yeah, but your hoses suck and your pump is bad. Like they're not stiff, and the pump is very much not designed for this kind of operation, like at all. And you have to use two of them, which is kind of shitty. It like introduces more noise, more failure point. Kind of, it's not about the failure point for me. It's more about the noise and outright heat, right? Like that's what that is for me. Right, I'd want to immediately increase fan density and get a better static pressure fan. That's what that would turn into. And then since I have to have the reservoir anyways, I just put a shield around that, right, for a fan shroud, and then I'd have a push-pull configuration no matter what, and then just fill in that thickness, right? That's no longer something I want, right? So I'd make them thicker 120s immediately, up the fan density, and make the fans, better optimized for that. So that means I have to get a little gasket seal that stands off. It stands off, kind of like the Noctua 2 for like the little directed fan thing. So that way it has a little bit of time to ultimately correct the fan blade or the fan air pressure that's coming out, right? And at that point, I might as well just get a big, huge block. And it's like, hey, so you've understood one of the main problems. You didn't just stick a third one in the center. It's like, well, right, yes, no. But that's a triple 120. Oh, yes, no. Luckily, Linus Tech Tips has done a video about how, ultimately speaking, 3 is about the max you're going to ultimately get in terms of outright thermal efficiency of saturation of your air, right? So there's that. But shockingly, where ultimately the fluid flows is massively important. If you know anything about fin density, expansion, heat dissipation, and outright fluid flow, right, then you know that it's like, no. The first one that has the cleanest, coldest air has to have the highest fin density, and it has to be the thickest one, okay? Which means that's why that fan looks that way, right? The next one is like, oh no, that's fine. That fan can honestly be not optimized for pressure. It's just all about flow rate. So it's just super fast, high bite angle. That's all you need. The middle one, of course, higher density, less thick, right? It's like you want density, but you don't want it to stick around for as long, okay? Or you can alternatively make it thicker, but with less fin density. Of course, the last one is lowest fin density, lowest thickness, okay? That's all you're looking for, but you still have to have it stand off, right? And you still have to have it seal. And that's why you have to have the 3 radiators here be different, seal between each other, have to have the rubber gasket, then you still have to have the stupid, bloody, fucking terrible in my mind. It's not. Okay, it's just my mind that's like that. Pump. I don't like the pump. I don't like radiator pumps for what it's worth. Okay, like they're great for AIOs that do them, and honestly, they work wonderful. I don't like them because of their size. I don't like them because of their lack of efficiency for a given application like this. It just doesn't work as well as I would prefer. So that turned into, all right, I'll just stick 3 of them together. I'll make the radiator, reservoirs all just be one, and then I'll make a big bellows pump. Each side is a pump. So that way the surface area is much, much greater. I can pump down and then back up and then down over and then spread it, right? Since it's more often than not, hanging up, off to the side. And it'll still work just fine if it's vertical, where it just blows out to the top of your CPU case. It'll still work just fine. And laying flat too. But that way, when it is orientated that way, it will be just fine and it won't starve, which is the whole terrifying part. Like a rotating pump starves. I hate that. And I don't want 3 at all. And now I can counterbalance the pumps so that way they don't make as much noise, which is a good thing for me personally. Even if I'm hard of hearing, I still don't like it. It still does actually vibrate the entirety of your enclosure, and it can produce this weird infrasonic kind of weird noise that you feel. There's like this pressure that's there, and I don't like it. So for me, it's like, oh, well, that removes that. It's now balanced, it'll last longer, and the pumps are far longer lasting. They'll seal for longer. Everything's good. And they're now much more easily replaced, which that's a big part of that. But this is a series, not parallel. Right? I was hoping somebody might have caught on to that. If you did, write it in the comment section. But hey, yeah, it's supposed to be a series, not parallel. So it goes to the front, then it goes to the rear, then it goes to the furthest rear. Right? So front, middle, rear, right? That kind of thing. And the whole reason is highest heat, still kind of got some heat, lowest heat. And it's expanding every time. So as it gains more volume for lower fin density and, the result of thickness of the radiator, it has less resistance to go through, but it also has, well, air-wise, less, that it can impart into the air because it's getting saturated. So it's a way to maximize, potential. That's all it is. Just maximize potential. But that it means that you're gaining more cooling efficiency because of the way it does that and because of the way it flows more efficiently through the given structure. But it's like, they don't make bellow pumps, like at all. No. And they don't make a 3 different fin thickness radiator, all this. So I have to buy 3 different, and then I have to make that all together as one. All doable, but still, it is what it is. But if you're like, we don't know what bellow pumps are, you have headphones, you have AEMs. Do you have those? Well, yeah, there you go. That's all they are. That's a bellow pump. That's not even a joke. A bellow pump is literally a headphone diaphragm. It's literally the case. That's it. Not even a joke. So just do that. So there's, beyond that, nothing else to it, more or less, for what it's worth. Kind of. It is a kind of. Kind of is kind of for a reason. Because it's not just fin density, it's also the seals in between each of the radiator, which you have to have. You have to have a gasket seal for each one of them. Because you don't want air to go anywhere other than the radiator. You want the radiator surface area to be as maximal as possible. So the enclosure to the radiator has to be gotten rid of. Because you don't need any fans there at all. And in fact, you don't want any real space to be there in between. Okay? Whole thing, you get that now, right? That also means fluid flow has to be very precisely efficient. Which is a whole other thing because, I'm only getting it from one side. And it's like, That's why the whole radiator reservoir on the sides have to change. Yeah, so it's like you have to do the whole bellow. It's this size that goes into, yeah, it's a good way to put that. It's an angle effectively, so it's like a funnel more or less. It goes into that angle that then goes into that one first, and then that's effectively another straight shot transfer, and then that's another straight shot transfer. So it'll have to go from that one side down over 90, but like we can't do 90 because flow is terrible. So we have to do the 45 into it, right? But that sucks. But it's like, no, 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 that's fine because we have, remember the whole like funnel thing that we're talking about for the next pump? Hey, guess what? You go all the way that distance and then you do the 45 up. Like do a little U. You want to 45 down, across, and then 45 up. Right? And then you'll do it again up there. Right? Because then you now actually have that space. Yep. And that also means you have to shift them just a little bit. So that way they're zigzag, just a slight touch, scotch, and you have all the distance now you need to make it work and be sealed. But that also means it has to move with the shroud and all the. So instead of fittings, we can't do fittings, right? These are thick, solid rectangles. That's like literally what that is. It's like, no, we got rid of the structure on the outside. We are just moving it over as fast as possible. That's all this is going to become. So goes over, finally, good, and then we got to pump. Send it off, right? But what? And it's like, yeah, no, I know, I get why you'd go like, what? But that's the most efficient flow path travel possible, along with outright remainder of static pressure that can work off of the counter style of pump that has to oppose itself, right? And destructively interfere its pressure wave. But in so doing, that gives us greater flow velocity and resultantly, hopefully, a reduction of boundary layer inefficiencies. Okay, so inefficiencies are dime a dozen. Everybody knows about them, but they suck, right? So, and the moment you go like, well, I'll just use a regular radiator, it's like, I'm not a regular person. Sorry, I'm that dick. I know, I'm that guy. So it's like it needs to be teardrop shaped. It needs to have stators. It needs to have expansion areas, right? It needs to go through a lower pressure area for the reservoir from here to here, right? And so that way I can have it try and do a micro phase change as it'll then dump off into the remainder as it's trying to do a slight cavitation as a result of that, which during the flow of the given fluid then it has a cavitation, which then allows for a given area to then be gone into, which will then allow for a greater volume. Right, but it's like this is the top and this is the bottom. There's your greater volume area. It's like I have to seal it somehow, and I still have to have this air travel and go around, and it needs to be connected to a shroud some way. So that's what that would turn into, for what it is worth. So that is more or less due to like pressure differentials, heat, but also flow, and then the big real one, which usually turns into I'll just use electricity. I'll move something and then it'll do it. That kind of thing. So might as well. Yeah, it doesn't have to have them be vertically aligned or aligned with the flow of air. So that way it's not a detriment to flow velocity of air. But it also increases surface area, which is what they're go on about. But it's like, for me, it's like, yeah, no, surface area, sure. But it's supposed to genuinely just do a phase change. Like for what it's worth, I'm just expanding into a vacuum area, kind of like another reservoir, which allows for heat to try and more easily dissipate. That's all it's doing. But of course, it's like, yeah, how much is that going to cost? Well, these are all bespoke radiator things, so not that cheap. That standard thing. So it's like, no, I'll just get the 3. Well, no, I'd want that for sure, because I'm basically giving you the equivalent of like a heat pump in AC. So it'll get closer to ambient. It's not going to get subambient. It'll get closer to ambient because I can dissipate more heat, because it's not nearly as much surface area for cooling after a phase change. That's what that is. So, but that's a solid 150 for you, because nobody makes those radiators. I have to design those radiators, and then I have to get someone to make those radiators, and then I have to put those things together, and then I have to market, and then I have to sell, I have to ship, I have to do the whole thing. So, no, not cheap. Versus, well, this is basically just sticking to radiator-dense structures. There's some hardline tubing for my compressor, and the compressor is pretty easy. It's fairly cheap to get, right? So, it's about 100, 150, depending on the size, because like it's supposed to go all the way up to this flat one that's 200 millimeters that can shift itself, like it can move a little bit. So they're rigid, but like they're able to move up or down or a little bit over to the side, that kind of thing. And so you can stick it to the side of your case panel as a big, ginormous flat radiator structure. I know. It's gonna look better than the AC ones, okay? You out there, I can already hear you. It's gonna look better. Stop that. It's gonna look it's a big 200 millimeter fan. It's a, massive fucking compressor. And not really good. Well, I mean, it'd be the same, but anyways, that's the flat one. But it's like, oh yeah, no, that'd be fucking perfect. I can have like all the cooling I need. I only need the one fan. Yes, but it does sort of get in the way of you being able to see your components. So that's what that would be. And then there's the other one where it's just like, well, it's several stacked flat ones, kind of like a 120, right, or a 240, right, and then it's like flat, and then it goes up. Basically, is what that would be, but it's like a little bit higher up for what it's worth. So, and then there's the 140 millimeter that has actually technically a larger, I think 160 or 150 or something. Anyways, a larger radiator at the outsides, right? And then it goes to smaller 140s in the center, and it still uses the 140 or 3 total fans, where I'll have the 140 in the center and then the 2, on either side of that, and it sucks it in and blows it out, right? Which was nice, but it only goes one way. It's like whichever way that's oriented, it's only going that way. There's no other way it's going. So it's like, oh, I bet you they probably want this other one that's vertically there, but graphics card heat or something. I don't know. I've gotten into that, like, I'll just put a shroud, and it comes with a shroud, to the case front, and then, like, to the rear case fan, as I used to do, right? And that would help, for what it's worth. But, then there's the cooling situation for the VRMs and everything, so, and then the flat one is just like, oh, it's 120, I got the one, well, it's actually 140, but, that's, yeah, but it's like, no, I need a compressor somewhere, so it's like, that's the sides, and that's gonna have to be there in like a different, like, vertical kind of like weird way. Yeah, the angles, for what it's worth, it has to be there. Whole thing. And then I have to have like the compressor, which is the 2, instead of stacked on top of each other, I have to do like side by side and stacked. So 2 stacked, but like that's the counter rotating, and then it goes to be more efficient for the compressor. It goes off into the the cool plate, right? So. Right, and then that's the surface area versus vertical. So it's much, much more compact, much smaller, but also, like there's a fan that's there, yeah, but it's drawing in air, sure, but like I don't want it to be underneath just because it has to go somewhere. So like I have to design the fan specifically for that, and that one turned into, I suppose I'll bend the radiator structure a little bit, and then like have a little gasket, and then have like a parabolic curve from the center of the hub, and then outwards. That way, that has a little bit of a structure, so that way the flow is good. But it's like, but that's sucking in air, from that. So like that's a thing, yeah. It's like, a little bit of shrouding goes a long way with that. So it's like, here's a cup, which is not really a cup, but it's a shroud that goes to the case side panel. If you've got any ability, the second, or have it come from the rear, right? That'll, and then it just blows outwards to wherever the fuck it's gonna go. I don't know. It's fucking somewhere, probably up the top or whatever, right? Yeah. Right? It's like, oh, I could. So much for it being small. Well, no. I mean, right? Like a smaller case will still fit that. It's still fine. Okay, it's gonna be fine. In fact, if anything, it'll be right next to it. And so, like, that's just a little bit of, and then hey, there you go. Yeah, no, just whatever, wherever that's gonna go to. Yeah, it's a real balancing act for air intake and where it comes from, where it goes. And eventually just was like, I'll just get a case that's literally just like effectively an open bench that's separated and then sandwich them right next to each other. Do a little diagonal version for my GPU, and then that's a little riser that goes around the side, right? A little mini ITX, right? And then it's like, oh, I'll just get that little blower because that's so insanely easy, way easier. It's so much like a vapor chamber and some heat pipes, right? And then like that's the motherboard thing, right? So it's just like, oh, I'll just blow it in, and instead of it going outwards, because that is so rough, yeah, like no, just blow it through. That's its out version, right? So it's super simple to do in that sense, but it's like, no, you have to get a blower. I don't like blowers. I love blowers to a point. You know what I mean? Like they do kind of suck a little. Yeah. Anyways, I gotta get going. I'll pause this. Alrighty, back to recording. So in the world of thermodynamics, because I'm here doing the whole laundry thing, all heat dissipation is moving, and this is the reason why it's work energy, moving heat from one place to another, entropically and or with active designs. So it's movement of any small, tiny particle or wave to a more elongated, ordered state somewhere else, or to do that somewhere else. That is literally all heat dissipation. That's not even a joke. That is all of the thermodynamics that you ever need to know. And unless you want to get into like hyper specific kinds of things with math and certain specific physics. But otherwise, that's all it is. That's what the whole math describes itself out to be. That's what your professor is trying to tell you. That's what any of it is, really. The long of it, run of it. It's entropy winning out over time, things getting faster, more long, and energy being dumped into that to help out with information transfer. That's all that is. So, informational transfer, which is a good way to put it. So, I think that's entropy, which is information can now travel faster in between anything, wasting less energy, allowing for less chaotic movement, allowing for greater degrees of order, allowing for then what we view as less heat. When in reality, it's like, this is work energy called the vacuum of fucking all the things. There is no outside. We're still accelerating last time I checked, numbnuts. So, boosh in your face, there is. Deal with it. It's going places. It's getting energy from nothing now. Shut up, you bitchy fucker. There is no way to do this. Proceeds to still continue doing it, and the universe doesn't care. Fuck you. So, what does this have to do with cooling designs? Oh, well, the basic answer is, shockingly, a lot. You want to know why I got to Sub-Zero with the water and then the face?
Is that you yelling?
Yeah.
What's the matter?
I'm recording.
Oh.
So there's that. So, anyways, if you want to know how I get that, it's like, oh, well, it's becoming more ordered while I do it. It's becoming ever increasingly smaller and has more surface area while moving in a more ordered manner. That is more and more, intrapedically speaking, dense, I suppose, in that sense, as information of any chaotic movement meaning, movement that is opposite and counter to any given straight line and or continual direction of travel, is being reduced. Which then, of course, means that for our view of events, because that's quantum special relativity, even though people don't like to ever think about it, it looks like it's colder, but that just means it's traveling more concisely and precisely and accurately, while imparting less of its energy in that given movement into us, in our version of view and perspective of it. It's traveling faster and faster and faster and faster and faster. I'm like, well, it's almost like quantum thermodynamics work on a universal scale, and that's why we happen to have this thing called the universe's continual acceleration, going faster and faster and faster. But no, let's not do that. Let's say it's other words that are wrong and stupid and don't even make sense after a while. But whatever, because for what it's worth, that's all it is. The lines then effectively become more ordered states of the given gases involved. Right? The compression, which is what's going to happen, because of course, while we separated them, they have to be pumped that way, which of course, that's a larger area for it to go into. But also it's not, because it's technically going into many, multiple small areas. While the volume is still larger, it then happened to exchange a large amount of heat while doing that. It then managed to, ultimately speaking, during that separation as well, lose more of its chaotic ordering and movement, so to speak. Then it got moved into more lines to do that yet again. Tubes, to dissipate more of its chaotic movement as it goes to a larger and to a even greater number of smaller. It started off small, then it got even smaller, then it got even smaller, then it got even smaller, and then it got even smaller. Until eventually, of course, it adds itself in and expands towards the center. It does work energy, of course, during that. As it expands, of course, it's going to cool. Of course, that seals up one area and allows for another to go into that, and that adds pumping energy from the given separation of the given catalytic conversion compounds that are being helped along with magnets, magnetic energy, and electrostatic and voltage, whatever forces you want to call that. It's like they're charge differentials to me, but whatever, because they're effectively pressure differentials. More positive here, more negative there. I need more of this from you. I need more of that from you. But that's all it is. It's just pressure. It's all charge really starts looking like after a while. I have more pressure here. You have less. Let's even this out. Reverse osmosis. Oh no. No, not my biology getting mixed up with you fucker, damn bastard douchefucks. Your physics. Stop getting your physics involved. I hate you and your physics. All of you over there work because of our physics. You stupid, dumb idiots. You. Anyways, on the short of that, it's like, oh, I'm not done yet with my designs. But all that is to say, so heat moving anywhere just needs to be aligned more orderly. And what you get out of it is something that then, of course, is colder. And it'll take a more ordered state as a lower pressure and a more chaotic state as a higher pressure, and it'll move it to that. What's the lowest ordered state that can be? Nothing. Yeah, there's nothing going on. So it's going to go back to that. Pretty standard vacuum force stuff. Yeah, there are inflatons. Inflatons. I hate inflatons. I hate this guy saying inflatons. He ruined everything by saying inflatons. The whole world of physics might as well be like, go fuck yourself. But for what it's worth, it does accurately describe that, but not really, because they're not particles in any aspect. In reality, it's more of a, this is a given pressure wave. So it's definitely more of a wave function than anything else, but whatever. You know, they always get all weird about it, and I don't like that. It's like, you need to learn all of the tons. I don't need to learn any of your tons. They're all a bunch of pressure wave things, and you all end up ultimately going towards one thing or another. And it's all a bunch of vibrational bullshit that's trying to order itself to no longer have vibration in any aspect and or way. But whatever, sure. But moving on, because it's annoying as fuck to like get into. But that's why thermodynamics is like that. If you ever get into thermodynamics for real, you'll end up understanding how much you end up hating thermodynamics because it describes everything incredibly perfectly around you all the time, and everybody just comes up with their own special words for a bunch of other bullshit that's just thermodynamics speak for does this like this because of these things. Because movement exists, and it wants to move more easily for less resistance. That's all it's ever been doing. But little universe stuff alone, this is why the basis of that given type of design works. Thermodynamically speaking here, yes, while I'm imparting a given disorder, it is becoming more ordered in so doing. Yes, I'm able to dissipate that heat energy, right, in so doing, because I can be very accurate and precise with how I do it, while also during that dissipating the energy in its own right. Yes, while it is a shroud, sure, as the reservoir it is, yes, I agree. However, the difference turns into that's also still got air going over it. So works out better that way as a result. Which means I'm cooling it while I'm also separating it into another phase using the very energy that it gained along the way. Well, most of it, if not all, because it's in a lower pressure, so it's effectively steam, right? And as a result of it being steam, it has a higher surface contact area through the given, catalytic compound that we're using with electricity and magnets that are involved that help rip more of the bonds apart more easily for the given type of design that's going on here. So, but that's also why it's like, well, yeah, no, in so doing, it has to get, there's waste heat. And it's like, yes, no, I'm putting the waste heat into the air. it's going somewhere. It's not staying with it. It's not an insulative thing. It's going places. So no, no, I can't do that. That's what that is. But what I'd tell you is like, well, that's the basis of the other radiator design, right? It's like, yes, no, well, heat saturation for a given flow rate is great, but uh, its first initial, right, heat volume is right there in the start, okay? But if I make sure during that initial pump that I create a degree of cavitation and I'm allowing it with a little bit of a movement of a valve to go into a larger volume, right, of reservoir, that allows for an expansion that still has to condense, of course, back into the pump, okay? So that means all of that has to be connected. That's why I talked about the top and the bottom and all those fins. It's effectively a fourth radiator that I have right in between three radiators and at the top of the bottom. So, uh, while doable, um, usually not necessary in the slightest for the vast majority of people at all. But that's why I said I'm like this guy. You know what I mean? Like it's slightly teardroppy shaped fins. They're connected with these, basically a vapor chamber or hollow, heat pipe, whatever you want to do, truthfully, because that will work. That allows for it to do this type of thing, right? But then that's its total amount of heat dissipation, right? But instead of doing it to the point where I was before, which is very small molecular, tiny, tiny little things, right? Which we're talking like we're getting a plate and then we stick a plate together that has really small channels, right? Like that's literally like you have to do it that way. There's no I'm gonna plasma deposit onto this thing. There's no I'm gonna do any of these other things kind of stuff where like that's super expensive and time consuming and I don't want to do that. So I just get a vapor chamber and use some thin and then right weld it together with a little plate and make sure it moves and it has the right kind of valving and structure for it to all do that, which will be fine. Uh, which is the only reason why I'm getting that kind of performance. Right, but uh, you know, it wouldn't do that without everything I'm doing to make that happen. And there's a reason why it's as expensive as it is, and why its chunk is heavy. It's heavy. Like to put it in perspective, the technicality wise, for radiator version, that's just water, liquid, regular, right? Well, treated all that so that way it doesn't corrode for a very long time. In all ways, is way simpler to make and cheaper, right? Like, and it'll perform nominally well. It's ambient. It's gonna get to ambient closer. It can't go below. That's what that is. But still, really pretty darn good. And it's not my full final fat design because I don't, know how to quit. That's kind of my problem. Like I'm that guy that just keeps going and going and going. Give me a second. So I was like, all right, I need to be able to figure out a better way to cool everything in a much smaller, tighter package. And Stirling is usually one of the best ways to do it. Just outright. It genuinely is that kind of a thing. If you can spin something and have it oscillate up and down, then that's literally the best way to go about doing it as a Stirling kind of heat exchanger effect. So the way to put it is refrigerant. It's going to be on the actual chip, right? Then that's a spinning disc kind of, stator separator thing like I talked about, right, for the blower, right? But in this instance, we're talking about a heat exchange. So during that heat exchange, that's what causes the thermal siphon pump sort of design, but we're also adding in right, electricity to help keep it pumping. But now it's flat, and now I can have it more or less uh, dome shape, hemispherical shape, right? Like it's more oval in that sense. But the reason why is because I can have a single 120 in the center and then two 120s above that are, spread over that given surface area. Then that allows for me to get the RAM and the VRMs just fine where they need to be because they still have to have that pump have a depth to it. It's not perfectly flat. So it can be right above it and it will always be able to continuously pump. And the losses are minimized as the heat exchange is right where it needs to be, right? Uh, Now, that is a micro style um, AC. It's a genuine AC heat pump, and so it needs to have the correct kind of refrigerant. I regret to inform you, I used CO2 in a very heavily pressurized state that sublimates out. Once it goes into a lower pressure, it will still have enough cooling to be a solid. But the solid, of course, sublimates out into a gas, helping increase expansion. Then, of course, has to condense, and then the pressure has to do its whole thing over again, right? So that means it has to come in from the sides, and it also has to exchange at the top, which, like during sublimation and during that pressure repressurization from the condensing round, and in the exchange of that heat as it sublimates, and of course I'm adding in electricity, so energy, work energy is being performed, so it's not going away. All right, like it's not a perfect thermosiphon. There's no way to do that, but that means I use a lot less electricity to get the results I'm looking for, right? But it is what it is. Like I am forcing it to undergo a phase change to a solid instead of a liquid gas, I guess. Right, that's in that supercritical state. That allows for it to then expand after it's turned into a solid. So it's a two-phase or three-phase, uh, refrigerant design. The only reason why it works like this, though, is because of the spinning and the expansion of the inside and outside. So it's like that's the Starling. So like the volume has to change, but then it's also spinning, which means it's going to impart a change to its given volume, but also a change into its given heat index. So it's colder below, but of course that's going to exchange into this, solid structure, right? That then allows for it to sublimate and exist as a kind of always boiling carbon dioxide kind of thing that's solid. Now, that means it can never fully close, which is okay, but that also means that the surface of this material has to be able to withstand dry ice never sticking to it under these pressures and movements, uh, which wasn't impossible to find. It's fairly cheap. It's effectively a tool steel. It's a chromoly, like molybdenum kind of tool steel. Yeah, it's got to be polished pretty hard, worked out. If you want to go even harder, you can get like the diamond like carbon or diamond deposition on the outside of it, right? And that'll still work, but like tools still work. So uh, the other side was, well, I'm always about the diamond, the polycrystalline, like it's super stiff. I was already gonna have tool steel for like the little, so it's basically using the same block. But now I'm gonna use like this kind of a design instead for that, which turns out they're really good as a bearing surface. So like carbon dioxide, when it's in that liquid gas state, the supercritical state, is a pretty decent lubricant that acts like a bearing surface when it's on the polycrystalline diamond because it's super, super hard. So I was able to get like a couple of different areas around that onto the slug that allow for it to exchange even more easily to that given spin and rotation and movement up and down. And that helps with pumping exchange and heat transfer. So it's like, well, it's too steel on this side. Yeah, so I know. So I can't use copper. Copper kind of likes to bend too much. I was able to get tool steel, sure, but is it so hard to just get like a couple of other slugs of polycrystalline diamond, and then shape them? Turns out not so much. It's not that hard. Uh, so I just did that and then put a bigger, case on the top and uh, basically the same thing for the diamond, pump at the top. And so it allows for a change from pressure into the solid state from the supercritical to a solid, then it sublimates out, but then like that would allow for that exchange as it would boil away, and then the rest of it would come back in as a repressurized, condensed version that I have to, of course, uh, perform a little bit more work by doing that, and that's the helpful, exchange of that heat for the given pump action compression into the supercritical state that I have to do, right? So that means the top and the bottom and the middle are a double exchanger for the given Stirling engine. You have to have like both that cool, but then it has to rotate, do a double vortex. So that means heat goes off one way and it gets recondensed again, and then it goes from a outside and at the top to a pressurized downward spin inward travel that then goes through all the little channels that are the bearing surface area, and then it moves and then it goes back up after exchanging some heat, and then it goes and does its whole job again. So the double vortex is a way of cooling things with air, but of course it needs really high pressure, and it's like, yeah, well, I've got that. That's fine. That's not the problem I'm having. In fact, I don't really have much of a problem for this given type of pump design or compressor. Well, it's a pump compressor design, but it's a Stirling, and so like the cool of the metal sponge is effectively the very refrigerant itself. So I know that sounds so odd, but it's kind of not. It's like, well, it's exchanging from its supercritical, and then of course, instead of doing, it's crashing out into a colder state, which is the reason why it acts like a constant kind of yeah, like ice, I guess, right? Dry ice cooler. So um, the downside is that it takes a little bit of time. Okay, so like when it sits still, it'll still slowly sublimate off, right? So there's that, and then it has to pump to get it back a little bit, which is the main thing. So that means it's fine during the beginning because it's not going to have any need for like that extra amount of cooling, right? But it also means that it loses its efficiency in the beginning. That's what it's about, right? So like I have to pump in energy, and then it'll eventually get the dry ice. So to do its work energy performance, which is fine for me. Other people might not like that, but it's like I don't really need like negative something ridiculousness degrees as my cooling. you know, I don't. You know, luckily the condensation thing is usually pretty easily solved by effectively a sponge and some rubber. And I know that sounds weird, but it is essentially that. It's a rubber cover with some sponge material in between, and once it gets up to being hot, that will uh, evaporate off. So it soaks it. It doesn't have like those kinds of issues as it sublimates off, which is nice, and eventually it'll dry off. But if it's extraordinarily humid, right, uh, you should really just get like anything to dry off your apartment or your house or something. Please do that first. You're asking like a lot because at that point you're effectively just gonna like always have for any kind of cooler. It seems like a water producer, using the cooling effect. You know what I mean? Like it's just gonna grab water from the air. So there's that for me. But the reason why I did this design is because I'm using the electromagnetic, electrostatic kind of thing in a different capacity, right? So like all those little grooves, all those little channels for the bearing have to do this specific way, and that means they're forcing it to undergo many small, from a larger to a smaller to a smaller, and it gets rapidly accelerated as a result. you know, and it has far more surface area, right? And that's great. But of course, it has to go somewhere. And so that reservoir at the top has to come back down, right? But reservoirs, luckily for us, can be an entire two sheets of either aluminum or copper, right? That are the heat exchanger, vapor chamber, kind of heat sink fins, right? So that allows for it to come back in and do its job um, rather efficiently. But the caveat here is it's not been done. The design, as far as I'm aware, doesn't exist anywhere. This is brand new territory. Nobody would be able to do it. Like you can't just go to someone. Like this is already extraordinarily high tech stuff, right? And then it's like, yes, but wait, there's more. Because it's like, no. Remember that electricity that has to be imparted for the pump to do its job? Yeah. Where is that coming from? And how does it do it? Right. And so it's like, all right, the pump. Okay, that's a good question, actually. Right. So turns out, in order to do that, you do have to have the outside and the center to have like an actual pump to exist. So remember that blower I talked about earlier? Well, it's sort of the same thing. Where I have to have four corners, move it along with a center hub that moves that with an axle. So, uh, which works astoundingly pretty well. There's always a catch though with me, and the catch is, and with well anyone really, because that's physics and engineering. So there's that. But this one turns into these are very low torque, which sucks. Okay. Uh, there's nothing I can do about like helping you with that like idea, right? Like, is there some way of gaining more torque with more? Like, yeah, oh yeah, let me get that 24 pin connected to this. Let me go do that. I mean, I have 1,000 fucking 20. Or in this instance, we use the plate and the bearings and everything as a type of electrostatic battery generator and electromagnetic magnetohydrodynamic repulsive and attractive force electro motor, which is what I do. So it's in its own right the exchanger. So I know this sounds counterintuitive, but separating the carbon, even one single, oxygen separated, massively alters its overall cooling potential. So that's essentially what I had to do. I have to create a bunch of electrostatic and electromagnetic that dumps into a Faraday cage-like structure, and it'll never go out electromagnetically speaking and electrostatically speaking into other material, because that would be bad, right? But it means it helps separate some of the carbon dioxide gases and recombines them, helping improve efficiency by using a version of a thermal, like an engine's pump, right? But also, that's the same as a iron redox flow battery. So in order to do this, it has to produce electrons flowing somewhere, because I have the polycrystalline diamond and it can be conductive, along with some doped material along with the tool steel. It then allows for an insulative and trace line matrix to exist onto the pump, which allows for both coils and attractive and repulsive forces to be made to happen. So I have both a regular standard electromagnetic motor on the outside and on the center, but also it in its own right is a type of generator pump. In a way, it's not really a generator, but it kind of is. See, it dumps it back into itself. That's what that is. So if I didn't do that and I was to put in some energy and move it, it would generate electricity. However, that's not what I'm going to do. Instead, I need to put in electricity, kind of like the piezoelectrics, to get movement. I modeled it after piezoelectric activity. You squish piezoelectric or pyroelectric, mechanical action happens, electricity comes out, right? This is basically a version of that. I'm putting in a electrical current to get a mechanical motion out. In so doing, though, work energy occurs such that I lose heat. So that's the reason why this works as powerfully as it does. It's not just super hyper efficient on friction and really powerful in terms of its material design for the strength and pressure it's at, for the valving and clearances it has. It also both gets moved externally and by itself using electrical forces. So this would be magnetohydrodynamics, Lorentz forces, electrostatic forces, the Stirling effect, all the effects effectively that I could try and pour into this thing. It's like iron redox flow. What is this? It's a heat battery. It gets really hot. Iron's over here, oxygen's over here. They want to combine. It's like a thermite battery effectively. And then, you can always heat it up and break it apart. And so they're about 80% efficient. MIT does them. They're trying to sell them whole thing. I'm like, yeah, but I can't do that. So instead, carbon dioxide is actually fairly efficient for this kind of design. With the right materials, it'd be even more efficient, but I don't need those materials, right? Instead, it's like, no, I'm not looking to actually break this apart and then recombine them. That would not be what I'm looking to do. I'm actually trying to use that as a method for attractive forces and a expansionary force. So I already have the ability to make a repulsive force, right? Which is fine. I'll totally do that. It's great to do that, actually. That's a thing I need to do. So, but if I want to do it even better, if I can get it to rip itself off just a little bit, then that oxygen recombines. And that creates an expansionary force, but it has to perform work energy to separate it. Of course, that work energy is, of course, made to do the pumping action, right? So there's a long, wordy thing that sounds like a professor that's trying to talk to a group of college students that don't know jack shit and he's just droning on. So a way to understand this is because there's a greater surface area, because there's more amounts now of that I can do, that allows for greater amounts of torque vectoring at multiple different areas while allowing for exchange and combination, so actually thermic reactivity to occur, that allows for an oscillatory spinning effect to be more pronounced and higher energy imparted, meaning it's more torque and more RPM. And while it does this, of course, it's getting cooled by the very thing itself on the other side. Basically, it's kind of the best of all worlds, but of course, it's not the best of all worlds. It is able to do this, yes, and it is able to move itself, yes, and it is able to do all these things very well, sure, yes. The caveat is always the same. It hasn't been done before. Yes, you can use it like this. Yes, it gets more torque. Yes, it gets more RPM. Yes, it is more efficient. Yes, all of that's a yes. I have to get polycrystalline diamond. I have to get tool steel. I have to put in an inlay to this stuff for either copper or graphene or something that's conductive, that allows for the electromagnetic to occur along with the electrostatic exchange and the correct material, which I don't really need like correct material to increase this, but if you wanted to put it in, you could. It'd be a lot more expensive. It wouldn't be worth it to me, because it's doing it more than well enough, right? And it's just for cooling. I'm not trying to do this for some other reason. It wouldn't increase cooling at all. In fact, it would do the opposite, because catalytic converters, of course, either need heat and or produce heat doing chemical reactions, right? So not wonderful in this sense. So that helps insulate that effect. But the reason why I want to talk about it is because, oh, these are kind of like conical and flat burr sets of an espresso maker, grinder, right? What that means is there's very tight tolerances, very specific types of shapes that are ground in that allow for this. But that also means that that's why it's becoming more ordered, and how it exchanges and how it sublimates and how ultimately it's performing its given work action. By the time it gets all the way to the flat part, which is 3 radiators here that are 120. So it's a 360 radiator effectively that has a outside, goes up first to the two towards the center, then it goes back in. It has to do it that way. I know that sounds wrong, but there's a reason for it. It's condensing. Because it's condensing, that means I have to get more pressure, and it has a smaller area, and it travels less of a distance to get back to the pump. Engineering-wise, it's optimal. You should not do it another way. If you do it another way, you'll lose efficiency in pumping, efficiency in all these ways, and truthfully, you also lose a lot of your cooling by doing that. So going outside towards the top, then back towards the center is the only way it can really be done. And it's a very statically fixed thing. So you might be able to orientate it the other way. Big if, if you have a PCIe riser cable, because what we're talking about is a CPU cooler, then oh yeah, sure, I guess you can move it away and tuck it out of the fucking way of this thing, which would be nice. Just stick it on the back of the ATX, mini ATX, whatever it is, and that'll be fine. Right, as my dog goes after this toy, he runs around. I wonder if you can hear him. Anyways, but it's primarily meant to go over the VRMs, the RAM and the other side where the power delivery is for the CPU, right? Which are on the right and left respectively, if you don't know how that works and is oriented. So, but it's a really nice compact design. Very, very compact. It also needs to have the air shrouds. It also needs to have all the way the intake happens to happen. Everything has to be done correctly, right? And this is not those, oh, yes, I'll just slap some stuff together and it'll work suddenly. It's just going to work. This guy thinks it's just going to work over here. Unfortunately, this is brand new, bespoke, all of that stuff, which means research and development, which means, yeah, I have to sell it to you, but it's not going to be cheap. This would not be cheap. I can't sell it to you cheap. There's no $80 one like the one I had before. That's not going to happen, right? Like, and by the way, that started scaling really fast. I got up to $150. You see how fast that came? Like, I didn't even talk about the 4, like the stacked tower one, but that's like an hourglass, right? Or any of those. But like that 200 millimeter one, that is genuinely the cheapest, largest surface area, most efficient in terms of like outright price performance, because it is a $100 option. That's it, just $100. Not bad. You don't get a fan though, but not bad. You don't get a fan? Find a fan. Go find a fan, dude. Go find a fan. Jeez, get out of here. I'm always so angry about the whole fan thing. I'm sure you can go get someone else's fan or our fan, which is factually speaking better flowing. So there you go. With more pressure too. Yes, indeed. Factually. With lower noise flare. Indeed. Hey. Or no. That's a solid $20 to $50 fan, depending on what we're talking about here, because like it does depend on the thickness, and then the shroud design, and a whole bunch of other stuff. Meanwhile, $80 option works pretty astoundingly well. Thank you. Yeah. There. See, this guy gets it. It's an AC pump, though. Yeah. Okay. Arguing with customers. This is what I'm selling it for. Okay. Anyways, back to this thing though. This is a $250 fucking cooler. Yeah, that is a $250 cooler. It's using CO2. It's using electricity and a whole bunch of other shit, which is phenomenally advanced right now. Like nobody, like, I know I usually in most of my YouTube videos talk about it like it's nothing. Just do this. It's super easy. These are like bleeding edge things that have come out, within the last year to 5 years. So have fun with believing you're going to get this cheaply. If you buy a bunch of them, though, I can then sell it to you cheaply. Otherwise, no, I'm not able to do that. But the reason why I'm talking about it is because it's like, oh, this fits perfectly into very small cases, like genuinely super small. I can flip, and I mean that, flip the fans around. Instead of blowing down, I can flip them the other way and blow them out. I can suck in air from the sides, which will easily outstrip basically anyone's liquid IO 360, AIO, I mean, right? And easily destroy most people until they get into like really hardcore cooling with like a cooler and some ice and like a multi-stage probable setup for like AC or something. Like it's still gonna get there. That's the reason why I'm talking about it. It's like it's gonna get to the point where you're gonna go into subambient, but well below subambient. We're getting into the reason why I was talking about the whole universe thing and everything else, right? Before we get to the blower fan that is different for the graphics card, which is a whole, like, you have to angle that. I'll just get a fan. I'll suck it in for this. I don't want to do any of that. That sucks. Everything about that, I just heard you say sucks. Everything sucks about that. I don't want to do that. But what if you did? Well, for what it's worth, I would. If they sold it, I would buy it. I'm not kidding. If they sold that, I would buy it. I'm just letting them know. I would get a single fan at angle 45 degrees. I would then get the shroud. I mean, I never get to do the dual cards anymore, anyways. So sad. Honestly, it's sad. I like just scaling it with more GPU. If I could do that with CPUs, I would. I'm not even kidding. If I could do that with CPUs, I would do that. Um, but I digress because it's sad. It's like loneliness and sadness, just always my friend. It seems. But there's programming. You can do the programming. You have supercomputers. You know what you're doing. That seems like you're copping out. You know what I mean? It seems like you're doing that thing. I'm just saying. But I'm going to move on. It is their product, their stuff, their drivers, all that. I cannot get involved. But still, my displeasure is still rather immense, and my day has been ruined for years since Crossfire and SLI have gone the way of the dodo bird. I miss that. So, anyways, I'm going to move on to the topic at hand, right? Where, all right, so we go back to the blower. It's a 45 instead of a 120. This would be, a smaller hub with the outside kind of like singular or whatever, kind of like fan that it's a little bit, maybe because I have to angle it anyways. So I can put it in a, thicker, fan blade kind of design, or like if I needed a hub that was like that, or I had to have stators in the center, then I can do a counter rotating design, which means I only technically need a singular on the outside or smaller, on the outside, like those PCB style, micro motors that then head towards the center with an axle, right? Because I already have the stators. So it's a doable design. I like it personally, right? It's thicker. It's going to be thicker. I also would prefer to do like a uh, more. I'm trying to get my words out properly, right? Because I want to be very careful with how I would say this, so that way you understand it hopefully a lot better, and why I would choose to do this. Okay, but I need them very flat angled, right? For higher static pressure, but I need way more fan blades, like as many as I can get in there, and I need them to intersect with stators, meaning static from the fan blades behind to the ones in front, with having a trailing off to the ones in front below that. Now the reason why is it makes it stiffer, yep, but it also means it creates a Tesla valve like situation. So if I put like ones that are slightly in front of it that then bifurcate off, that then have like a diffuser, yep, that go off into other stators that are there right behind it. So one and then off to two and behind, offset kind of thing. That means it has a harder time going back up, which increases static pressure again, but also makes it so that way I can flare out the bottom and make that kind of like a plate that allows for it to then from the outside and towards the center get pushed back down as a constant stream of air, right, that is more consistent and pressurized. So it's both stiffer, it is still acting sort of like a blower because I have to kind of curve them a little bit to do that, from the one and then the offset, and then it'll go off to a chamber essentially that then is curved. So it goes kind of like a flat, and then so it's quite flat angled to begin with, goes down kind of like an S, goes back to flat, and then it has to go to just a very steep, almost 90-degree scoop that it'll come out of. So that way I get increased pressure and flow rate with lower noise. That's the hope for this, because it's angled, then it goes down, and then it goes flat, and then it goes back down, which is a bunch of extra steps for pressure to go back up, that kind of thing. So, but it's also making it very laminaristic. So it's going from a larger to, technically speaking, a slightly smaller area. So it's being accelerated, been pressurized, and of course, has a bunch of resistance for coming out for the pressure. It's a whole thing. This is the reason why I would do it. It's just less sound coming out, less blowback, and as a result, it should be more efficient. Okay, that's the hope for this. So I already have to have the stators there for if you're going to use 1 or 4, I'd probably use 4 smaller ones, just because that means I can run them with less overall energy, and it'd be hopefully more efficient. It's a hope. Don't know. One bigger surface area might be better. Don't know. I'd probably do the 4 just because redundancy. If any one of those things fail, then I have 3 backups. So it should still work. Right. Then the stators, of course, there to help pressure or take the pressurized air that's already kind of mostly flowing down and orientate it to a much higher bite angle for higher flow rate that's counter rotating to that given stator blade area to that fan that's below. That allows for that to then travel more quickly. Like, it's all well and good to have higher pressure, but if that pressure doesn't go somewhere, then who cares? So if I can speed it up, then that means it'll have an easier time to be more efficient for the blades in front. And so it'll sound better, it'll perform better, and it'll outright improve overall efficiency. And it only needs smaller blades now. So like the ones at the top can be, rather wide, but they're somewhat on the thinner, but also they don't need to be super thick. The whole package will be thicker, right, as a result of this, but that means I can get away with less thick fan blades for both the front and the rear that are actually moving. So that's a big help for outright efficiency. It's 45 degrees, right? So that way it then can use the standard velocity or parabolic curve funnel or whatever you want to call them. To me, that it just goes to Venturi effects. So it accelerates to that, and it can be with the shroud positioned to help with VRM cooling and blow more evenly and be, technically speaking, now flatter and closer with the heatsink fins angled horizontally to allow for it to flow out the rear while allowing for from a wider to a smaller to an even smaller back to a wider and to another wider area. Right, so I can have it's going to be a dual slot anyways. You know what I mean? Like, the moment I think about it, it's like, no, I won't be able to, stick another anyways on it. But, well, if I'm willing to, right, just add like a secondary, because, just now triple slot, right? But it's like, I mean, dude, we have 4 slots. We have 3.5 slots. Everybody's got all the slots, so, but for me, what that means is it's the same as the CPU radiator. A denser fin area, an arrangement in the right place for the GPU cooling, which can now be placed further rear towards where the fan is. And then, of course, the VRMs and everything can be stacked along with the memory, right? And everything, right? to essentially allow for the rest of that to flow through. The caveat here is I would have a back plate that is no longer going to be the same type of back plate. Okay, so it will be another heatsink. I want to shrink this down, and that will allow for cooling on both sides. So I can flip the GPU up to the top, right? And then because we already have PCBs that have some holes in them, right, for the fans, for me, that's perfect because I can then have like that hemisphere kind of design, a little crescent moon, have that air from the top go down into the two vent areas in the rear, right? So that way it'll look like it's skinny, but it's kind of like an hourglass. It'll go down over, exchange a lot of heat. That way, heat, of course, thermally rising is kind of the whole point and design of this one, for the GPU being where it's at. But then the rest of it is power delivery and memory. Memory at the top, of course, but like memory below, right? And then I can shrink this massively, hopefully. It's a hope, right? Like it's still got to have the vapor chamber, it's still got to have the heating, it's got to have all that. That's what it is. So, yeah. But that then allows for me to use that more efficiently. Like a heatsink vapor chamber at the top, right, with the heat pipes, allow for different orientations to still be viable. Kind of either flat or regular against the motherboard, or vertical. Any of those things will now be just as viable. And the main reason is I can have a higher fin density because it's going to push up to that top anyways, and then go over for that, and then that exchanges more closely to where fresh air is, and then it can expand and then go back down. That also means I can get a smaller amount, right, of fin density at the bottom as it'll bifurcate, but I can start it off because we're talking either memory or some VRM, whatever might be super hot in that sense, to be right there at the beginning, and then it can expand. And so that way it'll kind of look a little bit like a dog's bone, you know, right? And then it'll go out. So the main big issue for most people, I would imagine, okay, for it to get too much in a tizzy, right, is, well, how the hell do I get my connectors to this thing? Like I got DisplayPort, USB-C if that's a thing, or HDMI 2, any of that. How do I get this? And well, it has to be connected. Yeah, so fiber optics, if I can get them, I would love to. Right? Be so sweet if I could just get them, because then like the two prongs on the side, so simple, right? They just run them through as tracers, right? But that's what it is. So unfortunately, they're unlikely to do that. So now the next best thing turns into I can get probably 2 on the sides and 3 in the center, and then I can have them go from a wider to a smaller back to a wider kind of thing, and then line them on both sides, right? Like hourglass again, but that's kind of like waveguide stuff. So, right, that helps with airflow. Yeah, that's what it'd have to be. So I'd have to have it go around that and then through that to allow for it to properly, vent out the air. Or if I'm lucky, right, I can just have it go straight through because like, no, we use this slot. This has a thing at the top and it has a thing at the bottom. Just use this slot, right? Hey, hey, yeah, exactly. Thank you, my brother, indeed. Yeah, woo. But that's what I would do if I could do it. If I really could do it, I would do it that way. Um, It's just simpler. I know that doesn't sound true, but it is. It would be simpler, ultimately speaking, for cooling. You know, just to have it go straight out at the top and straight out at the bottom, and have one single fan, which improves flow, pressure, and outright efficiency, which would not be terribly expensive, luckily, right? To make. It's a different way of doing it. Yes, I agree. Um, but it's injection molding. It's the same kind of thing. It genuinely would be like that. Yeah, it'd be two injection, and then you basically weld them with some heat, which is another injection molding, right? And then you have the third one for the other fan, basically, which is just the higher flow rate. Then it's four PCBs, right? You can probably cut that down to one if you wanted to, but I don't know. I feel like it's worth it to not have to do that because I can get like a single statically fixed PCB, right? And then I can have the micro motor both on one side and on the other side. And that would allow for greater torque because I already have like that, thickness, right? That's there for the thing that holds the fan, the shroud or whatever it's called, right? So it in every way for me means it's not tremendously expensive. It's going to be more expensive, yes, but not tremendously more. And in terms of cooling, it produces a factually speaking greater surface area of cooling and a faster flow rate to that cooling while also not having it finally vent into the case, which is the main reason why I'm not kidding. Um, it works fine for most people, but like the the things that have started to happen and people just became like accepting of it have bothered me for how heat gets dumped and vented back into the case. And it messes up airflow and it messes up like efficiency. I genuinely hate it. So uh, it's a thing. It's less efficient. It means that like in terms of many different types of like if you're talking servers, cooling designs, it sucks in that sense. If you're talking for me, like consumer, regular kind of Joe Blow guy, um, then it still sucks because I want all of my heat to go out one area. That's what I prefer. That's literally it. I want it to only go out one area. And the reason for it is then I can just get a duct and stick that next to a window and I never have to worry again. I literally never have to worry about any heat going into my apartment or my house or anything. It's that fast and that simple. So that's what it's for. And it allows for a greater control over where air is coming in from, where it's going, all of that, which improves efficiency again and shrinks the design massively. Um, you know, but it is what it is because it's like, all right, so what? Why the 45? Because it's blowing effectively straight. That's the main reason why. Um, yeah. Uh, like a 45 means it's blowing straight, but it's like, okay, I can curve that and I can have it go on both sides to cool, right? I don't think they do that very often, but then they do put memory on backplates now, right? So, you know, it's doable. It's doable. I don't know. Um, I'm just trying to think about a different way of doing it, though, if I'm being honest, because it's like that problem for me. Well, if you're willing to go the distance for that shroud, you can get away with that blower style design and the same thing, but you have to change the the way it happens to work. Okay, so like you'd suck in from the top and you'd suck in from the bottom, right? Back to the same thing like I had before, right? But the reason why I did it that way is it's way higher flow rate. This would be much cheaper, but still adequate design. Okay, so I'm effectively doing the same thing I did before, right? Where I have the stator, but now it's just the one kind of thing, and then I still have the parabolic curve. The shroud will go out. That'll have all that, blowing off to that, right? And then I have the center. So think about it this way: I have to get the rear. So think like a clock: 12, 6, 3, and 9. So if you were to look at 6 as being what's blowing towards the GPU, all right, then 12 has to have that parabolic, right? But that only gives me 11 and 1, all right? 10, 9, and 8 are blowing already towards a different direction, and 2, 3, and 4 are blowing at a different direction. So that means that outer side and inner side have to be merged together with the flow of 11, 12, and 1. So like that's a whole parabolic that I can get to work with the shroud, and then a separatory kind of thing that's around that for the 10, 9, and 8, and 2, 3, and 4 to also blow off and then join into the 12, 11, 12, and 1 direction with the 7, 6, and 5. So it's another version of like I have to get that to be separated by the shroud to then join into an outer shroud that is the 11, 12, and 1 that then will all have the 7, 6, and 5 join in together with that. So little air channels, for what it's worth, that all join in together from the top and the bottom to make that work. But luckily, doable, right? Like, I mean, if I wanted to get the motor right, oh yeah, I'm gonna do that. That'd be way easier instead of using the little tiny axles, for what it's worth. You can just use like the little micro motor PCB, and then have both of them just opposing, and you still have that axle and bearing and everything. But that means they can use that as the hub. But I would, so I'm, yeah, what? You already hear me. That's going to be one smaller one, and then I'll have like a couple of vertical ones specifically so that way I can make the hub smaller. Uh, because they'll be in the fan blade area, right? So that means I have a center that I can use as another parabolic, and it'll spread out from that center spreading out, and then I can have a little bit of hole there, like a little bit of space, like a valve that opens and closes. So that way, if one of them were to get clogged, it'd still achieve some amount of air going into that. But it also means there's a mass airflow that then gets captured and then sent in any given direction. So that way, that pressure doesn't get overwhelming to where it's at, and it can balance itself off of each other and allow for it to flow more easily into the shroud ducted area. So it achieves a higher pressure while achieving a higher flow velocity. But that means I need, instead of a flat part, I need a hub flat part kind of thing that has stators there, which isn't really impossible. In fact, it's pretty easy to do. It's just like those, Easter eggs that you squeeze in the side and it opens up. Kind of the same thing. You just squeeze it together and then it rotate off of that. Um, and then that would allow for the ducting and everything, the shroud, to push all the rest of the air. Why don't you do that? The pulsing, the up and down, right, of that given design does that very same thing I talked about for the airflow moving back and forth, but also seals and forces that air to have a pressure wave that is counteracting the sound, effectively a pressure wave sound. So it turns into, instead of a obnoxious kind of sound, it turns into a very clean, smooth, elongated lower frequency sound that also maintains its pressure and uses that to oscillate and jostle a little bit inside of the fins that I'm using to spend a longer duration, technically, in the heating fan area and saturate it more and remove some of the boundary layer effects, as it will then still expand out into the um, area for the cooler for the bottom part, right? Instead of where the connectors are, the the vent effectively. So uh, it's still a, a thick. People were still okay with 3 slot cards, so I decided to make it a 3 slot card. It shrinks down, all that, but then it then expands into the 2 vents instead of the 1 vent, which um, just makes it so that way it's more efficient at cooling. Yeah, um, that's what it is. Yeah, it sounds nicer. It flows a little higher, has a little higher static pressure, and it's just a little more efficient. Yeah, but that's the thing. Like they can easily probably match that with like you know more, I guess. Heatsink and all that. Sound maybe not so much, right? But it's what it is because I just don't like the I just don't. I'm not a fan at all of these triple slot cards that have like 3 fans on them that just vent vertically into the case and then also down. Like if you don't know, they vent downwards into where the motherboard is. So they're genuinely not good unless you're willing to effectively strap them to the case this of the side panel of your computer case. In which case, it's like, oh yeah, no, fine, okay, yeah, right. You get your PCIe, like, it properly flows, and it's not going to have that come back in to your graphics card and will remain cool, right? But if you're not doing that, then it'll always suck a little bit more of that air back in, and it reduces the efficiency, um, which sucks. I don't like that. And then they have these horizontal ones, and it's like it blows off towards where the intake is from the front panel, or towards the rear, which is okay, except for the fact that that's only efficient when you only have the one central fan that blows in, and you still need to make sure it has a parabolic curve so that way it helps move it outwards more easily and flows better. And you still have to have it tilt upwards just a little bit so that way, and for the one that goes into the case, it doesn't get disturbed by the inward fan flow of that air, as that's pressure that resists it. So a good way to think about it is like if it curved up and then slightly had an overhang, that Bernoulli's principle would then apply, and you would get that to help you flow out more air, um, which would be better outright because it's already a triple slot design to begin with. So, and it's 1 fan, one single fan, does the whole job. Yeah. So, eh, I don't need more because more fans equals greater amounts of heat imparted because the hub produces heat. It's just what it is. So the more electricity you spend, the more heat you have to contend with, as that's just how it works, unfortunately. So 1 fan, if you can get away with it, is always going to be more efficient than multiple fans, right? You might technically get more cooling, but it does depend pretty heavily. And graphics cards are a rough one for me. Cooling a CPU is easy for what it's worth. Like I just stick a tube here, go over there, it's cooled. You know what I mean? It's good, right? Versus like, oh, a graphics card, it's just like this is the shroud, this is this thing, this is, and it's just a nightmare after a while. It sucks. It's like, no, I'll get the blower and I'll do that. And it's like, oh, then fucking yeah, do that. absolutely, 100%. Like that's a way better design, for what it's worth, especially when I can compress it now, right? Like that's what my whole part of it was. It was like, oh, I can now get this back into a 2 card slot design, which is the big part for me. Um, Now, the way that works, however, is that the connectors are extraordinarily small. Um, yeah. Uh, uh, so the PCB goes up and it has to go over at a 45 and it has to go back up to vertical. So that way it goes back into a 2 slot. But that means I have cooling at the top and cooling at the rear. And the connectors are still right there, but they're really small. And then the rest of it's a big vent. So it's like, no, there's venting in between technically some of the connectors, right? For your display. And, and then you have venting at the top and then venting at the bottom, right? And now it's back to 2 slots, just 2 slots. And I have exactly one blower, but it doesn't sound nearly as bad as it could, which is nice. I just happen to like my design. You just have to deal with the fact that I like my design. That's all that is. I'm not going to sugarcoat that. I just like my design. It still sounds good. It's not terrible, right? But it's now within a 2 slot design, too. And it's got all the cooling you need, which is wonderful. That's the only thing I really wanted. I don't want this other. I don't like these chunky 4 slot design. I don't like the 3. I don't like this. The 2.5 is okay. I can kind of handle that. But 2 is where it's at. I like 2. I like the blowers. Blowers are all the rage for me, for what it's worth. Just because then I can effectively kind of stick it just, on a mini ITX, I can kind of get it vertical, right? Or like off to the side, right? And then that sucks in air from both sides. I can put the ITX, SFX or whatever, power supply right there at the bottom. If I elongate it a little bit, right, then that means I'm able to get all of the connectors for my 24, my 8 pin, my double 8 pin for the graphics. If I want to go for a flagship, to work with that, it's sure I get it. It's a little on the thicker side. I know. Okay, that's okay. I don't have to worry that much. For me, I don't really honestly see a problem with that personally. But that also means it's like, oh, I have to get the flat style. But it's like, right, I can make a longer flat style. If I'm gonna like use the PCIe riser anyways, and that means I can get that to be a much stronger PCIe instead of a ribbon. I can have it kind of like a straight out, straight down, straight across, straight up, and then it's right there, which means it's stronger. I can make that with a metal and plastic kind of backing with the motherboard that I can still, have the plate, and then this still allows for it to work with the 2 slot design that's there on the back, right? Or I can go all the way up to 4 if that was the case that you wanted to go with. But this is for the blower as it sticks a little bit further past the motherboard and allows for it to still intake air on both sides of the case and just blow it straight out, right? So super hyper dense, small, but I can get a a big square if I wanted to. Although not sold on the square one, but for what it's worth, that's what I would do. I'd get like genuinely, yeah, I'd get like a either that 200 millimeter or something like that. That's like a big square, right, radiator that I can then just pump from one side to another, right, and or the two of the same sides. It really depends on ultimately how that works because it's the reservoir versus the. Anyways, point is that means I can stick the pump at the top in the radiator, and then the case just goes around that, and I can get the nice filter, right? Air filter for the case for the intake for the blower, while also having the intake for the CPU, because that would be the CPU intake, right? But that cools off the VRMs, right? And then it can go out, just out, up at the top, off to the side, right, where the graphics cards is, and same thing for the intake for a maybe 80 something millimeter or 280s for like elongated, but server, flat style PSU at the bottom, right, where that allows for me to, it's not too thick, but that is my intake, and then it goes off and exhausts, both at the front or off to the sides, right, and or directly in the rear, right, depending on how you want to do that. But it means I now have intake taken care of, it's fresh, and exhaust won't have that come back in because I can flip it around and have it be vertical, right? And that way the exhaust that's going, out the PSU is taken care of and it goes out. But this is the other secondary caveat. If I wanted to be extraordinarily compact, then the PSU goes above where the GPU is. It's on the same side, right? It's still gonna have to be flat, okay? Instead of the loud, oh my god, shut up, you stupid fans. I hate these fans, but like big 80 whatever millimeters, right? And then that allows for either one or two. It depends on what you want to do and how much power we're talking about that you're trying to put into this, and you might want the GAN style of PSU. So that will handle higher heat load. So you can probably get away with just the one, and then it blows out, or you can have it, because that's the thing. I'd do it modularly. Like for what it's worth, I would either have it suck in air from inside the case, so that way I'd have the ITX a little bit lower, and then I'd have the, I guess, square. I mean square because it's yeah. So, but that means I can get it down lower, and then I can have the graphics card around there, right? And then that's a big, square, however much it would be. Like I'm looking for that 200 or whatever 180, that kind of thing. Really, I need it to be big, but then I only need the one fan. That's it, just one. That's all I'll need, and that also means I can separate the air intake for the blower as that can extend a little bit, right? So that means I can have it from the rear of the case, the other side panel, and then I can have it from the front panel, as a separate duct that goes into that. So, or at the bottom, if that's what I wanted, right? But that means the bottom is no longer going to be used for that exhaust. So I'm thinking whether or not I want to have that curve back into the PSU area, but I don't know. I might want to just have it vent for what it's worth. Yeah, like, See, I'd have it as a duct. All right, so I'd have it vent off into that little, like a little chamber that would then go off to the side, right? So it'd go off to the rear, the other case panel, but over towards where the PSU, towards the front is, and then it'd have the rest where the motherboard I/O is as the vent, right? So it'd go down and then mostly go out towards the motherboard I/O is, and a little bit off towards the rear, right, towards the side panel, right? Same thing for the top. Like the top would have like enough go over to where the PSU is, and it would intake from that, and then it would, right, vent outwards like a standard blower. But also some of it would just go up the top and then off towards where the motherboard I/O is, and a little bit, no, because there's a PSU there, so I can't do that. So there's that. But that should take care of outright static pressure and flow and efficiency and compactness. Like this would be very compact while being able to cool in a massive way many very high-end CPUs, which would be the whole benefit of this, yeah. But it also means it's like, yeah, I'm gonna have to get the cables that are hardline for this. So like if I were to ship a case like this case would have to have the PSU already there, and it would have to come in with hard cables. So they are statically fixed. They would be able to get moved, kind of like, from joint areas, right? But they're hard for a reason, like they're static for a reason, because that means it looks cleaner and I can place them in areas that will help with uh, just putting the case on. Um, as like I'll have like little rigid rods and bend areas that are the sheet metal stuff that would allow for you to then put your case together and do like a little slide, a little bolt, thumb screw stuff, right? So that way it'll work better and it's more compact. So, but that's the thing. It's like I'd have to make the PSU, and I'd definitely have to make hard actual cables because no, I can't have cables that long. There's no way that that would work. I would never sell someone this case without like making sure that they had the right length cables. They have to have the right length cables. They have to be able to use this with those cables as well to make it stiffer and structurally safer, sounder for them, right? And it looks cleaner and it'll look uh, well because I can, you want to pay a little more, I'll give you some bling. Here's some like RGB cables over here. It's got the nice little RGB fucking cables here. Yeah, it's doing the zappies to the, it's really going hard, and it's got a nice little like program to basically show off that you're sending power to this, doing this, and is ramping up to however many watts it is. But that would look super cool because they're like tracers on the cables, right? That are light, and that'd be blinged as fuck. So I love it. Oh God. Yeah. How much would you want for that? Yeah, well, that's a good question. I'd probably end up having to make you pay about $350 for that. Yeah, but like that's pure just case. So like with the cables and with the PSU, that's probably more like that 420.69 for memes because I know for a fact people will pay for it just for the memes. So 420.69. I know they would pay for that. I know they're gonna pay for $420.69. Just saying. But considering $350 to 420, right? It's a fairly darn good PSU with cables for fairly cheap. So, and you get it blinged. You don't want it blinged, and of course, you're only going $400. So that's $50 for that. Yeah, I know. Yeah, that's because you can't find the case. No, if you go directly to our site, you can find the case. Which I know you won't do. You'll probably go to Amazon or Newegg or any of the other ones. I know you'll probably do that. You probably are going to be fine finding whatever PSU you want, or you'll buy directly from us as the only PSU provider for this given case. Directly at our site or on any of these things separate, which will be more expensive. Oh yeah, no, it's going to be more expensive. So it's like, no, I guarantee you're going to buy the hell out of that $420.69 case for ultra efficiency and compactness. Very well. I have to insulate it, right, for the motherboard. plate where it's held on. So it needs to be PTFE or something similar with a metal backing. But I prefer glass, but glass is just going to break, so I'm not going to do it. So yeah, that's what that is. Aluminum would be really nice if I can get it cheap. Aluminum's still fairly expensive. So it's what it is, and then that turned into whatever the cheapest, like either steel, aluminum, ultimately speaking, in between the PTFE would be that. Yeah. So um, that'll work, and then it's aluminum outside, right? With steel stiffening it in the right areas, so that way it looks nice. It's going to be understated in that sense because I need to anodize the outside and still ultimately have some small little windows, either at the front, and if that's your version, or all of them, which would be at the front, and a little bit along the sides of where the fan is, right? And then that's also going to have the side panel case at the rear for the PSU. If you buy the PSU, it's going to have like a nice little, RGB that's sending with the tracers for the power delivery off to wherever it's sending it to, which will look really cool. Or you can have it with the uh, OLED kind of, screen there, which you technically would be able to use if you wanted to. It's not a 4K or anything like that. It's a 1080p, so have fun with that. But um, to each their own. That's definitely more expensive, and you know that. Like there's no cheap there. So at least with the LED strips, it's like, well, I mean, it looks cool and it looks really, chef kiss, mwah, looks good. Like you can see like the back case panel is just tracers of these nice, gorgeous, LED lit, hard cables that go directly into your graphics card, your motherboard, all of that, right? So looks dope as fuck for what it's worth. Um, so there's that, but there's always a but. If you don't want any of that, then of course it's only $400. Right. We were talking about the screen, like, what is this? Yeah, no, I'm not a big fan of glass because it breaks. And so that's kind of what that is. But there is glass there. It's glass on the outside, glass on the inside, sandwiched by a plastic that is polycarbonate. Thin glass. It's sheet glass. That isn't really sheet glass. I should let you know. It's a screen protector. Yeah, I literally called up the people that are like, screen protectors, we do them. I'm like, all right, so we'll just fucking stick this onto some fucking plastic. And it's good. As being clear wise, right? So it's hard. It's stiff enough. Why are you saying it like this? Because I don't like glass. Glass sucks. Glass is heavy. I hate glass. I hate glass. So that's the reason why I'm basically trying to avoid talking about it, because like I don't really want to even give it to you for what it is worth. So, but that being said, also for what it is worth, the intake and everything is going to be a static kind of like sort of shroud intake with the filter, so that way you don't have to look at that nasty fan spinning. You don't want to look at that. No. But I'm going to move off of that real quick to how stiff is that? Because people will wonder. Obviously, everybody's going to wonder. Well, the panel has to be the aluminum and steel panel on the outside with the glass there on the inside with a good separation in between So that way it clearly displays your graphics card shroud nice and looks, love it, you know, uh, except for it's with the understanding this would be the blower. Shoo, that sucks in that sense because it's like, well, I have this one and it won. Okay, then I'll make it support the 4 slot behemoth bastards. Let's give you a thin screen. You can see through it. And then I hate it already. Do you really? Yeah. Well, it's gonna be fine. I'll just put some lines, some vertical lines there that are like nice little eye channels, kind of like the hourglass thing, so that way it goes through, and then you get the screen there. It's just gonna slide, with the little magnetic thing. So that way it'll look cool. But the reason why is because like, well, there's a hub there, so I'm gonna put the hub thing. I'll have like a little X or like a cross. I wonder which one I should do. Because I want the hub. Like, it's worth it. It stiffens it up. It's totally worth it. I mean, what are you really going to see except for like at the top there? You'll have like the little screen again at the top, so that way you can see it's a GeForce or the Radeon, whatever it is, at the top, right? Which bothers me. But it's like that's where but see, see what I mean? It's like, no, well, I mean, they're just fans. So all you see is now fans. Like I got a small shroud. There's nothing really there to see. Kind of sucks. It's not really my personal, thing I personally like. That's the issue I'm gonna have. It's like, no, that's aesthetically not that great. So I'm all about that aesthetic and form with function. Like I like function. I love function. You can hear it all about and everything that I'm talking about right now. But it's like, no, form matters. So the fucking quad. Yeah, I know, right? Jeez. It's a rough one. Yeah. So get the screen right there would be fine, right? But then you can just make a bigger screen. No, but then they'll blow out. So I have to have that seal a little bit with like just a little scotch of like a movable kind of like rubber sort of grommet almost for a shroud. So that way it goes up and but it doesn't go into where the PSU is. So that way it'll go up and then it'll go over. And so like the PSU, have a little bit of that, and that's the air channel. Yep. That allow for it to go out. But it's like, no, I need that to go up and then I need it to go over and out from where the PSU is, but also up at the top and then where the motherboard I/O is. So that way it doesn't just look and feel terrible, but so also doesn't have terrible acoustics and thermals, which is going to be necessary for a 4 slot. Yeah, I know, right? And I want it to be adjustable so that way it's not just, the 2 slot, it can go up to the 4 slot. So it'll widen itself. Yeah, which means I have to get like another little thing that you have to put into the rear for like a little, yeah, it'd be like a stiffening plate, but you put it there, then you get the hand tight screw things, and then you get the 4 slot add on. But that means you also have to do that for the front and the top and the bottom. But doable. But it's like, oh, is that just going to be for things? Yeah, pretty much. Yeah, it's going to be a longer tube that they all connect to because like that's kind of like how it has to be based off of, right? And for the 4 corners, yeah. So, but doable. Now it's way more expensive. It's going to be like a $550 damn thing case. Why? Really? Yeah, because I I have to get steel. I want to get stainless steel, but no, I have to get steel tubes for that. Yeah, and then I have to get like the thumb screws. I have to get the whole. Oh my god! I have to make a PSU for you. I have to get all the. You know what I mean? So great. But that means it's configurable, it's modular, which means like you can buy specifically exactly what you want and need. That's also why it's more expensive. So that's gonna have to be what it is. Now, so he's got all right, yeah, that's fucking annoying actually. What is this? Airflow. We're talking air. So the one that goes off to towards the front is like, no, I just get rid of that air trap, right? But it's like, God, all that stuff at the bottom has to go somewhere. So I'm having to separate it a little bit further over to allow for it to go, yeah, into a separate channel that then joins with the other one at the top, but also with the one for the motherboard or area for like the big fucking square radiator that will then have that go in for the bottom airflow. It has to be done. It has to be separated. Otherwise, like that air, you know, goes back in, and you can't have that. So, but then it's like I need that to be mirrored, so that way you can see the cool light show, and it gets the infinity mirror kind of thing, and then you also get to see your shroud, right? And I got the nice air filter, right? I need it to be stiffer for that case panel, so it has to have, right, the yeah, the hub area, but it's like I'm just going to do an X instead of a wide hub. It's going to be more of a circular hub that has more of that. Instead of an I channel, it's more of a uh, double arc. So like they'll kind of like your tibia or whatever for your forearm. So like it's wider in the center, and that's hollow, kind of like a cat's eye, and then it goes off to the tips, yeah, the taper, and then you get like the circle that's there, and then that'll allow for me to put on these little waveguide things that are there that'll stiffen it up, lighten it up, but also reduce noise for air intake. So they'll bend in a little bit towards where the and be rounded off towards where the fan filter is for the case. That way it presses it against that and it makes it stiff and seal better. So that way sounds good, looks good, performs well, and it's just stamp effectively. It's a sheet, like a little steel sheet, well, aluminum, but it's steel from the other outside. But anyways, stamp and you know what I mean? Like it just round off some of the corners effectively, and it's done. Super fast, cheap, efficient. That way, it's not $1,000, and I thought you had to CNC something and all this. Nope, boom, it's done. Super fast, super simple, super cheap, super effective. That way I can actually sell it to you for a reasonable price, considering it's a tiny ass fucking case here. Yeah. All right. What the fuck? Oh god. Yeah. It's the modularity problem. Yeah. It's like, no, no. Is this your graphics card? All right. So then you're gonna want this side panel instead. You're gonna want this. You know what I mean? Because it's like that's $550 max, no matter what, right? But it's like you can get it down to the 420. You get the blower style, right? You find one of those. Right, that's real small, compact, super simple, cheap, easy. Yeah. And then that basically covers the entire intake for the big radiator at the front. Almost. Like I do it right because it's like, no, I want you to be able to see in there. Right. So it's like that's the stiff, kind of tensioned is what I'd call that. Yeah. Panel. It's plastic at that point. It is plastic. I'm not gonna lie, it's plastic. It's a slightly thicker plastic. Sure, it's not super thick though because of course I did the thicker kind of like phone screen thing protector. So and then it's tensioned, right? I have to stretch it a little bit. I have to right. So that way it goes into these little grooves, holes, and we stretch it a little bit, and it feels real solid. Yeah. So that way, it's a structural part, and it's less likely to break, which is the whole point of that. Yeah. So it's lighter weight. Yeah. Wow. But that's the front, and that's the rear. It's like, well, you don't have to have that, PSU scene, right? But all these little tiny little windows here that are gonna be there, right? With like stiff aluminum, it's fairly thick, right? And I can cut out some areas, right, for the windows, but do that little trick I'm talking about for the plate squish, kind of thing, right? And you cut out some of the areas as a result, and then that makes it stiffer and lighter, right? Um, but then, of course, I have the steel rods in the right places, along with the coated, most likely it's going to be steel that's bent like that for the center core for the motherboard, and the PSU ultimately are based off of. So stick that down there, bolt everything, quick release for the side panel. So it's like a side panel to the side panel. So that way you can take off the side panel, with your thumb screw, and then you can quick release with a little latch, and then you can take off your radiator. So that would be super way easier. Same thing with the shroud kind of thing, where it's like you stick it in, it's got a little rubber grommet, and then that allows for the intake for your blower, if you get a blower. Fucking love blowers. Blowers are way better. I hate this 4-slot stuff. It bothers me so much. But would you do that? Oh, for like a 240 or 280 millimeter GPU cooler? Oh, absolutely. Yeah, because I could just instead it would be like right where the PSU is. Yeah, like literally it'd just be the same thing. I just stick it right there, put it with a single slot, and then well, technically speaking, right? How thick is the PSU? Mm. Right? Like, how thick is it? Because like if it's a single slot, then it's like how thick is your PSU? Hmm. But you would know. It's like I do know, but it depends on where you can place it based upon your motherboard. Different motherboards change where I can place this. If it's very small, I'm able to essentially get away with this entire thing being in between both of them. Which means I can get away with the entire thing being a whole nother, square radiator, right? But if I don't do that, okay, then I would be able to sink it further in, but of course that elongates where the motherboard and the GPU is. So that means I can't get the 280 or the 240, but I can get a 120, right? If you wanted to not elongate it. So then it turns into, okay, so yeah, exactly. It's like, oh, I can have that down lower and I can get it like, a little bit lower over in between. Or if I wanted to, I can have it slightly higher up and get it right up next to it and then compact the single slot or dual slot, right, blower style GPU. But the moment I want to put in a radiator, it gets thicker. So there are multiple PSU types. There is the 300, the 500, the 850, and then the big, massive 1500 watt. So, have fun, right? What's your PSU? What's your motherboard? What's your type? How'd you do it? I don't know. I could technically get it. It's so close. So I suppose if I wanted to, I could get away with kind of doing a dual PSU and connecting them together as a dual 300 that would allow for the uh, mother motherboard to send off to a separate, GPU platform, right? That goes into that, kind of like what we do for mini PCs, right? And that would allow for me to get the 300 for that, or 350 for that, depending on like, well, not 350 because I'm selling it as a 300, but you know, dynamically play with that because you're technically combining them, but you're not technically combining them. You know what I mean? Like you're combining the two PSUs, but they're working off of the same trigger for both of them. Like the motherboard or the little uh, PC B, right, is connected to the motherboard like that, the same kind of way. So when you turn that one on, it'll turn that on, and you only need to have the one button for all of it. But that means it can't dynamically share all of the load, which because they're PSUs that are kind of dumb. So um, what that means is if you had like let's say it was a 300 and 300, then it's a total of 600, right? But it doesn't take 300 to run your CPU. It will try and use the rest of that is what you're hoping for, but you can't set it up that way. So what you have to do is go, what's the power amount that you're going to do for your CPU or for your GPU? Roughly, basically. Yeah. So it would turn into, for me, a 500, which is fairly darn small, and then I can get a 300, basically, in a very small, tight, compact space just below, right, where that empty space would be and have been. Because, well, yes, there's a little, PCB there. There's for like a shroud or any of that, right? There's still space there for a PSU, which, yeah, sure, it's not going to seem like a lot, but it is actually because I can extend it all that way with a GAN, right? And then have that PCB basically right on top of that. So that means I would then be able to get away with a 300 to 3 or another 500, right, PSU for that GPU while still having the 550 or whatever it was I said, for all of that. So that also means that I'm going to probably have to get like let's say it was 300 watts or whatever, right? For just the CPU, okay? But the motherboard or whatever takes up like an extra 100. So I got an extra 150 or 100 watts that I can send to the GPU, right? Now, that's what I'd have to do for what it's worth. So that, yeah, no, it's like, well, it's going to be thicker. So it's like the thickness of the total volume would now be what allows for that. So like before, it's like, well, I had the shroud, I had the whole thing, so I was gonna have to have the radiator there anyways, which now then means it's like, well, the PSU was fine, right? Like it was gonna be that kind of thick. It's gonna be about the same size of the thickness of the GPU, right? So not too difficult. But then it's like if you think about the total bottom area thickness, then it's like, oh, that's another PSU. So that's a whole nother 550 or more watts if you really want it. I mean, you can get up to 1500 for some of them. So that's what that would be. It's like, well, I already need the air intake, shroud for the four, right? So, or well, not the shroud, but the exhaust, right? As a result, that allows for me to suck it out right there and blow it out right there. That means I have both the top covered for that I/O, kind of thing, but also that's the radiator motherboard, right? So sucks it out now and just blows it out off to the rear, right? But that's a probably like 80 millimeter, I think at most is what that would probably end up being, or something similar to that, like the same thing for, or yeah, GPUs, where it'd be like the 60, 70, 80 millimeter or something like that, that I could stack in three, or just the one, right, and then blow it out towards the rear. Or just two, right, and then I could have it blow out towards the front or blow out towards the rear or both, kind of thing. Personally, I'm a big fan of just the one and then blowing it out, as you can clearly tell, right? So that's probably what I'd do for my PSU, right? I'd get remember that blower style I was talking about, right? It's like I'd get the same thing for my PSUs, right? I'd suck it on one side and then I could just blow it out, right? And allow for it to go up, out the rear, uh, and that'd be fine. I'd just get the blower style hub kind of thing for the top and at the rear for fans, right? And then I still have the PSU at the bottom that helps also as well with the standard blower style. So like I suck it in from the sides and blow it up at the top and at the rear. So that's all I would probably be doing, just because that means I would be able to get away with the 280 at the bottom. Now, finally, like genuinely, I'd be able to do it because I'm able to shrink the top. Is it like wait? You're gonna have a triple or a quad? Is that like a 350, 400 some watt? What is that, like fucking GPU? I need to have that pump too. Um, so what's that? Like honestly, I just right? Well, okay. Which then turns into like, well, two 550s will be easily able to handle it completely for 1,000 watt. Right there, that gives me my pump, that gives me my motherboard, that gives me my CPU, that gives me my GPU, my RAM, everything. And I got my radiator on one case, side panel, and then the other case side panel, and then those will disconnect. It's going to be just as compact now as the two slot style blower, but that's because I'm filling up the entire space effectively for that. Yeah, it was like that. It would be a 280. Yeah, it'd be a 280. So I'd do a 280 and it'd be right there. I'd have to make sure it's a little bit on the bendier kind of side with like some movable joints, for that, and quick disconnects for that. But now I can stuff it in like that, and there we go, right? Because it's basically the same size. Like the 3-slot quad for thickness of a radiator, and then the 140 yes phaser. I get it. This is my dog. That's made for something. Anyways, thickness wise will fit into that. All right, I am able to do it with the 2-slot, right? But I am going to have to use standard fans, and that's it. I mean that, like, I have to stick it in a little bit closer. It's going to have to go a little bit further, higher up for the case, right? Versus a little further down. Oops. This is why I don't like throwing things in there. So I'm going to have to stick it a little bit in between where the PSU and the GPU is. Well, the GPU in between where the motherboard and PSU is what I meant to say. But that'll be fine. I can do that because then that would allow for me to then get everything situated over to where the radiator is a part of the case panel, right? And still have the thickness that I need to be able to do that. But that also means there is only a single, like yeah, like there is no, yeah, at all. I'll leave the vent there, for sure, because like that'll help out with cooling, yeah. But like, it's like, hey, I see a fan there, yeah, right. It's like, well, it's not that bad. Yeah, it won't be too bad. I got the filter, and then I'll have like a little gasket that'll connect to the block, so that way it separates. That way it goes off into the blower, and then the intake also at the top, right? And then the rest of it, that's just a straight vent to the rear, which will be fine, and then rear as well, also up towards the top, right behind where the PSU. So that way I'll have the PSU be a little bit separated towards the rear, and there'll be a little bit of a channel there, and then a little bit from the actual case panel. So that way it can go up and then out, and then also towards the rear for the motherboard I/O. That way it has more than enough space for it to fully vent quickly enough. Now it's just as compact. It's a dense fucker though. Oh yeah, it'll be heavy. It's so heavy. How much does that one cost? Oh yes, big elephant in the room of cost. Well, do you want the bling? It's $550. Of course. Do you not want the bling? It's $420.69. There you go, because I already told you what it was. So there's that, and then I don't know. Give me a second. Alrighty, so the case, $550 for a 1,000-watt PSU. It's like, well, would you buy it? Well, yeah. There you go. Look at me. Except it's not really 1,000 watts. No. You get two PSUs that are 550 watts or some shit. I know you'd buy that. I know you'd buy it with all the bling and everything. But would you buy it for the memes? Damn it. I'm just saying. I'll probably do enough volume to not have to worry. So that's what that would be. But if I'm not, it's like, alright. Well, you know, I can always just make my own GPU, make my own motherboard, make my own entire complete system. Instead of making it like that. Yes, I am eating. And I've got everything into the dryer. So that's good. I got one more load to do for laundry. So there's that. But, alright, so I'll make a system for you. Right? It's like, alright. $2,500. You want a 4090 Ti? You want 1100 watts? You want a 280 cooling radiator for your graphics? And you want a top of the line CPU that has like effectively a 200 millimeter, square radiator. I want my custom fans. We want my custom hard cables that have cool tracers in them, and my PSUs, which also have the cool, whole thing basically. Right? We want it to be stiff, strong, long lasting, all that stuff. Still, you ask me why in the world you wouldn't pay $2,500 for that. It's like $2,500 for a fucking 4090 Ti. It's not, but it fucking feels like it. It's insanely expensive. So there's that. Or the top of the line Radeon, which will be appropriately priced as well. How the hell do you bulk the fuck order? Like, it's basically what it is. Yeah, I have to do that. It's like, yeah, so I have to make my own PCB, and I'm gonna have to order the memory. I'm gonna have to do all that. Because I have to be more than just a system builder. I have to make a bespoke style of GPU, and have to become a GPU manufacturer. I have to become my own style of assembler, like an Origin, CyberPower, Digital Storm, any of that, right? And it's like, no, it should be way more expensive. It's not, because I know for a fact that consumers are stupid. Not really, but a little. It's not a huge system. Look how small it is. It's so small. Oh. Mm-hmm. Mm-hmm. Mm. It's the top of the line fucking shit, you dick fuck. I'm gonna do a direct die cooling, because that's how I roll now. Genuinely. Yeah, I am that guy. It's like the moment it's like, okay, I have to make this for you. I have to make my own. No. No, no. So the RAM is going to have to be like basically side slotted RAM, right? I'd prefer to literally just solder it. Like I'll if you want it cheaper, I'll solder it for you. Like I'm not gonna have any upgrade path for you. It's gonna be this 64 gigabyte or 128 or 32. You know what I mean? It's gonna be this amount, but it's cheaper now. You know what I mean? No upgrade for you. Suck it up, right? Like literally. But also on the other side of that, it's like it's better for cooling. I can literally make it so that way that the GPU can now be effectively sandwiched in between and on the other side. So it's like I can solder on the RAM, I can solder the CPU, direct die cool as a plate effectively on one whole side for your VRM and everything. And same thing for your GPU, where I'll just connect it on the rear and then spread it out a little bit for certain things. But then I have to do a little bit of kajiggery for programming, right? To make sure that it knows where things are, what's going on, how to best use everything, and how to have it all talk to each other with the motherboard, BIOS, and power delivery. And it has to be a little bit thicker. I get it. But still, it'll work, right? And it's like, all right. And then like, shoot me that figure. And it's like, oh, yeah, no. 1 second. Here's my big old 1200 millimeter blower. What? It's like, yes, you see my issue with myself. I have that issue with myself. So it's a genuine thing. Because it's like it's not necessary at all, except technicality wise, it's slightly necessary. You know what I mean? That problem. It's like, no, I'm going to use that like big, huge turbine fan, and it's like, no, right? Yeah. Eh, well, it depends on what you want to do. It's like, it's still going to cost you a decent, pretty penny. Yeah. Because it's not a cheap GPU in the slightest. And for what it's worth, the PSU is now effectively going to be what is the equivalent of, well, screw it, man. It's just going to be attached to the whole fucking board. I'll just fucking do that. Why wouldn't I just do that? Yeah. So if I have to build it anyways, I'm just going to literally manhandle the motherboard into being slightly larger and just make the PSU a part of the whole thing. So that way it's on both sides and I can easily deliver power perfectly as I need to. So, and it's like, oh, and there's this plate that I have to make. So, good old poly crystalline diamond and some steel and some aluminum that I slap together and weld and all the rest of it. But it'll look good. It'll be incredibly good looking because I'll make sure that I get the right translucent and transparent areas for all of the nice little cool tracers of where the electricity is being sent, the cooling, the flow, all of that looks really good. Okay. Now the reason why I'm talking about a blower is the very definition of like, yeah, no, because I'm going to put something at the rear so that way you can lay it flat. That way you can have a radiator effectively suck in as an impeller design for all intents and purposes just fine, and it'll just blow outwards, except I don't want it to blow just outwards. That's my problem now. So it's like, wait, I thought you wanted that whole blower, and it's like, see what I mean with I'm designing currently in the moment. So it's like, all right, well, then it turns into, all right, well, I'll suck in air, but I don't want to, see what I mean, right? I want it to be seen, right? So that's my problem right now. I need it to be seen. It's supposed to look cool. It's supposed to be seen. It's supposed to be a part of the cave panel, is what I'm seeing there. That is correct. It is the case panel. The case panel is the actual fucking components. So it's like, what is this whole thing? Is it a bunch of radiators effectively? Ooh. For what it's worth, yeah. It's sucking in air, right, from the four sides, right? That will be a bunch of radiators. Then it goes into the blower area, which is technically a blower area. It's more of a fan kind of style of area, right? But that allows for me to get stators in there. That allows for me to then have a secondary fan that is, well, not a secondary fan, but it's just a 200 millimeter fan. Is a good way to put it, but it's like it needs to be attached to something. And like for those fans or for those radiators, for that matter, because I don't want them to be very thick. I can't have them be very thick. They can't be that way. So like they have to be attached, to this side panel that's your PC, right? So like that has to have it up at the top and it has to seal properly. So it can only be so thick, right? And then the fan has to be attached sideways, right, to four corners. So like those then have to be elongated is what you'd have to call that. Yes, thank you, Phaser. Right. But it's like, how do I make a blower work for that? And it's like, you don't really. See, that's the thing. Right? So it's like, no, I'll suck in air from the sides. That's the impeller. And then I'll blow it out the sides. That's the blower. Right? For the bottom. But then I still have to have a case panel, which is another radiator. Which, shocker, has to be there. So where does that come from? Right? What's that design? Right? So that turns it into, all right, well, I can start from, and then I can, yeah. Blow out the sides. Very simple to do, actually, for that matter. But that's depth, effectively. All right, there's stuff that goes from the sides, from the center outwards for the fan blower combo. That's what this will be. It has to travel further in, and then it has a separator between the two that'll have from the outside, and it'll try and suck it towards the center as a different blower style. So from center out approach, that then blows out to the other radiators, and then the out towards center approach is then the fan approach for the bottom rear fan, which is the case radiator side panel fan thing, but it'll work just fine. That's not the issue. In fact, it would be ridiculously efficient, which would be great. It's the fact that I have it on the bottom now, and that bothers me. So, and I'd rather have it at the top, but then you'll never see your cool computer, which will bother the fuck out of me, actually. Like, I spent this amount of money for this. Yeah, so I, put a nice, like, little genuine. No, instead of acrylic or any of that, this is because you're willing to spend the money for it. I'm going to give you an actual sapphire, yeah, case side panel window, which it's like sapphire. It's like, well, they're fairly cheap these days, depending on what we're talking about here. You know, um, so there's that, but like it does depend pretty heavily because it's aluminum oxide. You know, it's that thing where it's like, well, sapphire is supposed to be super expensive. Yes, when it's from the ground or whatever. This is just an artificial sapphire thing. So, I suppose I can make it cheaper by instead deciding to do something else with it begins with an M, but it's hard like diamond. It's not diamond, but it has a bunch of fire in it. They call it fire, so it has a lot of refract, right? And it's like if I mix that together with some sapphire, right, and then I make it a little thinner, but like they're in pieces, right? So layers, and then sectioned, then it's cheaper instead of having to build a whole huge piece. It's like, well, they have these sizes, so it's like, oh, well, that's fine. Do. Done. It'll look really cool, very clear. It's hard crystal. It's thinner, which is nice. It's able to be rounded a little bit. Not much, but a little bit, because every little bit will count on that. Because it'll look nicer, you view in more easily, and sharp crystal sides are dangerous. And they like to break. So new. It'll look nice as well for all the LED that is there. So that's what that would be. And it'll protect it, which is good. So it'd be fairly cheap too, which would be nice. Except, of course, it's all going to have to be artificial. So nothing too thick though. It has to be thin. They have to be very thin. So I'd have to layer several of these like phone things, right? Along with basically the same kind of thing for the refract, which is not good for phone screens, but amazing for other things. I'm thinking about that for like diffusers or whatever, for like beam splitters and diffusers refract. They use Lorentz lenses because it would help with like breaking out of different wavelength frequencies. But I'm gonna move on. Um, that would mean I can then stack them in different ways. They probably have Anyways, that is probably like a $200 screen protector for what it's worth. So like that's probably majority is ordering all that stuff. So it's probably going to cost about that much. It would be too difficult. But if I wanted to get away from that, for like absolute maxed out, instead it's like I'll give you nice tempered rounded glass panel that I guess is okay. It's okay, I'm just gonna be honest. Yeah, it's not gonna look as cool as that, so it's okay though. But anyways, see here. All right, the back. Right. Um. That one's fine for what it's worth, mostly just because it's the outside from the center point. That's a type of blower design, yes. But then like thank you. You're such a nice dog. Really, you just want to play. Anyways, let's see here. Well, that's the separator. You have to have the separator for like where intake's at the center and it has to travel versus at the bottom, right? Which is a shroud, which I'll have to suck it in from the outside, or yeah, from the outside to it back towards the center. So it'd be a reverse style. It's still gonna spin the same way, but like different air channels for the air blades that, as they spin, effectively make it so that way they spin and move the air correctly towards where you want it to go. So that's what that is. Simple stuff. But the only reason I'm talking about it is because it's like, well, I need that to be structurally a little bit stronger. So I'm going to need to get like the aluminum, nice little, plate aluminum. Get it, anodized after brushing. Just a little brush, little anodization. Make it look really nice. And then you get the nice plate, and then everything really kind of falls into place after that. Because it's like, oh, yeah, well, yeah, no. I mean, it'll work. It's gotta work, right? It's where the hell do I put the damn air from the, fucking, like, I can't let it go. Like, I don't like the air just, going towards the bottom. It's going to go right into the intake. I don't want that. So I'm going to have to make a little tiny shroud, for it. Then basically like covers it and has it go off to the rear. Thank you, Phaser. Yes, with your little speed. I get it. Okay. I was eating. I'm still eating. I didn't even finish my food. But of course, you want to play fetch. So, love you, though. Your squeaky toy. You know what? Get a different toy, and I will absolutely play with you. Because, no, get your other toy. Let me pause this. So I started eating, and I successfully switched to a different toy. 4 hours in, still designing. Takes no time. There's no work at all to it. There's no effort. So easy. Anyways. So, shroud, right? Yeah, I don't want to do a shroud. For what it's worth. I mean, 4 of them. Do I even need the extra case thing? Not really. I mean, it's really about shrinking everything for what it's worth. I mean, yeah. It's like, no, I mean, well, yeah. I don't really need to do much. It's like, well, the cord that goes up to the PSU, that's pretty simple. In fact, most of it's pretty simple, for what it's worth, yeah. That'd be off the one, and then it's all traced from there, so I don't need anything after that. Then, let's see here. You're avoiding the shit out of like talking about, yeah, a little bit, yeah. Just a small amount. I just don't want to really talk. Like, for what it's worth, it's like, well, a smaller radiator, instead of doing like the double, right, I'll just use like the maximum turbine thing they talk about with like the extra, pressure, right? Instead, it'll just go straight down and straight out. That way, I could just keep it vertical instead of laying it flat. Because, like, if I lay it flat, then it's better, just in terms of acoustics, for what it's worth. Although, you don't need to, but it's going to blow out, So I just get, like, a little shroud that would go with the direction of the air blowing out. Right. And then that would cover all the bases. So you just lay it on like a standard tower. That kind of thing. Except I could significantly reduce the amount of speed that it needs to ultimately perform its given, cooling from one single fan. It's just one fan now. Everything would be run off of one singular, easily replaceable fan. and a pump. That would be pretty easily taken apart and replaced too, for what it's worth. But, you know, people might not agree. I know, they'd probably want it to be much wider too. They'd be like, no, give me extended ATX. I'm going to put the GPU right here. I'll put the fucking CPU. I want it all on the one side. Yeah, I don't want to do that. I don't want to do that all in any aspect and or way. I'd rather just stand it vertically for what it's worth. Like, if you wanted to see both sides, I'd just stand it vertically. Right? I'd just do that. And then I'd have the air stuff, instead I'd just turn it into one singular side intake kind of thing, and then it'd just blow through one single solitary actual like big boy chonker radiator and cool everything. Getting close to thermals though. Somewhat, yeah. I mean, there's a reason why I want 4 of those extras, but it's not that bad. But it's a 4090 Ti with the 1500 watt PSU with a, what is it, 256 or whatever it is that they have, right? Like 128 and it's 256, right? DDR5, whatever. And fuck that. I'll go with HBM. I mean, if I'm having to do this for you, then it's like, I'll just make my CPU have HBM RAM. I was like, do I need to? I was like, nah, really? No. Yeah. The answer is yes. The answer is also no. You know what I mean? For cooling, it's a lot nicer just because it's really pretty small, but it's not like the DIMMs are huge for what it's worth. I just want more speed. I want them to be able to do a lot more. Because if it's an AMD, right, I can have the chiplets a lot closer for what it's worth for the design. And that helps out outright with like total cooling, but also performance. Because I have to literally, instead of put it on a chip, I have to solder this fucker together. So I'm going to make my own PCB, my own kind of design that I have to do. Which makes sense, because I can now have them effectively opposite on either side of each other and right next to each other. So that way I can have the CPU right next to the GPU and the CPU for the other side right next to really, really fast memory that I can put with a bunch of VRM on both sides. Right? And I can much more easily balance everything while allowing for a higher degree of thermal efficiency and transfer rate of any given calculation for bandwidth. Yeah. But it's like, oh, you want me to stand it vertically for you? You didn't say how much it is, about $5,500. Bare minimum. So let me go that hard with HBM2? Yeah, it's about $5,500. Like, come on, really? It sounds cheap. Just, I'm gonna sell so many of these. I'm gonna sell so fucking many. It's not even a joke, though. I know. Like, for what it's worth, it's like, no. You have a what? Yeah, top of the line CPU and morning to you, right? That's just ridiculously over the top. Yeah, well, kind of. For what it's worth, it would be. It's like most people don't need a 16 core, 32 thread, right, CPU. They don't. But for those that do, okay, sure. But otherwise, no, you don't. Yeah. But it's like, here's HBM2. For your RAM that's soldered right next to it. Yeah, on both sides. Right? And then I still have your DDR6 HBM kind of hybrid, HBM2 or HBM3 or whatever it is that they're at now. Right? For both of that. Right next to itself with really good power delivery and It's about as good as you're ever gonna get, but it's effectively like a monoblock. Yeah, I have to squeeze the two of them together. Yeah, but it's cooling my GAN PSU as well. So, you know, the standard elephant in the room is it's a fully complete package. Here's the one plug. It's a bit of a chonker boy, but you know, dunk. It doesn't even make sound. Come on. I have to make some kind of a sound. Or what? It stops. Really kind of making much of a sound at all. That's a bigger fans for you. And this is cooling. Well, no, it is, but you know, we're talking about like polycrystalline diamond and aluminum and steel, you know, kind of stuff. But every time I think about it, it's like, wow, why don't they just like build a literal just that's my cooling or my heating plate or condenser or whatever area, right? Because I'm gonna use that anyways. That'll be my pump and compressor right off the bat, and then that's my phase change area, which I can stack effectively two radiators next to each other, right? In series, parallel, whatever configuration. I'm pretty sure it'd be parallel at that point, but you know, it depends on what you'd want, I guess. But that'd be one single larger 200 millimeter fan, and then I'd be able to still stack it vertically, so that way it looks pretty cool. And then you have the air intake for your fan right there off of all of that, which would be pretty neat to look at, actually, I'd say. But, you know, it has to go somewhere for the air, you know. So it's usually the elephant in the room, so to speak. I don't really want to put it anywhere, you know, that's going to go right back in. So, you know, standard wherever the fuck you want to put it. I don't know what the fuck you want from me, man. What the fuck? Here's an air shroud. Here's like this. What is this? It's connected to my fucking goddamn like window. Look at my window. It just cools every fucking. That's all it does. Never. Oh my god, it is snowing hard out there right now. That'd probably help out. Just blow it into that fucking room. But that's the thing. It's like, well, if you really want to go hard, yeah. I mean, it's a mini PC now. For what it's worth, it's gonna look ridiculously small and compact. But the problem is of course, it has a ridiculous amount of heat. Like it's supposed to get up to about that 1500 watts, right? So, you want an appropriate size cooler, and that's the real crux of any actual mini PC or any real powerful design in a small form factor. Cooling is the worst, and most of my designs, you know, utilize the basic principles that have stood the test of time, where it's like decent flow rate, good vent, good surface area. It's built into the very structure of the chassis, and it is effectively, you know, the whole thing as one, right? And that works very, very well and is incredibly cheap. But the moment you want to make something bespoke like that, which is what somebody would be talking about, it's like, I thought it was supposed to be cheaper. It was like, well, you know, this HBM and all that, so that's design. But like, if you wanted me to just do like the basic stuff, then I would be able to make it cheaper for sure. Instead of 2,500, I get down to about 2,000. So there is genuinely nothing. It is a solid stock. That's it. And the only reason why I'd be able to do that is because, pure and simple, I would be selling it where I could make enough volume of sales and profit on each one of them to pay that back. So that's what that would be. But it's also because it's like, yeah, no, you wanted me to spend $2,000 on a 4090 Ti? Well, I can get that and this top of the line CPU and the PSUs and everything else. So, meanwhile, the other side of that coin is also there's no upgrading. There's not a single thing. Like you are as fucking stuck with whatever that is forever long. You got it for. So there is nothing else going on there. And even then, like I would absolutely ramp that price up very quickly the moment someone wanted to do something outside of that bare bones, like this exacting design kind of thing, where it'd be like 64 gigabytes DDR6, or I mean DDR5, right? And then GDDR6 standard, like it's this is what they're saying it is instead of having to do all this extra stuff, right? And so it's like this chip and it's direct die, and that genuinely removes a large amount of overhaul of issues. So it's like this is a stamped, pressed, then laser, finished kind of plate of aluminum with the polyacrylic, I mean not polycrystalline diamond. Jeez. Right, and then there's some steel in the right places to make sure it evenly spreads out its mounting pressure throughout all of it, and it's not really ever meant to come apart. You know what I mean? Like that's what that would be, and so this would be wherever if you wanted it not to be as a, because this is genuinely very quickly how I would get that price down massively. So this is a little stand. You're gonna, I mean that it's a literal stand. It's gonna be vertical, so that way it looks cool. It's got like the nice little, little protective acrylic or polycarbonate. In this instance, it would be a inside and outside like the phone screen protector, but it'd be acrylic and polycarbonate, thin, plastic in between. It's just supposed to be like a nice little, protective case that's clear, and it's a vertical stand, right? And then where are these tubes going? It's like wherever the fuck you want to put them. You know what I mean? Like they're over there, wherever the fuck. I don't really care. Off to the side, you don't see it. Wherever you need to put them, that's what that is. Because that's all you're gonna get. Like it's that. It's a big, ginormous radiator. Sure, it's flat surface. Yes, it's gonna be the 200 millimeter. Sure, absolutely, right. But like that's a huge radiator, is what you'd think, except not really for what it's worth. Uh, there is the thermal headroom for that given size of radiator to manage all of that. Yes. However, we are at that limit for one of those little radiators. So, like, that's the 2000 that you're going to get, right? Like, $2,000, you get this. It's bare bones. You can't change anything. It is this exact thing. It is not changing, right? Some tubes, you'll have to put them somewhere else. You know what I mean? To the radiator. So have fun. It's not a built anything. There's no case here. Technicality wise, there is a case. I mean, because there's the case around it and then the stand that is. But wherever you put your radiator is wherever you put your radiator. You get the one fan. That's it. So, like, and it ain't gonna be my fan. Have fun wherever that fan might be. So, it's not. We're not gonna give you that fan. That's the point I'm gonna try and make to you. It's like, no, you don't get a fan from us. You get this, and you get a. So, I'm sure it'll work out though. I'm sure you can find a fan, like a desktop fan of some kind. You know what I mean? Like a little tiny, like Vornado or Amazon Basics or some shit that's basically the same size. Just stick it onto it. Get some zip ties or something. It'll work. It'll work. Be fine. But also, you know, um, it's exactly what it is. It's bare bones. It's $2,000. There's no screen. There's some LEDs, right? That's it. That's what you're getting. You're getting the top of the line everything. This would easily be like a $3,000 to $5,000 system, right? For $2,000. You can't change anything. You can't do anything. You can add in another line somehow, but that's a quick disconnect to the radiator and all that. You get a secondary radiator. Go for it. You want to overclock a little bit harder? Sure, go for it. Do you get better performance than most people? Probably. It's going to be a little bit faster, memory transfer, all that stuff. Yeah. But it's exactly this. You're not going to pay in any way for the fan shroud that they're having you try and use, or the heat sink, or the heat pipes, or any of that for the 4090 Ti. You're not going to be paying for the heat shroud or the die or whatever the fuck that is, case thing, fucking whatever it is. You know, like that's gone. The IHS, it's gone. Yeah, the heat spreader, the whatever that is, but it's gone. You're not going to be able to get memory that isn't just because it's literally just soldered on. So like the DIMMs are right there, right? The GaN style MOSFET, all that power delivery has to be there. It is stuck, statically fixed. It's going to have the PSU be board isolated around in a circle around the entire thing instead of, oh, it's just one little fucking like rectangle at the bottom. No, it's going to be around the top, around the sides, and around the bottom. It has to be that way. It's going to be a slightly thicker PCB, right? I have to get all the little chips, but overall, we're talking direct eye cooling. It will cool you better. It's factually the case. It will also ultimately have the pump at the radiator side. So, have fun with that. You can hang it off your desk. It'll be fine, most likely, for what it's worth. So I know for a fact you'll pay $2,000 for this. I know for a fact I'll sell a fuck ton. I won't even have to try. Are you kidding me? I get top of the line everything. This would be a $3,000 to $5,000 system for $2,000. So what if I have to basically just deal with a radiator that hangs off the side of my desk? So what if I, ultimately speaking, can never upgrade anything? Who cares? I just go buy another $2,000 system by the time I want to. So who cares? That's the whole point. So, yeah, I know for a fact you'll pay for it. I'll sell more than enough. And always, I know for a fact I'll sell more than enough. But, you're not getting a screen. You're not getting a keyboard. You're not getting the fan. You're not getting a mouse. This is as bare bones as it gets. You'll find a fan. You'll get a keyboard. You'll get a mouse. You'll get a screen. I know that for a fact. That's what that is. So, that's what I'd have to do. It'd have to go pretty top of the line in no way for other stuff. So it'd get the 1 gigabyte and 2.5. You're not getting Wi-Fi. Suck it up. That's it. I mean that. It's like, hey, stick a Wi-Fi card to it that's just gonna go connect to your Ethernet or some shit. Just do that somehow. I don't care how you do it. Figure it out. Figure it out yourself. Literally just do that. If I was the CEO doing this, I would actually put out a statement going, suck it up, you stupid retards of customers. You're getting literally a ridiculous, insanely good value to performance here. Suck it up. Get anything yourself. I saved you like $3,000, depending on quite a few different factors, but $3,000. I saved you $3,000. You can figure it out. Granted, it's unlikely I'd have to do that, but if I did actually have like people angry about having to pay $2,000 for this, fuck yeah, I'm gonna send that statement out. Are you kidding me? Fuck you. Get out of here. Leave it alone. Deal with it. Literally, as fast as it would be a thing, I would immediately just. I'm not gonna care. Go fuck yourself. But it's me, because the moment that happens to need like a fan, a secondary radiator, and then it's like, well, okay, well, I'm going to start playing with the HBM. I'm going to start playing with more chips, right, on there. So, fuck it. Yeah. Like literally that fast. It's just like, nah, screw it. Here's 5,500. Ah. Right. Like you'd understand pretty quickly where I'd come from that because that's like basically building an entirely new system. So it's not the same in any kind of way. Yeah. So, but cooling it's pretty easy in that side. It'd be just within the limit for a 200 millimeter radiator, like just within that limit. Yeah. So not too bad. Doable. But the moment I think about that, I'm like, well, what if I just decided to do something slightly better, basically? You know, like I'd have to get a reservoir pump combo, right? The moment I do that, it's okay. I got the AC, the AC cooling, right? Like I just, why not, right? I already have a 200 millimeter. You know, it's effectively take it from like these mini fridge, things, but then soup it up to actually run consistently, constantly, kind of thing for that. Upgrade the radiator surface area to a larger amount because like those mini fridges don't really have that. So it's basically gonna cool something that has to do it. Something not the constant. It'd have to do a separatory phase change. So I'd have to go through an initial cooling and then I have to go through a phase change cooling. So it'd have to be a hybrid 1 and 2 phase. So I know that sounds counterintuitive, but it's like it would be a better way to go about it. I'd have to get a different radiator, but the radiator would basically be one whole pack as a radiator. It'd come as standard. And I'd immediately jump it up to that $3,000 range. Yeah. So, but yeah, it's basically it's one radiator, but it's going to be split. So it'll go from one side at the front, that'll be one, and then it have to go through a phase change setup.
Not for doggies. Not for doggies. Nope.
All right, so it'd have to go from one side to the other side for the front, and then it'd be a split reservoir on one side, which would help with a phase change by reducing and making it larger tube. So like this would be a smaller tube, this would be a larger diameter tube, and I'd have to deal with fin density being the same. But because there is a phase change that allows for the tube diameter to go back to being a smaller diameter towards the other half of that radiator because it'll condense as a result. So that would give me the outright cooling performance I need for a big ass fucking thing like that. Except it's quite small. It is a mini PC, but it's the size of the surface area of the radiator. Because like I could get this really quite small. Like, and I mean this. PRM, all this, it would fit within like the size of like about 5 to 8 inches max. For diameter size. So really incredibly small. like genuinely. But the thing is that it's not about the size. It's about the fact that I have to cool this, and then you suddenly realize like, oh, there's this 200 millimeter size reefer that has to go somewhere, right? Uh, where exactly? So it's inevitably what the bigger issue is, seemingly, which is one of the reasons why it's like, well, no, I'm on the thermal limits for just water as a pump. But the moment I add in an AC with a phase change, so it's a single phase for the first part, but it's a secondary phase change for the next part, which that'll be like a Jules Thompson. So it goes from a smaller size to a medium size to a larger size back to a smaller slash medium size, which is a Jules Thompson style cooler, right? But of course, it's doing a phase change while doing that. So, which helps outright with efficiency and power consumption, but that means I need a refrigerant that's like a multi refrigerant, so multi gas refrigerant. So one of them would have to be a liquid, another one would have to be soda bubbled, basically liquid, so pressurized, into the liquid, right? And then another one would be a gas that's not going to turn into a liquid, right? So that allows for expansion to be increased from the liquid with the gas that's inside, that allows for it to then also still have the first phase gas that'll never change, but then that, of course, helps recompress it during its compression reservoir state. So uh, it's kind of like one of my waste heat generator designs that have to do a slightly different refrigerant type, but it would work and they would be safe for our environment because it'd probably be more oil and um, um, ethanol or like similar to alcohol style base, uh, with a gas that's more like, no, I can't do nitrogen or oxygen or any of that, but I could probably, no, I don't think I could do carbon dioxide. Mm. I'd love to do nitrogen though, but I'm scared of weak nitrogen bonds and then explosives that occur as a result. Um, so I'm not going to do that. So I'd have to do argon or something similar to a noble gas that is very unlikely to react, like a helium perhaps, something similar. So that's that's what I'd go with. Um, it'd be safe, it'd be efficient, it'd be effective. Um, I just have to make sure that the oil doesn't have any possible reaction with the ethanol or methanol or whatever alcohol ultimately we're using. So I'm sure that they have a couple of oils like that. It wouldn't be too bad. Yeah, but everything has to be in a lower pressure though. That's the main issue. Yeah. So nothing terrible, nothing too intense on that side. So that'll be fine. But I think I'll leave it there on that one, just because it's like, well, that would allow for me, but it's like a $3,000 fucking set. Yeah, oh, yeah, yeah. I'd take that cooling right now. Can I get that? God, like, right? Like, I already know for a fact that a lot of people would want to buy it just for cooling alone, let alone like, oh, would you be willing to just build me like a mini PC, like, hey? Which actually, I could probably do that for direct dry cooling. I might actually be able to do that, you know, um, for what it's worth, uh, where I'd be able to get the PCB and then just sell them that. Like you buy the whole bespoke thing for 3 grand, but then you have an upgrade path later for um, a just a whole new PCB. That it has to, of course, fit within the specification. So it depends very heavily, unfortunately, for the size of the dies and the placement of things. So, you know, which at that point, it's like, fuck. You know, yeah. So, but if it lines up, then I'd be able to do it. But otherwise, I would not be able to do it. It'd be better to try and make it more compatible by leaving the IHS and everything on. Yeah, honestly, it's a hard one because it's like no, that practically destroys the amount of cooling. Like if we were to go with Intel, Intel in this instance is a monolithic chip design, and I like those because they're really, really efficient for certain things in terms of calculation for speed. But for our everyday purposes, it's not that big of a deal. But when we solder everything together, it's like, oh, um, that's interesting. I can use that. I can absolutely easily use that, you know? So that turns into, yeah, direct eye cooling is like a 10 degrees C difference or something like that. Some craziness. So worth it, but also not. You know what I mean? It's like, what are we talking about? A few frames here? You wouldn't get it. Yeah, because the GPU no longer has to talk through a motherboard the same way. Power delivery is far better, and cooling is far better. So I know for a fact that the drivers are going to be changed, and they have to be changed to do this properly. Within the power delivery limits, which are all now known, optimized, optimal things. So that makes it so you can immediately jump up clock cycles, timings, everything. And that's a great thing in terms of outright performance. A standard Intel CPU that's their top of the line consumer kind of thing. Well, you'd easily be able to get at the very least 20% improvement. But you could do that with just taking the heat spreader or whatever off and direct eye cooling it and overclocking it, roughly, right? But the elephant in that room is, yeah, but it doesn't have this going on with it. There's a lot less electromagnetic interference. There's a lot less power delivery uh, interference and delay. That jumps up performance even further. So it's like, no matter what, I'm getting 20% easily just off of that stuff, let alone clock cycles. So it's like, I add in that, it's a 40% improvement on both GPU and CPU. So it seems like it's not great, but would you take a 40% improvement and you pay less money for it, even if you, in all actuality, can't ever upgrade anything? I mean, I think a lot of people would probably do that, right? So, geez. That's the thing. Like, I'm pretty darn certain a lot of people would buy the hell out of this thing. That would probably not be the issue I would have to worry about. Instead, it would be all about how in the world I would get from there to somewhere else. It's like, I'd be able to hit a market like that and saturate it pretty darn efficiently because there's a huge market. Like, if you don't know, there's a huge market for laptops that are in the $3,000 range, and we would saturate their market. We would destroy their market effectively. Like, well, why would I ever? I don't even. I hate lugging around this thing. It's kind of what that turns into because I can immediately turn this into an all-in-one. Like, so easily, like genuinely, yeah. It's the equivalent of like, I got a briefcase, some Dremel, I stuck in the cooler, right? And then I put a keyboard and mouse in the briefcase. I then put a screen on one side, and I'm good. Portable, all in one, super easy, cheap, efficient, fast, kind of done stuff. But right, like people that often buy that usually use it for the webcam, right? And the processing power it has and all that. For me, it's like, okay, so buy a webcam, get a battery pack, right? Get your keyboard so you can still use that, for whatever 3D, scanning or something that you need to do. And yeah, you have it on site easily. You can have a wireless keyboard or a wireless mouse. So you get a battery pack. It'll work. You have a higher degree of performance than what those $2,000 to $3,000 laptops will give you. And you don't maybe want the ginormous screen. You can still connect it to your phone. Maybe you do want that though, but that's still a small screen. It's less than $100. That was like $50 or something. You know what I mean? Like, right? Like, for all intents and purposes, you can dynamically set this up the way you would like to. It's a bit of a bigger battery bank, sure, I guess. Yeah. It depends on what you're doing though. Hard, yeah. Because like if I had 1,000 watt hours, it's like, right? But like, do we need do we, hmm? Do we need 1,000 watt? I don't think I need 1,000 watt hours. Maybe you do. Like you're really out there in the field, you need 1,000 watt hour. But like at that point, you have a backpack, right? Like you're gonna have a backpack with your your computer on it, and you'll just use like a basic like whatever glasses kind of thing, and scan with that or run your webcams or something, right? Like you'll just do that. It'd be far easier in all ways for that kind of a thing instead of having to lug around this ginormous fucking screen. It's annoying. But to be extra fair on our side too, to them, you are going to be lugging around a fairly decent sized battery and a backpack to suck air in and blow it through and all that. So potato. So there's that.
How you doing in here?
I'm hanging out. Alrighty, so stay here. Check out the lint trap and all that. I think I'd do that. Pause that for a brief moment. Yeah, backpack, pretty heavy for the most part. Kind of. It all depends. What's the battery life you're looking for? You know what I mean? Like the pump wouldn't be that bad for all intents and purposes for the cooling. It'd need to be a bit of a rigid cloth kind of bag. You can suck in air at the bottom and you blow it out. Or actually, that's a fair bit of a point of comparison because I like the battery at the bottom, right? That way, or at least near the bottom or at the where the back is, where the padding is, right? Because that'd be far easier. But then that's the camping type of backpack, where it has like a rigid thing. So like I'd be able to get away with like a couple battery packs in the rigid part of the backpack and then at the bottom. So that way it would spread out the heat dissipation because I don't want it to run too hot, right? So I can afford to not go as high on the total amount of use of each given cell and battery, right? But that also means I can get away with using I guess, probably no, because amperage would both amperage and volts are annoying as fuck in terms of like heat. Um, so it all depends on how you want to do this. There's always a balance there. So I'd probably try and convert amps just because I can usually get away with a multitude of series and parallels for a higher amp and convert it to volt. Still have a decent amount of amp, get a 200 millimeter and the pump, which I can then run more or less towards the bottom. But I can have the radiator towards the top, facing away, so I can suck in air from the sides, and then it would blow out towards the rear, directly behind you. It'd be a little bit on the rigid side. I'd have to do that, but it'd still have cloth, you know. All right, and you still have room to put things in if you want to. You just got to make sure that the cloth kind of thing in some of the rigid areas, like you cinch it essentially, right? Like you use some rope, you do the little you don't want to tie your shoe, spin thing that they have for like this cable or whatever that you can use to tighten up your boots. So kind of a similar story where you'll use the same thing to basically make these little ducts so that way you'll always be able to blow air out and suck air in for your radiator. But that also means that you can take it over one of the straps, either the left or the right, or both, really, depending on whether or not if you want like your camera for your lenses, like if you're going to use like the HUD picture screen and or like camera stuff, so or whatever it might be. So, and then the rollout foldable kind of keyboard. It's not perfect, but it'll work. Right. Same thing for the mouse, wireless mouse. Stick it in so like a little mesh, kind of side pocket. Turn it off. Stick it in there. Right. And then it's like, basic wireless something controller if you need to navigate any menus or something like that. Maybe a trackpad. Yeah. Oh yeah, like Valve's old trackpad thing. I love that. Truthfully, that would be perfect for that. Like one of those little trackpads. Be perfect for the hood for your lenses, sort of stuff. So, but that also means that you have like a top tier GPU and CPU. This is this is the mobile version. No, this is the full fat desktop. You're getting the whole 9 yards of, power performance. So, um, for how long though? That's the good question there, isn't it? But we're talking about like industry, like professionals and industrial applications. So it makes sense to kind of do it depending on like their environment that they're working in, um, because then it's not this cumbersome. I have to kind of like angle this and do the screen and then move it around like that. You know, like if they designed it into like a suit, so to speak, they'd be able to more easily use that to their advantage. Let's say it was like volcanic activity. They had to hike, and they didn't want any of this like even on until they really needed it. And it's like, well, a little screen and all that. Oh, that's great. It's a nice little compact everything, right? Until you have to take it out. Till you have to use it, and then it kind of sucks a little bit. Yeah. Versus, oh, well, it's basically built into your backpack anyways, and then you don't have to do anything. You just turn it on. That kind of thing. So that would be pretty helpful in that sense. But, of course, it's going to weigh more because there's a fuck ton more batteries. Yeah, there are, and more cooling for what it's worth. So, like, is there something you want to? It's always dependent on the application, and there is pros and cons to a lot of things. So that's what this is. That's what I'm trying to get across. It's like, oh, I can put the pump right above, you know, where I put the computer at the bottom, or I can have it towards the back, you know, right? And all of that will help in terms of outright compactness and longevity, meaning you can use it for quite a while while still taking all the gear that you were going to have anyways. Right now, we're talking about a bigger pack. Pros and cons. Pros and cons. So I don't know. Like I can make an argument, but I can also make an argument for the laptop. It all depends on what you'd want to do and whether or not you even need that amount of power. And you're definitely not going to get a 4090 Ti or like a literal top of the line CPU in those things for $2 to $3 grand. So if you need that, then absolutely. But if you don't, then just barking up the wrong tree. That's what that would be. So, but I can definitely see it being useful. For me, it's more about van life, van dweller life. Say, I want to go do the camper van kind of life thing, right? And I know that this sounds really stupid or bad to some, but for me, it makes total sense. But there is no fucking way you're going to take, in any aspect, a full fat desktop with you. It's the stupidest thing. It's over the top, too damn large. It's just too much. You don't need it, right? So you're not going to get a 48. Like, you wouldn't do it. You just wouldn't. But I've been looking at mini PCs, and they're phenomenal. I mean this, like they are genuinely phenomenal at what they do. They don't have any GPUs. Every mini PC I find has not a single solitary fucking GPU. They have them as a APU, and they barely manage to do 1080p gaming. And by barely, I mean they do it much better than they did in the past, and I love that. But they don't actually do it to the point where I would prefer it. That's what that is. So, my thought process has been get the Oculink cable, get like a little, stand and all that, and try and like basically get a small, GPU, external GPU kind of setup and run with that. And it works extraordinarily well. The problem is there's way more meat on that bone. That APU, the GPU part of that CPU doesn't get used. It doesn't have the Crossfire, it doesn't have the SLI, it doesn't have like whatever Intel to NVIDIA and or Radeon, AMD. Ultimately, you know, it doesn't do it. It doesn't talk to each other. They don't share resources. They don't actually like use like each other for their benefit. It makes no sense. Why wouldn't they do it? Uh, there's more meat there. And then on top of it, it's like, oh, it does 1080p. And some titles it does it so well that you don't really have to worry. But I want 1080p, 120 frames per second bare minimum with medium to low settings, which they don't do, which bothers me a lot. So the moment you want that, though, it's like, okay, I need to get like a 4060, 4070, something in the Radeon equivalent. I haven't been paying attention very much on the AMD side. So as a result, whatever those would be, you've used those. But that's the problem. It's like, oh, that's a full fat fucking GPU. And it's like not necessary. There's a $700 option that I found that's the GPD G1 or something like that has a really cool docking station, USB, all that stuff. The issue is it's $700 and it's a non-upgradable AMD Radeon option, right? And I'm like, I'm basically paying $1,400 for this. I could, honestly, probably just make like a mini ITX for $1,400 or something like that and get better performance, which bothers me. That's what bothered me about it. It was like, oh, yeah, I'd rather just do that, you know, um, which, you know, it sucks because it's like, no, I want the mini piece. I like the small, tiny little form factor. I love that. It's amazing. It works phenomenally well. I want it, and that's another reason why I made like one of my videos previously for this mini PC idea that has a projector built in. So I was like, well, yeah, no, I don't want the the things that a laptop has. I don't want the keyboard. I don't want the fucking mouse pad. I don't like it. I don't need it. I don't want it at all. The screen is okay, I guess, to a point, but I don't really need it if I have a projector because I'd rather have a projector that can throw pretty decently and has decent brightness and all that, which is why I got into micro and mini LEDs with phasing and pulsing and using a LCD screen along with a multitude of uh, tube TV like designs that are scanning, you know, that allows for with the LCD thing here to be a lens corrector because it'll curve and move, become, well, it's not polarized. Anyways, blocks light in certain areas and then allows for light to become lensed. So, and diffused and refracted, depending on how you pulse it and the different wavelengths that there are. That gives you a multitude of different, uh, you know, ways of delivering exactingly the right tube scan line TV kind of thing for your projector that is multitudes of lasers that are very bright, which also happens to have the light backing and behind it. So instead of just lasers, there's a white LED behind that both brightens and dims and pulses. When you do that correctly, you can get reflectivity, you can get uh, light wave interferences, you can change the light wave frequency, you can change the brightness, you can change the darkness, and you can change its focus, and ultimately also all of it effectively for super cheap and have it be incredibly accurate, deep blacks, bright as fuck, and very low latency. All the things you want and looking for. That's the whole point of what that projector 3D technology was for, more or less, because I don't want a screen. I don't, in any real way, care about screens. I don't like laptops. I'm not a big fan. I have big hands that, fat finger all the time on things. So I dislike the vast majority of laptop keyboards and the placement of the trackpad. I usually don't like the screens either because I'm tall, which means I have to place them really high up, and I hate this. So I almost inevitably turn it into it's statically right there, and I'll just get like a screen, a monitor. So at that point, I'm like, fuck this. I'll just get a fucking mouse and a keyboard. I'll just get a fucking, even a white sheet would be probably as good. It's not really, but like you know, it's better than like what I just point it up at my ceiling, I could just get like some cardboard or some shit, paint it, right? Like seriously better for me. But it's what it is. And if you're in a van, it's like, no, I don't want I don't need that level of power. I don't want to burn that many watt hours. I don't need it. I don't have to, you know what I mean? So It's like, oh, what if I were to make that the mobile? I mean, they still give you everything I'm looking for, right? In terms of performance, they still have more than enough in terms of like RAM and storage capacity for the computer. So every time I look at it, it's like, no, it's this close. It's so close. It's that close. Too expensive for what it is. It's not upgradable. I'd want it to be upgradable. It's just a requirement. If I can get like a tiny little miniature, slot in card to the rear of a motherboard for the mini PC, that's immediately what I would do. I wouldn't do anything else. I only need the one full fat actual PCIe lane. So it goes over the sides. Well, screw it. You know what? I'll just have where the original, a little bit lower. That'll be where my SSD is, right? Like it'll work. They don't make them. They don't make anything, right? Like that. That's the problem. They make the 2-lane PCIe 4s. I'm like, give me the one full fat rear PCIe Gen 5 X16. Give me that. I want that. I need that. I want a whole actual, like, you want me to have a blower? I'll do a blower. I will 100% do a blower. I don't care. I'll do a blower design. Full stop. I will. You know what I mean? Okay, so it's a little bit on the, it's a stubbier. I don't have to go that hard. Okay, right? Like, okay, phaser. No. Okay, right? No. But yeah, I would do that. But that's also another reason why it's like, okay, so it's a blower, right? But it's like, yeah, no, and I'll fucking cool both sides. Get the GPU on one side, the RAM on the other. I don't think the RAM doesn't need to be cooled nearly as hard. It still does. Same thing with the VRM. But that means I can primarily put the vast majority of my cooling, where I need it. That also means I can put it on the rear, which would still allow for a blower to work just fine. And I still have enough room because, of course, it's going to be a flat mount, right? Kind of like an M.2 is, where I can still put a M.2 towards the rear and still have that cool based upon the blower sucking in air on one side and the other side, right? So that allows me to get a genuine mobile, like big boy mobile GPU that's upgradable, right? Same thing for a chip. I don't have to have it soldered. I can literally change out that chip. I can still get flat style RAM that's from like, oh, okay, Phaser, you don't want to, no, go get that. You're the one trying to give me this to fucking throw. Come on, really? Anyways, guess he doesn't want to go chase after that one. But, RAM from laptop. All right, I can get laptop RAM. It should be fine. But, like, it's a smaller form factor. Yeah, I agree. Yeah, sure. Same thing for, like, the PSU, right? Like, oh, so I have to get a barrel connector. No. I'll just get a fucking fat, like, I'll just do that. I'm honestly going to get the plug. I'll stick it into it. So it's, basically I have to rest on top of like a smaller form factor, like mini SFX or some other thing, like the GAN style, right? That's fine. I'll still do that. In every way, I'll still do that. You know what I mean? I'll still do it. It still fits within the package. It's a little bit bigger. It's a little bit thicker. It's a little bit longer. I'll do it. Like, why wouldn't I do it? You know what I mean? I can get all of that in there. I still have the cooling I need for the CPU. I still have the cooling I need for the GPU. Right? That's all I need. I don't see why we wouldn't do it, but that's the PSU thing. It's like, the PSU will be fine. it's supposed to go up to like 60 to 100 watts or something like that. So I can feasibly speaking go a little bit harder now because, well, I'll be able to get a decent cooler. It's still active cooling, but I can still get a decent cooler. They have flat style coolers. So it's like, oh, if I want to, I can basically use a push pull kind of configuration, right? Where it's vapor chamber on both sides, right? And then I can use the intake for the GAN PSU and then have that blow into, right, the thicker, of course, uh, fucking combo for the CPU and GPU. But of course, that means it's like, well, the shroud has to be ready for that and all that. So instead, it'd be probably better instead to flip that around and have it blow into, sucking in from the sides, and then blowing in through that as a single, style kind of combo, I guess, at that point. Because I'd be doing the blowing, but I'd also be doing the fan style. So, like, right. Uh, right. So I want it to be sucking in from the sides and blowing, right? But then if I have a single one that is there along the sides for a fan, either not the case side panels, but like from the other one, right? Because then I can put the PSU at the other side and have it be right vertically positioned, or not well, on its side instead of like laying flat. It'd be on its side, like the smaller rectangle instead of the wider rectangle. That's longer instead of the shorter one. That allows for you to understand how to position that, but that means it's like, oh, well, I can intake at the top or I can intake at the bottom, right? But it's like if I intake at the top, I have both the sides and the top as my intake, and I can blow down into one singular outtake blower, right? Which wouldn't really be a blower, it'd be more of a fan that goes down and then it goes out to the one side or both sides, depending on how you want to do it, or all four sides. Although I'm not a big fan of the all four sides, clearly, obviously, you know. But that's the thing. It's like, all right, well, why would you have the one at the? What would that be useful for? And that I can kind of get where people would come from for what it's worth, But it's like an 80 millimeter fan, which sounds tremendously better in all aspects than a tiny little 1U chassis fan that's just the worst fan noise. I hate it. So, but remember the whole blower style, right? It's like, well, the moment I have this move like that, that allows for me to basically, yeah, blow air in using the same method as the other two. So it'll take that air from the sides and then suck it in towards the top. And it'll have a little overhang, right? So that way, that air that's trying to be blown outwards in the rear gets separated by the fan shroud, then goes up towards the top fan to blow in, and then that'll go in between and then blow over together with the extra air there from the side fans, which now means I can make that those blowers be smaller, right, and thinner, like laptop blowers. And then I can do an 80 millimeter at the top, which allows for me to get all of that extra air that I'm looking for the entire cooling of this. But that also means I can just sort of lay it on the longer, smaller rectangle on its side and then just, leave it alone. And it'll have a specific amount of actual power delivery. So it's this specific amount. You can't go above that, right? So that one for me is like, well, I only want about 550 watts total out of any of that. 550 watts for an hour is a lot for a van dweller or an RV or any of that. Anyway, you got the fucking toy. Anyways, and that's a lot. That'll eat up a pretty decent sized battery bank for what it's worth if you're going to game out there or maybe edit, or if you're a person that's remote working, use it for a job, even with solar panels and some windmills, you'll burn through that fairly quickly. Uh, so like 550 is like that max watt that I would prefer. But I'd be willing to go up to about that 1,000, target, but I don't think that that would be as reasonable, right? Um, it depends on the person's involved for their life and all that. But for me, like 550 works just fine. Projectors are by far less energy efficient than an OLED. All right, I'm just gonna just jab real hard into some people out there. Like they are actually less efficient. But a properly done projector, like I talk about, or I'm sure other people have, are very energy efficient. Uh, I only need like at least 5 watts for any of those given laser wavelengths for red, blue, and green. If I were to divide that into a less eye destroying, amount, and a single LED, around 9 actually, smaller watts, so 5 watt, then we'll do 1 watt per each laser. We'll use 3 diodes. So instead it'll be 3, 3, 3, 3, 3, 3. 9 times 3 is 27. You get it, right? But that means I don't need as many switching and pulsing and frequency changes. So that's kind of what the point is, okay? But it's still doable with only just like 3 LED. But I'm going to move off of that for the laser thing. But if you get 27 of those, they're technically just 9 pixels, but it's like, yeah, but that's not really how that works. So if you change those frequencies and then you have the LCD, which then you can use the electromagnetic coils of a LCD monitor because you have to run electricity through it. And so like how that covers up certain things, and if you use 3 single LCD panels, right, that are meant to help you not just with lensing, but also with the electromagnetics, right? And then the reflectivity of a white light backing that is, of course, just 9 total, right? It's like, well, they're each 1 watt. And it's like, I know. So it's like already 27 watts. And then it's like, right, I need like 5 watts per each one of those, and it's 9, so that's 45 watts. So 45 watts plus 27, is it times 3? Fucking damn it. Yeah, no, it would be 27 watts. Yeah, so 27 watts total for a package of 1 each one of those. Yeah, but you have to pulse it. So if you want to do 27 times 3, phaser? No. Yeah, because it's supposed to be 1 watt per each one of those LED light, right? Laser, right? Yeah. Thanks, Fraser. You're such a nice. I use fiber optics in my design specifically just so that way I'd be able to pulse them and change the distance of where the fiber optic ultimately exited for the light, which changes how light wave interference works. So I'm not going to do any of that. But I wouldn't be doing this in this design because I wouldn't be needing it. It'd be ultra compact. It's the whole point. But it's like already I'm increasing the amount of watts I'm using, and I don't want to. See what I mean? So it's when I talk about this, it's like because it uses at most 10 watts to do all of that. I'm doing a 1080p, I can do 120 hertz, I can do 480 hertz. You know what I mean? Like, honestly, it's not that hard. It's pulsing frequencies and light wave interference frequencies. Yeah, that's all it is. So, but, the LCD, not very much in terms of like actual like amounts of watts used, but that's also where you can use like a little bit of this reflectivity, for the liquid crystals. So like not only does it become more opaque, but it can become more like a lens, but it can also become more reflective. So that allows for a lot more, which is what I was doing specifically, so I can reduce total watt usage. I only need a few volts for any of that to switch, rapidly into the terahertz ranges, because they're small, tiny. I was using really small stuff for a good reason, though, right? Because it's like, well, you have a, phone camera lens, so I'm going to use this. The optics that you use for your phone camera are what I'm going to be using, because that's easier in all ways to do. They're cheap, ubiquitous, super good enough, if not actually better for those designs. That's my throw lens, right? But like that means I can basically get a multitude of apertures and multitude of different distances, along with three different, no, nine, sorry, different zones for my tube TV. Instead of one, I get 9, which means a 3 section at the top, 3 section in the middle, 3 section at the bottom. And they can dynamically alter any of the given light. Instead of scanning from side left to right, they can directly place their shot wherever they need to within that given square box. This one, of course, isn't going to have that. It's not necessary, really, realistically, but it's also going to have larger lenses and a greater degree of accuracy and fineness of control, but that means I need less pulsing and frequency matching and more. So that's what that's about. But immediately just jumped up my power by a fuck ton. Like, the amount of power I'm now using is huge. It's from 10 watts at most, and it's very bright. Everything's more than good enough to, what is that, 45 and 70, 27. So is that 12, and then 4 and 2 is 77, or 72 watts, which you think is not much. It's a lot. It's going to be a huge amount. So, and it's more than bright enough. It'll have blacks, right? Because that's destructive interference, right? But also just straight up, no, you don't pass over there. Right? Which is good. But then I'm like, well, no, I'd rather have a screen, right? Like I mean this, a small, just the smallest of a, it's so odd that we don't really think about it much anymore, but we used to have screen projector TVs. They'd have a rotating drum or something on the inside, but they were phenomenally good for what they are. They honestly, they look really good, but that's because they're reflecting off of something to then like ultimately have that screen become a lens that then corrects everything and gives you all the light and so on that you're looking for. So my design turned into, I don't really care about that. It's a bunch of fiber optics that effectively go to multiple different areas throughout the screen, and a bunch of 3M tape that go into the diffuser screen. Yeah, because it's far easier to do that in all aspects than otherwise, because it's effectively already got the screen there. It's just breaking it into multiple little sections into ultimately the whole screen projection in its own right. But that's the 9 total sections with the 9 total white light constructive interferences, which then with the screen then turns into, shocker, I can alter that total black level and total brightness level and total light through all of that, which means I can now roll up that screen. I can then now put it up pretty easily, and I only need to just make a little clip to the little fiber optic projector that just needs to connect to the display port or HDMI 2 and the USB-C to be an active, thing. It's not going to stretch the bounds of the total amount of heat because we have 100 watts. We have, like light bulbs that are 100 watts, and this is in the 72 watt range. So it won't burn out. But I wanted it to be a little brighter, a little better, all that stuff. I kind of gave up with it for what it's worth. But it's like, if I can get it back down to that 10 watt, that would be better. But I can't do that because the moment you need more of the lasers, then is the moment you end up making more and more electricity get used. So it's what it is. It's a catch-22 kind of thing situation. So projectors are very good for those kinds of designs, but they do go through a lot more energy. This is not going to use as much energy as an OLED, which is great, but at that point, you might as well have designed an entirely brand new projector, because that's literally what I just did, and a screen. So it's a micro projector screen. So, and it's analog, which is the reason mostly why I did it. Because that means I can diffuse and refract and use polarization and some other effects for the optical, the fiber optic and opticals. So that means I can have multiple screens, like both top to bottom and left to right and diagonal. That makes it so that way I can have a far more 3D, far better picture. But because that's analogically done, it just gives you really good viewing angles at first. But if you were ultimately speaking to put it through the correct screen, kind of program that does that, then you'd have a 3D picture that would be fucking phenomenal. That would burn far less in terms of outright energy that's necessary to do it. But that's the catch. That's the crux. That's the elephant in the room. You need to know about light wave interference. You need to know about pulses. You need to know about collapsing. You need to know about collapsing wave functions. That is. You need to know about diffraction, diffusion. You need to know about the amount of light that you need to have. So there's a reason why it's 72 watts. There's a reason why each one of those has to be at least a watt. Okay. Because by the time it gets to the end of the screen, you don't really want it anymore. It's going to get dull. So, the elephant then turns into, well, I need to get light amplifying crystals or light emitting diodes specifically in these small little areas to increase the amount. And it's like, no, but you need to detect it before, and you need to know if it's this color or that color or this wave frequency, you need to pulse it the right. So I turned into Crystal Guy with rubies and other stuff to figure out how to just analogically increase the amount of light we get, which then turned into, well, it turns out there's some electrical stuff that's really nice instead of just analog, it'll just immediately do it, and that's better. Night vision is amazing for that. It'll transform a IR signal into a natural frequency, or natural light frequency, right? And a little bit of electricity goes a long way with that, turns out, and with the right material and the right reflectivity, which is 3M tape, it turns out, it's everywhere. It turns into that. Like, I'm not kidding. Like, they're like the silver nitrate and 3M2. So much cheaper. So much cheaper. And it's genuinely more reflective. It's better. It's just straight up better. So with the right fiber optic, the right all this stuff, it turns into that kind of a design. Yeah, like it's literally just do that, and then it diffuses easily. And it's like, oh yeah, no, I've got my 4K 3D holographic portal, screen that I just roll out, right? And now I can dramatically reduce the amount of actual like overhead cost of energy because I'm going to use only about maybe 10 watts for the screen at most, right? But the projector only needs to use now about 25 watts to get that total outright amount of brightness, peak, and black level, and all the rest. So that's why I did that, for that design. I was like, no, I want it at most to be this amount. And like, for what it's worth, yeah, sure, like my CPU and GPU now can really hit those high marks, up to 550 watts for the whole thing, which is basically a full fat actual desktop, right? But it's like, yeah, but I'm probably not going to hit that very often. So, we're really in that 400, maybe 420, 450, maybe 500 at most, right? But it'll hit that. So if you really stress it out, it'll hit. But otherwise, it's not really meant to do that. But it's what it is. So, but that means it lasts longer. That's what it's for. And it's a heater. It's a space heater. Right? Like in my little van cabin, it's a space heater. And sometimes it gets cold. I'm just saying. It can get pretty darn cold. Now, it's 300, 400 watts. But, if you game for a while, it'll get pretty fucking goddamn warm and toasty. So, if you cook at least once in there, it's gonna be just fine. So, the projectors are where it's at for me on that side. Mostly just because I then can just get a screen, and that's as genuinely as simple and easy as it gets. If I can get though a good projector that has a reflectivity that can then go to like a lens that I can roll out, because we actually do have like these flatter, thinner kind of diffuser lens styles now that are perfect for it actually. So like literally just 3M backing tape, right? And then like the projector, is it a short throw or something similar to that, is all that's necessary to get that quality now. It's going to be, instead of I'll be able to get glossy, for that. But on the one side is glossy, the other side cannot be glossy. So that's what that is. But that's the, lens corrector effectively. So, but that's the thing. It's like I have to get this little, and then I have to get like a projector for that. Which, has anybody, out there, just wondering, looked at short throw laser projector or screen projector? Has anybody looked at how expensive those fucking bastards are? They're not cheap at all. They're not in any aspect. They are like, they can be up to $5,000 to $10,000. So I turned into, I'm gonna make my own little thing real fast because I didn't want to. Not paying for that. I don't have that money. No, but for other people, absolutely go for it. But yeah, no, most of you are not going to do that, and I know that for a fact. So it's like the short throw. Yeah, see what I mean? That's the thing. Yeah, because like, oh, you'll have it in the center, right, or something like that. Maybe on a swivel, perhaps. And then it's you got to put your projector onto that screen because it has to be a screen. Yeah, You know what I mean? Like it has, but it's like no, but it has to have blacks. See, so that means there has to be a thing that covers where the projector is up to where the projector is, so that way it has a light trap behind it, so it doesn't ultimately reflect light back out, and it looks terrible with your black levels, because all you're doing is throwing a screen forward, right, to wherever that screen is. So reflective wise index stuff, oh, easy all day. Oh yeah, no, that's fine. Right? You're just talking about an LCD screen, like we, on phones. It's like, oh, well, that will work for what it's worth, but not quite the same. No, it's really genuinely not quite the same. I have to pee so bad. I've been trying to fucking hold my in for way too long. I have peed. I have 5 minutes left on my drying, which is nice. And I have 5 minutes left on my washing, which is optimal. So, as a result, I am right here waiting for 5 minutes for this to be completed. So that's going to be a thing. Now, you can probably hear all the background static noise that's going on. That is the whole reason why projectors are really nice versus the LCD thing. Because we're talking about the LCD thing, they used to have them for phones. One bright LED, and then they have a big taped area, right? And you get your wonderful LCD. But the LCD isn't super efficient in terms of outright watts per hour for this. Right, so if you can generate one light and ultimately have it do something, that's great, which is what LCDs are really known for. Okay, but what they're not known for is switching pixels very quickly, having a large amount of different pixel switch operations per second, so, and subpixels, without massively increasing the amount of energy used. That's the issue. Like, phone screens are 30 to 60 hertz. Maybe you get 120, stuff like that, right? Well, if you want, the 120 to 240, even higher now, refresh rates, like the 480 and the 540 or whatever it is, that's amazing. I love that. But you're not going to get that with that. And you're not going to get, like, the 4K or any of this other stuff. And the more screen real estate you have, the greater amount total of outright light and volume of that light you have to fill up. Which sucks. Which is why they don't have it. Oh, now it's saying, oh, it's still going? Okay. You keep doing that. Anyways, you use more energy to make a screen like that work. And you need more cooling to make that screen work. You need a lot more to make that happen and work, which sucks. Which is one of the reasons why projectors are that good. Projectors are a single light source that then only needs exactingly this thing, because it's pure and simple a diffuser lens, like they have for the projector TVs, that just use reflection, right? That means the light is all that you need. You don't need any switching of any sort. It's all done at the fundamental level of the light pulsing, frequency changes, and the tube TV slowing down, frequency change, movement, reflectivity, all of that stuff. So it burns a lot less energy, it's much more compact, and it's able to get away with that much more easily. But the moment you want to use a screen projector, you either have to make your own, because you know what I mean. Like there are nice smaller, lasers, right? And okay, so it's a digital and analog design for the PCB and power delivery to change the frequency and pulse sequence and all that. Okay, which is okay because that will also help lead into the LCD tube TV, but also the blocking and reflecting and lensing of the LCD kind of micro-sized thing and the multiples of them, right? To allow for that to be done very quickly and with very low amounts of energy used at very high frequencies in the terahertz range. Because it's small, tiny, so it uses a lot less energy, which is the kind of whole point of it. Right? Not to mention, it's like divide that frequency by 3. That's all I have to hit. If I move it here and I change it here, I can also hit it there. But if I were to go to 3 of each of those, right, then of course I get even crazier, below pico, whatever, if it's femto, second changes and switches between all of that, which is just an intense thought, to be really frank about it. It's a very odd one, that's for sure. Because it's not necessary in the slightest for a screen like that. So, what I'd tell you is, if you want it, sure. I mean, but you have to design it yourself. That's what that would be. That's not what I designed. That's not what I went for. I don't need that. I went with 3 single solid. I think we used a 5-watt laser that is both red, green, and blue. So 15 watts total, because I only had 3 of them. Then they pulsed and changed and reflected, depending with the fiber optics as well, for that given design, along with a 20-watt white backing LED. It's like 20 watt. Why would you use 20 watts? It's like, because that's more than good enough. It's a very specific white LED though, where it has specific frequencies that I use for that given pulsing sequence and management of the given type of light wave destructive and constructive interferences that I needed to ultimately make my design work at the speeds and the power densities, the brightness levels, and the accuracies, and the timing, and everything that I wanted and desired. So that's what that was, kind of a thing. Versus, well, I'm not sure if they make anything like this. I've never really looked into it for what it's worth. I'm not really big on projectors. I've only gotten into them very briefly and recently because of the whole this is a nice, I want to do this kind of thing. So it's like, all right, well, how the fuck do I do it? I need way less amounts of energy used. That's what that is. It'd be way better to ultimately reduce power consumption here. And 550 watts is fine, because I'll be more than able to get even 4K off of a 550 watt at 60 frames per second. So that means I can easily get the 120 hertz 1080p at high frame or high, textures and graphics and all that for the vast majority of games. And I like that. That's what I want. That's kind of the whole point. So there's that. As we fold and everything, of course, is turned off. It's quieter, isn't it? It's like, no, I can handle that kind of background noise. It's, why are you always so focused and fixated on this sound? Is it nicer in here? Is it? Is it nice? No. That's what I thought. So there's that, right? But it's also all about, um, you know, usage of outright watts. Because if I get a battery bank, let's say I had 1,000 watt hours, which is pretty nice. It's, like you kind of want to go pretty hard for your van. You know what I mean? Like you usually want to get like a diesel heater generator combo, or if not that, like the solar panel windmill with a separate fuel heater generator. So that usually turns into, for me, piezoelectrics, bioelectrics. It's yeah, I mean it's not even, it's really genuinely not even a joke. It's if it vibrates and it heats it and it cools it, then it produces a lot of electricity and it's 90% efficient. So that means 90% of that is captured into electricity. Means I also can get away with a much smaller, kind of setup. So if you know anything about like those little tiny propane heaters that you can usually get at camping stores or whatever, then you know that like that entire thing would be 90% captured as electricity. So when it's like, oh, this is 10,000 BTUs or something, it's like that's a lot of electricity. It's a fuck ton. You can capture 90% of that. That is so much. I could genuinely do so much with that. And it's like, well, the heat has to go somewhere. Yes, into my cabin. You weirdo. I just said that. Okay. Well, two can play it. I'm not the weirdo. You're the weird. You suck. Uh-huh. I'm so sucky. He's pointing out the flaw in your argument over there. But how this is net transmission. He's somewhere. Meanwhile, I'm also just looking at like the equivalent of the same thing for a heat pump, right? Because it's like, well, I mean, basically same thing, right? But like kind of sort of reverse. Like there's heat in the atmosphere. I want to pump it to here, right? But it's like, are they that good? It depends. For me, it's more about like if I cool my solar panels, because that's the surface area, and then, but below a certain amount of, so I don't know. It's catch-22, as always. There's pros and cons. It's always a problem for me. There's no, man, there's a magic bullet and I get everything that I wanted. It's like, oh, yeah. But otherwise, the sad truth of it is, in physics and engineering and all of that, there usually isn't often those things, unfortunately. But in this instance, it's like, all right, well, if I wanted to get the surface area of the van I was using, or truck, or whatever, camper it is, into I'll dump out the heat, kind of a reverse style, or like more accurately, I'm a refrigerator. Look at my refrigerator. I live inside of a refrigerator. I am the refrigerator guy. Look at me living in my refrigerator. Don't open that door, you bitch. You let out all the cold. Or all the heat. You bastards. You don't have to pay for this, right? So there's that, but that's the heat pump to the outside kind of thing, versus also I can still probably tap that into the car radiator or any of that stuff. I don't know, but that's all expense. You always have to pay for that. That's what that is. So it usually is almost inevitably just better to do a small design that is a waste heat generator kind of concept, where it's effectively I burn fuel, it exchanges it, and then it goes outside and if it happens to ultimately have a leak, it helps tell you that. But that also means I have a more efficient burn path. So a way to put that is efficiency is tied to the size and diameter of the radiator surface and the size of the tubes. The greater the surface area, because of cubic volume metric stuff, because, good old Cuban law theory stuff tends to always get better the moment you add in circles and you add in more length and time for it to do it, and you make it do it in a smaller volume and area. All of that is to effectively say, tube go small, small, efficiency go way up. And that's all you really ever need to know about it. But, fancy language and blah blah blahs aside, that is literally what they're saying. So, but there are, of course, exceptions to this rule. Usually, they involve materials or the bins, the flow rate, the thing for the heat exchange. There's a lot of stuff there, but for what it's worth, it's massively easier to immediately start increasing outright efficiency and surface area contact to designs like that. The moment you start making them burn in a smaller area, of course they got more efficient because, of course, they burn hotter. The moment you add in a single nitrogen filter to the nitrogen that's in the air, which turns out there are high flow ones and they're pretty good. You just need a decent filter before, since you already had, the need to pump in air. It turns into those nice little, well, I was, I'm going to pump the fuel here. I was going to do this, so, well, you know what? I'll just kind of put it all on one basic bitch, kind of like compressor blower thing. And it'll work pretty well from that point. So it'll filter out the nitrogen. The nitrogen can go outside, basically, but it's like, well, why wouldn't you use that for something? And it's like, yeah, it's not really necessary. That's kind of the whole point of that one, is you want to make sure that the cabin is separated from an asphyxiant, is what that is, because nitrogen, of course, well, yes, you can breathe it in, is not something that actually helps you do the whole continuing to live thing, with oxygen being the reason why that works, not nitrogen. So, while yes, you lose a degree of efficiency, you do gain that efficiency back by having a greater amount of concentration of oxygen. But see, the thing is you want that oxygen and that burn to exchange, right? So, a way to put it for me was like, oh, what if I can use that to help me exchange things? Nitrogen, turns out, is pretty decent when it's mostly by itself at transferring heat. It has a different saturation. Certain gases concentrated in our atmosphere are not great, which is really mostly just oxygen and nitrogen. But when they are nearby, they are repulsive. And the reason why that's actually a good thing for us is because they often don't want to combine chemically. And that's great for us because, of course, that means we can breathe. But it's terrible for saturation of any given heat into the elemental gas, as it happens to not do the cool ionic bonding or elemental or metallic, whatever bonding thing it does when it's just as a gas mostly by itself, which means it happens to reduce boundary layer inefficiencies and improve overall transfer of heat to it, which is nice. Now, there are better ones, of course, that do it better. Xenon being one of the main ones, argon being one of the even better ones. But we're going to get off of that topic really fast because it doesn't really matter. It's just like, oh, then that means it exchanges really efficiently, right? Kind of. It's always pros and cons. So a good way to put it would be it's fine if you want to just dump it out and it will cost you nothing. It'll cost you genuinely nothing in terms of energy at all. You just have to make sure it goes elsewhere. So that way you don't have a higher concentration of nitrogen in your intake area. So that's what that is. But for me, it's like, oh, well, I'm already cooling it off from where the heating spot is, right? So what if I were to just use this as a separation of nitrogen from, like, the outflow gas? Or, no, that's a bad way to put that. So inside the cabin, there's nitrogen, right? I don't want the oxygen, though, right, to be burnt, okay? I want nitrogen to be burnt. In no way either from the outside. So it turns out it is possible to separate nitrogen from inside the cabin and use that to ultimately help transfer heat, and the oxygen stays in. While I can use the same method, more or less, to separate out oxygen from the atmosphere, which is good. It's kind of like a double heat pump where, like, it has like the little, sucks in air on one side. That's the condenser. It goes up and then it blows out and you get your cold air, right? And then the heat gets transferred out to this part and it blows out all the hot air during its phase change. Sort of a similar concept and idea, except now we're using filters for nitrogen that's inside that is wonderful at transferring heat, and now I don't need my oxygen to be taken up, except, of course, you will slowly but surely lose oxygen because you breathe, and you might have like any of that stuff. So, where does the extra oxygen come from? And it's like, yes, where? Tell me, please. And the unfortunate answer, in truth, is it doesn't really. I don't have that one yet because I'm still designing this. I've done a little bit of work preliminary, not just on this recording, but it's a thing where they're really expensive. Propane, gas, the filter, not super. I mean, you basically keep it forever. As long as you make sure that the air coming in that it's separating is filtered well enough, then they'll last a really, really long time. So, or at least adequately long enough time that you wouldn't really be that concerned. But for me, it's more like, well, I already got two now all of a sudden, and I want to make like one effectively do the work of both of that. So that's the problem, I'd have in that side of things, because like, well, no, oxygen goes off one way and nitrogen goes off that way. It's like, yeah, no, but yeah, I need to make sure I get extra oxygen from the outside. That's what that is. So at least nitrogen, gets transferred, which is not so bad. But if I have an outflow, then the outflow can be used as a way to help transfer some of the carbon dioxide as a filter. So it turns out, carbon dioxide filters exist, but that's not really what I'm looking for. So I know that sounds weird, but it's more along the lines of, now I'm looking to transfer oxygen from the outside for a given exchange. Since there is still a H2O there that is burnt, of course, then that means to its view, we are far and away drier than it, because it's pretty darn well saturated. So that's where a nice charge differential of carbon dioxide happens to come into play with the polarization of a water molecule and carbon dioxide. So it attaches to the whole thing and gets scrubbed out that way. But in order for it to do that, it has to do an electrical energy transfer, which means it tries to grab oxygen from the atmosphere and move it into the spot that was the carbon dioxide. That means it then does that filtration using effectively a redox flow style of filtration, which is highly efficient and nice, because that means it's always going to exchange carbon dioxide. It should always more or less be low, hopefully. But, just open up a damn door or something. I don't know. If it starts failing or some shit. Yeah, like simple is nice, but, then the other side of it's just like, divert some of it from the nitrogen filtration, that is the oxygen, because I don't need to burn that much, into the cabin. So that would work just fine for what it is worth. It's all about how much heat you need more than anything. So, same thing for the amount of, if you had a single kind of style of plant or something that is similar to that is good for scrubbing out carbon dioxide to give you oxygen, then that will work. Just keep it in the right place for the window and all that. And that is really then all that's kind of like really necessary on that kind of style of things. But for me to go over terrarium and bioreactor kind of style breathing apparatus, so to speak. But it does cool it, and it keeps it typically pretty good in terms of the amount of humidity and volumetric airflow and filtration and scrubbing out a large amount of pollutants and more that are inside of your fan, which is something you probably want, or your RV, or whatever it is. But the reason why most people don't tend to do them is because, of course, they're terrariums, but also when I call them bioreactor filters, I do that for a reason. You do still kind of have to make sure that everything's sealed and maintained and everything else. And they are living, and things will eventually possibly die. So, as always, results may vary. Are they good at heat soaking? Past a certain point of heat, it's bad. Past a certain point of cold, it's bad. So, it's also another part of why they don't often work as well as you'd prefer. And it's like that. Now, we're going to move on to the more exciting stuff for the van stuff, because I want to talk more about, projectors are pretty hot. They suck. It's because the IR isn't being used properly. That night vision thing I was talking about? Yeah. What if you could just make that be a cooling thing that also helps amplify the amount of light that you receive for your projector? By constructive interference. Oh my God, have you heard about this thing? Everybody's doing it these days. This is everywhere around you at all times, everywhere, all at once. So there's that, right? But, and you're expressing it right now. That's the whole, everyone's doing it right now. So I'm going to move on, because I was like, well, that's a nice cooling trick, is it? Kind of. It's reflectivity. It's the constructive interference from a lower wavelength to a higher wavelength given a structure of the reflective surface. So that means they have to be broken down from an IR into a multitude of pixels that you then have to have get used by the light that is there properly. So, which usually just turns into, look at this LCD that has this reflectivity in the back, and then these are the pixels, and where are you going? Shh, I'm not here. This is I'm just gonna walk away on that one because it's mostly that fast in terms of how to use light, both for cooling, which is super cool, pun intended, but also really good at increasing brightness and all the things you're looking for, right? And of course, heat still goes into the cabin somewhere. Yes, because things will still move, which is one of the reasons why I was talking about it earlier, but it's just chaotic vibrations. That is what we consider heat. So, and it's I don't want to get deeply into that for what it's worth, because it gets really, really, really boring and frustrating to constantly drone on about that. Now, the reason why I was thinking about it is because it's if it's in a vacuum and I happen to do the equivalent of the tube TV kind of movement of light, then I'm able to use that reflectivity and the movement with the correct stiffening and strengthening of a given reflective index material. It then becomes a acoustic resonance pump that is also really good with piezoelectrics at using the light heat energy up to 90% efficiency to producing more light. And if I structure it correctly and use the correct things in the right places, magnets and electromagnetics for coils, all of a sudden I get a increase of power that is out, but also constructive interference pathways that are much better than normal, which is, nice. I like that. It effectively means I turn the movement of that given material as a diaphragm into a reflective surface that also helps with my constructive interference and reflectivity pathways for the light that is IR to any given point on that screen. So it's more efficient. Yes, quite a bit more. A literal extraordinary increase of efficiency. It's no! How did you get this level of brightness? This isn't possible. I've never seen this before. 30 fucking, goddamn watt my ass. You were able to get a 20 watt. What the fuck is this? He just started spouting numbers about his little projector screen, fucking LCD, whatever thing, TV thing this is. He doesn't even know. It's going to be way more, amounts of electricity than he thinks. Meanwhile, troll face, kind of, because I didn't tell you about this. You thought, but I knew, and you didn't. You should have waited. Should have waited for my cooling and light reflector converter interference, constructive and destructive, whatever the fuck thing this would be called, I guess. Right, whatever this is at this point, it's not any of these things. It's fuck you. It won't even work. I know it won't because I'm smarter and better somehow. Whatever. It's not about intelligence. It's about progress over time. Although I must agree, I'm rather intelligent, but it still did this over a long period of time of never-ending, like constant thinking. But it cools it, and for the given exchange, it also helps reduce electromagnetic interference. It helps reduce total heat loss, and for brightness, right? It gives me work done and performed for the given energy that takes, which is nice. Of course, we're talking about light wave constructive interference work energy. So I'm not sure how they'll classify that because, well, yes, it is moving something, and well, yes, it is doing a whole bunch of this stuff. It is still, not, I guess, considered light. It is becoming more ordered. Yeah, well, yeah, that's the whole point of it for the gas that's inside, but it's of course vacuum, right? So the movement of the vacuum, and I don't need to transfer that heat to anything, but of course that heat will still eventually transfer. Shocker, right? But that heat then gets used as a constructive interference, kind of like CO2 laser light does, for ultimately making an amplification and constructive interference model occur. So the heat actually does do light amplification work energy, which is great, while also being a constructive interference, tool and all the rest of it, which, I think is necessary, I'd say. But yeah, no, let's see here. I was thinking about it for other designs for my cooling, which is difficult to do because it's like, well, light is annoying. And it's like, yeah, no, it is, because it's not very good at cooling anything. So I was thinking about how to cool a CPU using light, but also using a lot more than just light, using field potentials. So not a first great start for some people. Most people don't know about what the hell that would even be. Most people know about, a surface is cold and so therefore cooled, but the way I described this earlier is heat is just moving into a more ordered and faster, less chaotic state, which faster tends to mean more chaotic, but faster also means more superfluidic in that sense, which means less friction and less interference, less interactivity between any given thing around it, which just means it happened to speed up doing whatever it was, and therefore it didn't lose much of any heat at all, and didn't become less ordered. Okay, now there are a couple of ways to think about that as there are superfluids, of course. There are like quark gluon plasmas, right? Or at least it's theorized to be like that. So it has very low amounts, even though it's quite dense, of interactivity with itself until it cools off and it changes its given charge and potential states therein for its various tons inside of it, or ons, as it were. But what that means is all of a sudden they'll glue together, or they'll repulse each other, or they'll combine like this, like in a different type of chemical reaction. They're effectively doing the same thing, just on subatomic particle scales. Literally, that's all that is. So the reason why I'm talking about it, however, is a rather simple one. Fields elicited when any given performed increase or decrease of activity, volts, amps, so on, of transistors
are more or less the same thing. It's a movement of a
quantum fluctuating field. Instead of field programmable gate arrays, if you happen to sap disorder using light and using electromagnetic and electrostatic fields, you are also able to increase the amount of cooling potential, and the result of decrease therein of disorder
that is chaotic
and therefore hot occurs. You basically grab it when it tries to move. So a field will be elicited and it tries to move in a way. The field grabs onto another field and it takes away its movement and it goes back to staying where it was. That's all we're really doing, but we're talking about electromagnetic and electrostatic and some forces around small, tiny little areas called transistors.
And of course, in order to do that, that takes energy. You have to put energy in. So
You don't get to do it magically with no energy involved. So he's doing it magically. He says there's this stuff called energy around. I can't see it or even imagine how it could be a thing. I don't even understand. Okay. But how about a wiggle and a jiggle here of like some air, and then, it got quieter all of a sudden. Okay, now imagine if I did that really well. Do you think I can get it colder? Probably. I mean, they have. Hey! Meanwhile, that's exactly what I'm doing. Just very, very specifically. There's a reason why there's light involved. You see, light has to be involved for this to work. Shocker, right? But it's a way to effectively force light to be destructively and or constructively, depending on your persuasion of thought on that one, interfered to allow for it to pass more evenly and unobstructedly through the given material that these silicon wafers are, thus imparting less heat on its travel through, alongside of allowing for a next kind of thing to occur, as in do the thing that is the movement of any of the voltage and more inside of your chip more efficiently and more quickly, more precisely. Right? Because that's all we're doing. Like, literally, that's it. It's like, no, you see, yeah, but no. So, interference, electromagnetic interference here is far more nuanced than most people will have you believe. Electromagnetic interference produces movement and heat as a result. We're removing heat by removing movement. Both the movement itself from the interference, but also the movement itself by making it effectively react similarly to a field effect transistor. And that's all that is. But it's not quite fully everything, so I'll have to describe it. Give me 1 second as I do this. Water. Dude. Yeah. So, let me go over here. Light is produced because of a drop in an electron's orbit. When you reduce a drop of an electron's orbit by simply moving the energy into a movement of a given field that allows for that given field to take and soak the electrons fall or even move to a higher plane in orbit, then of course you gain decreased heat that is there. Now, the way we ultimately do this with the vast majority of our cooling options is by having a crystalline bond structure of copper or some other material do it for us. By having a fluid flow through it, it transfers its given movement of electrons field orbit to a given fluid's field orbit. Now, a lot of us tend to think about it more in the sense of the particle itself, which, my God, that is a racket. Got my jacket in there. Let me go close that door. As a atom, so to speak. But an atom is a ball cloud structure that often acts and reacts with wave-like properties. So, as a result, it doesn't really do it the way we say it does to the vast majority of people. That's why boundary layer effects are so enormously weird to us, depending on the given material trying to go through. They either chemically react or they try to bounce away. And of course, there is a sweet spot there where they get close, but they don't react, which is wonderful, but in terms of a purpose of heat transfer, not super wonderful. Copper seems to have a nice reaction of extending its field further into the fluid, which is nice. If you don't know, there are in no ways ever been a single solitary time that any of your cooling plates or more have ever touched the surface of the IHS, even regarding without any thermal paste, because nothing technically ever touches anything, ever. So what we're talking about is a given surface area to surface area connection that is electromagnetic every time. That is a singular field to field oscillation that allows for any given transfer to and from any given place in an intrapedic thermodynamic quantum fluctuational wave function manner. That is all it's ever done.
2 loads of laundry.
We don't have corks flying around. So if you want to think about it properly, you'll have to think about it where things on that scale that are so incredibly, enormously small are far incredibly more small than you think, and do this far more often than you believe. And the amount of efficiency in which they do it is far greater than you think. as there are multiple avenues and approach to having that transfer occur. The electrons will most likely never hit each other and cancel each other out. So they soak up the energy through a quantum tunnel phenomenon in which they skip through each other. That is a field-to-field interaction, which is a pressure and charge differential, which forces a tunnel energy as they approach and get close to each other. This means the tunnel energy is what drained and transferred the vast majority of your heat movement energy to the nucleus of the electron's orbit. As it tunneled, it jostled, of course, the nucleus in order to do so, thus making it far more efficient at transferring heat than you believe it to be. That is the gist of quantized thermodynamics. The gist, not the you have this on, you have this thing, you have this, virtually, you have these quads, you have this ghostly, blah, 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 blah. I read something earlier. It's like, no, it has like these multiple, fourth dimensional movements. And I'm like, it's not moving fourth dimensionally. It's just a pressure wave that happens to be interacting with the given pressure wave of its already there given orbital movement. And because the damn thing has a spin, the electron has a spin, that means, of course, it's going to elicit a given pressure particle, which isn't really a particle, but it's a quantized little area that's a little bit more statically a thing that you can more easily kind of see. That has a idea as if it's there, and an idea as if it has this charge, and an idea of many things. But in reality, it's just quantum information because it's just a bunch of fields in a given fluid that are wrapping and being turbulent, effectively, onto themselves. But whatever. Fourth dimension, I guess. It's the fourth dimension now. So, whatever. But, still, I'm going to move on because it's not necessary to really, kind of go on about that particular, area. But if you now know a little bit about that, then it's the equivalent thing. You make effectively a different type of chip that is to soak up all the energy that is being elicited by all the transistors. That changes both field and propagational wave and ordering structure of electrons through any given material by both having its own amount of amp, volt, current, charge, and more in and around essentially the same thing. It happens to also constructively interfere and destructively interfere. Again, it really depends on how you're going to view that, because there are degrees of microwaves, there are degrees of some radio waves that pass through, and then there's still IR and some natural light, which isn't much, but there's some, so it's a thing. It doesn't really matter. Long and the short of that, it tries to reduce any given movement that is a negative movement that creates a chaotic, non-entropic, therefore hotter, right, chip movement. It also means that the clock cycle goes way up, really high. The clock cycle goes really high because it has to be working off the tracers on the motherboard to do this efficiently. And while, yes, it is a chip, it is not the same chip for what it is worth. It is definitely something that, yeah, sure, it's like silicon, but it's not going to be able to be that. And it still has to be transparent to the given light that we have to both put through to constructively and or destructively interfere, but also have it reflect back into and absorb that light in the right areas, while having very small, tiny areas for control over our given static charge and charge differences, along with electromagnetic and other force differences that are there as well. Long and the short of it is, it works. It's not necessarily needing to be as tied in to the motherboard's BIOS and more, but if it knows what that is and it's sending that information, then it can do this better. And it happens to no longer need a big surface area to cool things. Yeah, that's the highlight of the day, that you would have had to have gone through all of the rest of my entire damn video to get to the point where I said I effectively made it so you don't need a large surface area to cool something, because I force it to effectively never get hot by canceling out energies, which is a way to put that. It's like heat energy is chaotic energy. It is turbulent, frictional, didn't do the thing very well energy, right? And so I was all like, do it better. And then I whipped it every time it tried to do anything that wasn't better. But the positive side is that also means that the thing doing the whipping also happens to have its energy dissipated as well. So it works in lockstep, and it works really rather well. It still has a higher degree outright, okay, of surface area. So there's still that. And I still did not trust it forever, so I still did put a, basic bitch cooler on it and called it a day as a design. Like, genuinely, it's a vapor chamber. It pumps air from the out. It's an acoustic resonance kind of pump for the inside and the outside. So it moves the outside, heatsink fins, and then the inside then pumps it around. And so that way it still pumps a little bit of air. It just does so on a much smaller scale. And it's still rather efficient. It can cool about 100 to 150 watts depending on its size and enclosure and other stuff like that. But, it's neither here nor there. It is one of those, this will work. It does work phenomenally well. So, but it is also I have a lot of programming. I have to build the whole thing specifically for this. It is in every way something that is bespoke to every single damn type of chip. So any difference in the size and the shape and where the cores are placed and everything means I have to redesign the cooler for that exact thing that they're saying that is. So the opposite of it's plug and play and easy in terms of manufacturing. Manufacturing is a hellhole of a rabbit hole because it is beautiful. As a chip manufacturer, instead of an IHS, I would immediately remove an IHS and put this on it. Because why would I ever need to care about anything else other than this? With a IHS that at this point might as well be called IHS, the heatsink combo, and right, as a direct die cooler, then yeah. But we're also talking like it can do ridiculous amounts of power of cooling because it's not allowing for it to overheat or ever get all that hot. So that's kind of the point of it, though, in terms of like outright simplicity. But I don't know if manufacturers are going to want to do it. It works. It works fucking phenomenally well. That's the thing. It does. It genuinely does work phenomenally well. But it's the catch-22. It's like, yeah, oh sure, it works very well. Okay, but it's also pretty obviously intense in terms of how you have to manufacture and make it. We're talking about smaller structures. We're talking about photolithography. We're talking about running electricity through it. It has to be a part of the board. It has to know about what the power delivery and everything is. All doable. It is. I mean, but most people aren't going to break open their motherboard to get into their tracers, right? So that is one of the reasons why I also didn't do that, and it's like it's the equivalent of how you measure using electromagnetic fields in a cable to know what's going on in it, right? Like the little loop, right, for electrical engineers or electricians, so on. So same thing. He basically placed it onto the motherboard with another thing on the back for the back plate that allows for this to be done like that, and it knows what's going on as a result. If I didn't do that, I'd have to literally drill in and or solder to a tracer, which of course changes the volts supplied and the timing and everything, which sucks. So I'm not going to do that. You can do it though, right? It'll still work. Like you can change the BIOS, you can do a lot of stuff, and it will work. But my workaround to doing any of that was just place it on both sides and then use that as a way to know what's going on. There are a few different spots that I have to actually do that too, and it's very heavily dependent on motherboard. So not just chip. Depending on the motherboard, I have to give you a different one, which is the reason why I kept saying it was a bit of a hellhole for the rabbit hole, because it's a great rabbit hole. Oh yeah, I know, but it's also a hellhole because like you'll chase it. Like you will absolutely 100% chase it. You'll go through. Because why would you do anything else? And it's like, yeah, kind of, yeah, a little bit, yeah. Like, why would you do anything else? It's like, yeah, I don't know. It's one of those things because sure, it works. Oh, you have to be. It's very advanced. This is the very, I started getting into advanced stuff for that. Right? It's like now this makes that. Well, it's advanced. Look, unfortunately enough, like it's kind of just normal, not advanced stuff. So really nice, but give me a second. Right, but it's not too difficult to do. Is the point, right? It's a little bit of light, but the light luckily is kind of like the main LED on the sides, right? So like with a little bit of laser, a little, small, but not to the point where it would be enormously expensive to get those, right? And they don't need to be very bright or powerful. And same thing for the electromagnetic coils, and same thing for the electrostatic generation and more. Okay, and the pulsing and sequencing is rather benign, turns out. But it's all in the layers that I had to make. It's all in the material I have to use. It's all then also has to have programming for this. So there is its own version of a chip that only works as a result of that chip being on. Because otherwise, it in its own right gets too hot. So that's the caveat. The caveat is, oh no, it's built for this, so it can only work when it's working. That's it. That's it. Like that's the caveat. And even then, it's like if anything were to fail. So here's the plunk down vapor chamber cooler, right? So that's the other caveat. If there is failure, which inevitably there will eventually be a failure. So that's just how things work. But yeah, it helps with clock cycle frequency. Now, the reason why it does this isn't just because of cooling, it's because it's changing potentials around transistors for how it is and how low of a voltage it is that it's necessary to deliver to ultimately get a given type of transistor to work and do its performed operation. That also means it has to pulse little tiny electromagnetic fields that then have an electrostatic repulse and attract in all this to kind of aim them towards these tiny little nanometer sized areas. So it's a bunch of layering for multiple phasor arrays that also have these electromagnetic fields that are in the general area to also take any movement and charge differentials in that sense of any electricity, so electrons that try and go and lead astray, right? Or go off the beaten path, so to speak, or cause expansion and thermal resistivity, which I guess isn't really technically the case. It's more like they drop an electron orbit, so it wouldn't have gone to the electron orbit that it would have gone to. And so then it doesn't heat up as much, which is the point. It's still going to heat up because, of course, there's still electrons moving, and electrons are quite small. So that's what that would be. But, all right, back. I had to pause there for a second. Dad's playing with my dog. Mom on something. Anyways, let's see here. Right. I'm not allowing for electrons to go to a higher orbit to produce a drop that allows for some electromagnetic photon radiation, right? But there are more things than just that cause heat. Okay? Movement of an electron from one to another creates a jiggle of the electromagnetic field. By forcing the electromagnetic field jiggle to effectively be captured by another electromagnetic field that causes it to snap back into the given cooler design, but then also happens to create a next area jiggle cancellation, that's then going to dissipate over time, of course. But that also means I'm starting with a lower amount of volt and current to perform a given type of transistor operation. I'm improving its efficiency, but not really, because the efficiency is not actually being improved in any actual real way, because I'm basically strapping a supercharger and turbocharger to the given transistors by creating field effect types of transisting, except I'm really just helping that occur more easily, okay, at a lower voltage, okay? But that means that doesn't get as hot, and that means this doesn't get as hot, because of course that field then goes and gets dumped into the given amount of electricity used for the given core to do its given transisting in operations. Okay. Now, it's more than just electromagnetic field jiggles. Okay, there's also spins, right? Which we're not going to get into spins today. Spins suck. Yeah, I'm just going to say it. Like, calculating for spins suck. So don't think about that. But spins of electromagnetic fields are something I can, ultimately speaking, get rid of. which change the amount of heat that you'll see. Which instead of a counter-rotating, it's more of a pulling it out as a direction of a spin of an electromagnetic field for a given material as electrons move through, which have a collapse depending on the wave and sine wave delivery, as my dad screams in the background, is what occurs. Okay, so think a boat goes over water, and when another boat comes through that's close by, because electrons do not all travel the same path, it then creates a turbulence. That turbulence is a vortex. That vortex then extends and dissipates outwards, except because we're not talking about water as a fluid, it extends in a 360-degree manner. But because there's more resistivity towards the given material, towards the nucleus of a given atom, it actually extends outwards and then collapses back like a spring. Now, that creates, of course, a jostling, which is, of course, a kinetic heat. Okay, now, when you remove the spring-like effect and you grab it, then, of course, you ultimately no longer have that heat. So, with light also bouncing and being used with a reflectivity index to constructively interfere other light that's elicited during the operations of a core or a transistor or any given filament of wire, that means it soaks up that energy during that moment it is moving. Because it's highly predictable, because of the tracers and the delivery of power it needs to have to be able to perform any of its given operations, that means within any given nanometer, it is incredibly predictable in how to sap any of that given energy out. That also means the constructive interference turns into, or destructive depending on how you view it, turns into a light wave that does not interfere very much with the given material that is there. And so therefore light is cooling and keeping it more maintained and more ordered and less movement overall. Same thing with electromagnetic fields that are used to capture and then ultimately dissipate off into other light areas throughout the cooling design. As a collapse of a given electron's orbit when it's in a more ordered state, right, then also continues to keep its ordered state. Now, a way to view this is when you do it the right way, it's collapsing to always having a more ordered state, as the elicitation of a given light wave elsewhere then is what's creating the continual increase of more ordering of its given state. Layman's jargon's term, light burrs correctly and it cools off. That's all it's doing. But it's doing it in the right frequency and manner to which ultimately things don't move anymore. In a highly controlled, highly precise, highly accurate, highly consistent manner and environment. That doesn't really care if there's other light waves, because it doesn't matter. It just needs to make the core do that. It just needs to make itself do that. That's all it does. But the whole point is it's literally generating a lot of light. Okay? It's a light amplification premise of a cooler that also happens to make a very, very specific type of frequency of electromagnetic pulses, effectively, that are then captured and turned into light. That's all it's doing. It's making electromagnetic pulses that are kind of like how the sun happens to have electromagnetic filaments that then collapse and then get sent as big, ginormous charged particles. Think that the particles are tinier little charge differentials, right, in the electromagnetic fields and electrostatic fields here that are generated, that then have light that are attached to them, but also they drain their energy into the light, thus making them change their given frequency and directionality. Which is all that's going on. Okay, that's it. It's stopping the movement using sapping methods. So a way to put that is if you drip water onto a hot pan, it boils away. Okay? Think that the thing is a hot pan, and this is going to take away its hot field, basically, and then it boils it away into more light. That's it. Yeah, it's just making it move less. Yeah, that's not technically true. It's no, it's because I can't say that it is doing that because it's not. That would imply that it's like a binder. You know what I mean? Like I'm binding it really hard and I'm trying to compress it and it's not moving and so therefore it has no heat. But that's not what that is. I'm making its heat be changed into a phase of another field and then into a phase of more light. It's a two-phase boil-away system of thermodynamics. Instead of compressing something, instead of condensing something, I am simply making the transfer of its given movement of chaotic heat happen quicker into material that is, technically got no mass and can do it much faster. And by technically, I mean it definitely has no mass, but I don't know. I still think photons sometimes have mass. We would never know. It's very hard to know. There's a lot of photons. There might be a type that we just don't know. So, I don't know. It'd be rare. But then I'm also like, I wonder if it's just hiding its mass. Is it, it's like an anti-graviton, right? Or anti-mass, whatever kind of boson it is that would effectively be what's attached to it or something. But then we can't even break them open. So we don't know what the hell they're made out of. Although we do know that we have, but I want to move on. Doesn't matter. We're going to move off of that. Okay. We're going to turn into, so let's explain this a little bit more easily, understandably, that kind of thing, right? So, movement of the given cable. That's the silicon wire filament thing, okay? That happens to move very specifically as electrons are placed in, all right, to do any given transisting calculation work for its switches. And it, of course, has to hit a certain voltage to have its switch then activate and allow electrons to pass through. Okay? That's all computers are. Okay? Now, as a result of this, though, I can change how it happens to move through by having the field that is a pressure that happens to move through, of course. Now, it's not technically traveling anything faster than light, but it is. This is the crux of that electron virtual particle fourth dimension. Alrighty, so I had to pause there. Back home, I had the laundry. I have to put the laundry away. I don't want to put the laundry away. It's the whole thing. We're going to try and figure this one out. To motivate myself. So, let's see here. Right. Movement yada yada, blah blah blah, more photon excitation. Yeah, well, it's conversion. Yeah, so movement gets converted into photon because of electromagnetic field potential, which is a fancy way of saying photons are made as a result of something occurring during electron orbit decay. There has to be an opposite reaction because there's not enough mass to make ultimately a electron, any really big excitation of something. It creates a photon. But it does this only as a result of there used to be an electromagnetic field there as it was moving that direction, but now it no longer has the energy to continue moving that direction, having it spin, and also having its given continued plane of existence in its orbit. All that is to say, a Hall effect field then creates a spin collapse that then, during its tunnel movement, because it's no longer there, now has an area for it to go into, while as it happens to decay into that orbit and continue moving, then still has suddenly another field that's elicited nearby. That then collapses its given field wave function of its necessary movement that used to be there, that then allows for this photon to be created and its given wave frequency and intensity for a direct conversion of its given continuation of mass at this given speed, at this given orbit, at this given spin rate, and more. Which they're all like, no, this isn't something else. There's tons. I'm like, ton it up, man. It's all the ons with the tons and the eons and the pawns and the bonds and all the fucking ons. I don't care. Fuck your ons. I really don't care. That's literally all it is that you're describing. I don't give a fuck at all. I don't fucking care. That's all you're describing. But for what it's worth, they do. And if I was, ultimately speaking, to get into that field of science and study, I would have to be the nice guy that goes, yes, it's this on with this, man. This is the, sigma fucking alpha. I don't give a fuck. Some, stupid symbol that means this algorithm, which is relating to this observation, which relates to these studies, which relates to this type of way of doing this study, which relates to these types of physics phenomena, which of course were not accounted for during the initial study and observation, and then they then still did not continue doing that. And now they have a workaround adjustment theory for their given math observation corrections that they have to do for the given input and output of energy, which is where they have these weird-ass long string of numbers that seem infinite, and why the complexity appears to be there, which is bothersome. Why don't you just observe it better? Huh? How come you don't just get good, son? Huh? Shut up. You suck. All right, fine. But that's literally all they're describing. It gets boring for me, unfortunately. You'll end up understanding why very soon, because it's like, how did you make the electromagnetic? How do you do it? It's because it's like I'm making a photo of the. I just told you, like I have to make it pretty small. This has to be fairly small and fairly precise and concise and consistent and all of that accuracy that it entails. You can't just stand together and suddenly wait. It's like, fuck yourself. That's not how this is going to happen. Are you kidding me? I'm talking about highly precise things. Like genuinely, there's no way to do it the way that you think you could do it that way. There's just some fields and some coils or some shit. It's like, go fuck yourself, basically. No. So that's not happening. But on the other side of it, it is still what it is. Goddamn. Yeah, I just want to lay down. But, it appears that recording helped me out. because I was just going to go lay down, and then I started my recording again, and apparently I decided to, I guess, feel like people would look at me weirdly, and then I decided to do this thing where I put stuff away. So there's that. You know, that old ever popular judgment of other thing problem. Then we move on to, all right, so how does one do this? I was like, well, I mean, it's filament thing, but, it's not filament thing, because you have to deliver fucking electrons the right way. You have to understand the electron jiggle wiggles on the smaller skilly whales. We can't use transistors, so instead we use a version of both light emitting and electromagnetic coil wave propagation through given filament coils, winding size stuff too. Remember I talked about how it's like, well, yeah, it's not an actual CPU. It's not gonna be able to do any calculations, but because power delivery is what it is, and it's very consistently this thing, you can program around that and get the type of result that I'm talking about. I have to do programming. I'm just a physicist. Okay, I'm never going to do this. I'm just a science. I don't program. I'm not a programmer. I'm a mathematician. Okay? I don't do that. I'm above this. Meanwhile, luckily, it's not all of them. It is luckily even further. There are those that like this. So, go fuck yourself, those people. Jeez, God. Oh, it's almost like we'd be much further along if a bunch of people decided to do this, or even possibly collaborate and work together to do things like this. It's almost like that's a good thing. And that gets things done faster and better. But oh no, we wouldn't want that. That would be working together! But I digress, Standard stuff here. It's like, no, I'm really good at this math. Okay. Is this guy able to program that math? Oh, absolutely. I know exactly what that is. All right. And so you know about the observation. Oh, absolutely. Oh, yeah, definitely. All right, then go do that. No. What about this material design? Like it's not silicon. Yeah, I can't really do silicon at all. Like genuinely, no. It's a thing. Yeah. Well, maybe in some areas, sure, but no, the vast majority of it would not really kind of be about that sort of thing. So kind of have to deal with that. You got to take the good with the bad. So that's why it's like, no, this is a genuinely bespoke, in a way, thing. But luckily, we don't need to get to nano sizes. We just need to get to micron sizes to get this, as long as you layer it the right way and you properly channel the field potentials and more through the given material and the electricity that you dump in as well. It allows for you to get away with murder, so to speak. You'd be hard pressed to find a physicist that actually knows what I'm talking about that would say it's not possible. A real one. But it's like a holy grail. It's the destructive interference wave quantum fluctuational tunnel energies being used to cool by making more ordered states into our very CPUs. And I'm like, okay, blah, 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 a lot of words. Get out of here. All we're doing is burning some fields and it cools itself. But not really. This is the thing. I'm dumping that into more light. Very efficiently, basically. And then the electromagnetic fields and electrostatic potential fields and more then get used to make more electricity as that is captured to make more light, which is a whole thing. So, Yeah. All right. I was with wave propagation. That's what it was. Right. So wave propagation is technically able to tunnel faster than the speed of light. And because it doesn't have mass, that means it can work in a fourth dimensional aspect and way, which is why they decided to write that study that way, even though the wording was piss poor at best and your title was crap and I hate you for your damn clickbaity bullshit. So there's that. You're gonna have to deal with me knowing what you mean. Who is a layman's non-PhD having motherfucker who's that smart. I just get very pissed off with people that try and do that shit. You know, bothers me a lot because it's like, really? This is the best you? Come on. You're smart. You have a PhD. There's a whole bunch of. What is this? Seriously? So, I'm gonna move off of it because it's not their fault. That's kind of the unfortunate truth of how to get eyes on and ultimately, possibly, more funding for more studies and experiments. So it's just what it is. But, so, it's, for me, with what they were talking about, not technically doing a fourth dimension, okay? Because the electron itself and its field is just that. Just that. It's literally where it's at and where it moves and everything else, and it is more than anything else just an indication that we're wrong about observations being uncertain. That's the problem. It would destroy a lot of what people believe about Schrodinger's uncertainty principle. But that's quantum thermodynamics and many more fields in theoretical physics and particle physics, basically all describing the same thing happening, but they're not willing, I think, to admit to it because they like Schrodinger, and their equations currently right now are not, well, great. They're holding up. So they don't want to do that work. And it's hard to get the funding for it. And that's what that would be. But it's just that. It's a field that's within other fields that's also got less fields, areas, basically. So in its orbit, yeah, that's great, but then also there's a larger amount of fields around it, and there are, of course, the quantum vacuum foam zone situations going on that exist both in their fields, in the nucleus, and in the very electrons themselves, because of how intensely small that really is. So, hard to measure all of that in any real way accurately. They'll eventually get there, but it's not a thing right now. That's what that is. That's why you see jumbled up, turbulent field collapses, movement that start being made into virtual, ghostly, and quasi-particle soups stuff. Where it's like, but all you're describing is this, but that's friction to us. Chaotic movement of fields for thermodynamics. Okay, so entropically it wants to make that do less of that. Of course, that energy burns into something. Right, which means it tends to spread out and then realign itself to more elongated wavelengths that aren't wrapping onto themselves or interfering and interacting. Okay, we use interference for something that stops something. We use interaction in the terms of I am talking to you and you're listening, and this is an interaction. Okay. If you want to transform, then you'll use transform because it transformed it. It took it from this and changed it into that. Now it is different. But interference and destructive and constructive. Oh yeah. Fucking makes no sense. I hate their fucking words and lingo sometimes. So, but we're getting into, so the tunnel effect of this given field happens to travel faster than the speed of light. The pressure wave is also elongated differently than you'd think, as that pressure wave collapses towards both where it is and where it is not, also where it has been and where it could have been. Okay, but it was too resistive, and so it moved that. Okay, also same thing with where it could have been or where it could go. Two sides, same coin. Think supersymmetry. That's why the math still works, but not the same, because we're not talking about supersymmetrical, virtual, quasi, ghostly, or any particles whatsoever. They're fields and pressure waves. But that's why I use dimensional theory from Michio Kaku, Dr. Michio Kaku, in my math, but they are not strings. Okay? Same thing for, while yes, I remove supersymmetry, I use supersymmetry specifically for my versions of this. All checks out. That's why the math is good. The math checks out. The math is something that can be used, just not with what it's being trying to be used for. Now, the reason why I'm talking about this is because that field interaction and interference type happens to elicit a collapse more readily, like a field gate array, for photons, since it's set up in a potential that makes a movement of an electron produce a opposing photon release much more readily, thus making it move less, the fields jiggle less, the nucleus is staying more ordered and less chaotic, and electrons being able to be helpfully moved more easily along certain paths. That's all we're doing. That's it. That's why it is not a compression, it is not a condense, it is a helpful ablation boil away, otherwise known as a phase change, as a setup of a fluidic field that allows for movement of a given mass particle that has a given type of resistivity to other areas, as that drop of resistivity to those other areas is removed, but not really removed. We are in lockstep and definitely creating the correct pathways for least resistance while allowing for energy to more easily go through that, but also energy to be taken away from other areas it might try and go to alongside of energy to help it move through. So that way we get a transisting. It acts as if it happens to have a higher volt. It does not. That's all it's doing. So it never gets hot. But of course, that energy, that is waste energy, which I have to put energy in to make the waste energy be removed, is still occurring. It's just going into photons and captured electromagnetic fields that make more photons. So, good old nice. Which is why it's in lockstep. So it has to effectively do it only this way. It is stuck. It cannot do it another way. To put it in real plain simple terms, its movement of volts and added of volts and everything for both electrons and whatever else you want to call it, because I don't really care. It's a bunch of fields and pressure and differentials of different charge and blah, blah, blahs. To me, that's all it turned into. But, you know, you have a bunch of words and lingo for many different phenomena that are all the same. So, use whichever one that's applied for your field of study in your PhD in your whatever the fuck it is, and it'll work. Just use that. So that's really where I'm at. It's like, okay, so I'm going to take energy away from this. It has that given volt, but that volt is no longer going to be the same, and I'm imparting it only where I need to, when I need to, and while it happens to move in terms of the electrons and the packs of electrons, because that's the sine wave, that's square. It's a packet of electrons that gets counted as this, whatever it might be, depending on the given type of programming you are using. So that allows for us to drop it, store it as potential, and deliver it when necessary. But while doing so, it undergoes several different transitions to various static, field, so on, that exists. Now, heat is removed in that way. We are removing both heat, of course, but also the ability to have heat generated by making less be there and more be there when it's necessary. That's a huge part of why it doesn't get as hot as you think it should. Think I undervolted the fucking shit out of my chip. Like, where are my volts? It's all zeros. No, that's not what that is. Don't worry. And the other side of it, of course, that also means that has to produce light. And that also has to produce a resultive opposing field that is either captured or collapsed into more light and or electrostatic in some instances, right? Because we actually do like some tunnel effects. Just as photons can be tunneled, photons can be transformed into electrons, but we can also tunnel electrons to somewhere else using the same method, which helps reduce the total amount of energy that is going through any given area. Think this section, well, yes, this whole filament of cable is this long. Well, I shorten it to this long, however much you want to think about it. Let's say it was a millimeter, now it's a nanometer. Yay! But it still has to go through several hops to do that. And, of course, the energy for that has to be done precisely, which is why it's a balance act, and it can't work without ultimately the CPU being turned on. It is the very definition of it is as a razor edge. There is no extra. It's that. It can only do it because of this, doing what it's doing. It is that kind of cooler. Now, other types do have the potential to work. They're just not as easy to do. You know, with the CPU, they're very statically fixed positions. Really simple, you know. It's very clear what the material is. There's not much in the way. The material that we use then becomes much, much simpler and much easier to manufacture as a result, and place it the right places as a result. Like, everything gets much easier. Like, the moment you want to do this on a large scale, which we are doing it on a large scale because we're talking about quantum and near quantum physics, we're going to decoherence, so it'll turn into electromagnetic stuff, which we're getting into electrodynamics and chromodynamics to a degree, and quantum mechanics for cooling, which is a big deal, actually. So, you know, that's why it's like, oh, that's advanced, but have you had a look at this? Have you seen this? I don't know if you've ever seen this. But that's the caveat. Okay, that's a genuine caveat here that's going on. Say what you want about the fluid, the supercritical CO2 fluid bearing pump thing, all that, right? That's easier. That's honestly easier than like thinking about this. Okay. A lot of people can kind of understand bearing and something in between, and is hard surface, very low friction, while also having comparatively a lot less heat to deal with and manage, and the right electricity and all that. Versus, fuck, I'm getting into subatomic particle physics and more, just to cool things. So it will work. It is difficult, but not impossible. And of course, uh, um, if you want to, you can have it, that light that's generated by this, go somewhere into something and recapture it if you so chose. Different material, though. Usually I'm going for pretty high wavelength radio waves. So high frequency, not wavelengths, though, high frequency, but it's a little bit more difficult. It's doable, usually, because we're talking about constructive to a destructive. So it'll go to a high frequency that then is tunneled into a longer frequency. That, of course, is one of the reasons why it takes so much of the energy out. Which instead of like a fuck ton of bright light, it's, oh, if I make you tunnel and I make you make more light, all of this, that eats your energy, doesn't it? It just fucking eats it. So, I'm gonna do that. I'm gonna do that so fucking well and hard. I'm gonna do that so fucking much. You don't even understand. And then it's like the beacon of radio waves compels you. It compels you. Anyway, not really, but man, wouldn't that be great, right? The quantum tunnel effects take a pretty damn good amount of energy to do, which is why I talked about that before we got to this point, along with the quantum wave and electrical field wave traveling through any given media before we got to this point. That's why that happens, because it's like you need to kind of maybe slightly understand that before we get into this. So that's what that is. Now, this is difficult to imagine for most people. So I usually phrase it in think movement of just space-tons, I suppose. Because it's not that, but like, it fucking feels that way. It does, though, doesn't it? Yeah. It's effectively, yeah, but they're like magnetons or something. And I'm like, they're not there. You know, and we're talking about quantum foam and space and time and quantum vacuum pressure and inflatons and other quasi, virtual, and more that exists in those moments that are aligned along given oscillatory frequency resonance fields that create a given directionality and spin to a given type of reaction of movement of another field. So through a given media. That's the thing. It's like, this is a given media. The media then elicits this given response. We see this type of chronograph. No, that's not the right word. Like event horizon, basically, of it. That's why we view that as a magneton. But in reality, that's just where it happens to bend and curve the right way for our relative perspective of our given speed and our given heat and our given all the things for observation for a given field to be there. So a way to look at it is like, yeah, but it's not. And so, like, fucking no, but okay. It's like, it's magnetons. I'm like, it's not. It's just a collection of soupy things. And it's moving in the right way, and it keeps them around in the right area, and keeps this consistent thing happening. Which is why I think about a resonance frequency as any given type of vibration into a given field and fluid media, instead of this idea of fucking particles or fucking fields or any of this other stuff. And I don't like to learn about the tons, because the tons will eventually be changed and moved on and blah, is what it feels like, because it's like, well, this is a larger field thing, that's in a big matrixy network that gives us resistivity, which makes an inward pump towards its sustained resistivity of information that makes mass occur. And that's all that is, really. Come on. How come you can't see it? But, of course, that's not, how other people view it. So, I don't know. It's a weird one. I don't really grasp that thing that they do where they just straight up deny, like, obvious, like, logical fallacies in their observations. But anyways, this is to go through with the next stage. So yeah, this is a different cooling. I know. You're gonna have to give me a second. So remember how that cooler produces a lot of light and all that stuff? So I was all like, but what if? Okay, like what if? All right. I basically did something similar to power delivery, with multiple power delivery areas that input the delivery specifically so that way it doesn't ultimately do what it's currently doing to the given material. So it's set up to more than just match ohms, resistance, and impedance. Okay? It's also able to help with delivery of a given run through and then resultive check of what the sensing of that run through of volts energy is, and then make a massive amount of corrections to its power delivery for its both square sine wave and multiple different patterning and sequencing to that given power delivery of both volts, amps, and currents, so that it essentially doesn't have anything occurring until it definitely needs to have it. But that means it's using an AC and DC combined. Okay, are we almost there? This is phasing along our tracers. Yeah, but you can do that, so shut up. It's fair. Okay, thank you. Now, we're not actually done. I know this. I'm sorry, but we're not. So we're gonna have to deal with it. This one turned into, remember that chip that I put it and I send stuff? Now it's turned into an active, and I'm gonna send pulses into the given tracers and pins and more. So that way I don't have to deal with other motherboards, or any motherboards for that matter, because they don't do this, not doing this. So I was like, yeah, I don't like that. So I'm going to just get around that real fast. And then I was all like, corpus callosum! Corpus callosum! So I then got like, well, this IHS is really pretty something much. of a thing that I can use, like a corpus callosum of some kind. So I then connected the two like this, as it helps effectively modulate both sides and the given information from both sides. This one makes it so it goes faster, but also it doesn't use as much energy to make sure that it does this, right? But it's like, but you just do. Wait. The fuck is going on here? Are you sure know what that is? Oh yeah, you're gonna hate this, but also probably love it. So, because clock frequencies are what they are, those are clock cycles. That means it runs through and then it has to pause and then it can run through, and we use phasing and multiple sine waves, square, that are delivered very specifically in a very specific sequence in a very specific pattern to ultimately do any clock cycle frequency, right? But it's like, what if I stored that into that? That's right. What if, hear me out, okay, right? I stored it by transferring some of that, just you know, I knew what it was, it set it up, it's analog, right? Because of the field potentials and more that are there that it can capture, along with the light and the given information as it has to capture it in these given areas, are only able to do it this way. So no matter what, it's a sensor and detector, but also storage and also deliverer of electricity in fields. And so it balances itself as it uses effectively the same thing, right, as it goes out. And of course, it has to deliver a sine wave and it has to do all this stuff, right? It has to do the transisting, right? And I'm like, yeah, no, that's super cool. Why the fuck would I do that, though? And it's like, yes, right. It's a good idea to understand how chips work first. Okay, so as it goes through, of course, it has to either send it through the fabric network to then use, if we're talking AMD chiplet, the information stored for another calculation. And it has to wait effectively to reuse this or transfer it to another core. Okay? Now, when I don't need to have that wait anymore at all, I then am able to balance it differently. Okay? So instead of it turning into another fabric network, instead, this is a crosstalk. You know, kind of like how our brains work. They balance off of each other. Some parts are really good at specific things, and other parts are not so good. But, of course, they're still able to do pretty darn well at what they do, right? So this is to both cool it, but because it's analog, and because it's storing it, right, and energy, of course, moves back in, it is a calculator to the calculator. It does it faster. It can only use the energy that it can gain from the core, which is both in terms of heat loss as electromagnetic, but also the delivery of power that we send to it to make it better at doing its job. We can get more threads as a result. We can deliver it from a different direction, and we are able to no longer need as much time for a clock cycle in between. What this means is it flows constantly instead of doing a clock cycle. Instead of a pulse jet, we have a regular jet engine. That's what it's about. It constantly goes through now. The caveat here is it's basically a computer chip for my computer chip that cools it. and it has to run off of the amount of memory and electricity it has. What that means is the chip did not get massively more memory. It did not get more cores, realistically speaking. What it did do is it used a trick to the core itself that it was already going to attempt to do, to grab and pull and use the next wave to calculate again, while allowing for that energy to dump in, meaning electrons and fields to dump in, while making it so that way it's using the correct transistors after having performed some amount of calculation whilst it's doing this. So now energy has to go into something, right? It's only alive because it's pulled enough to make it live. And it does this, again, technique, the passive active technique of doing that now as an actual transistor type that makes a bunch of light occur. Some of it I'm able to get back into the system, but that's not perfect. So it doesn't need to do that, is what the theoretical says, okay? It still has to input energy. It's not perpetual in any slight form or fashion. It's just highly efficient. That's all it's doing, okay? But a little bit of capture goes a long way for that to both be a transistor type and to deliver a calculation performed that works in conjunction to the opposing and overlaps. We're talking very close here to the given clock cycle frequency. So it is still performing as normal. It doesn't know anything different has occurred, and it's receiving the correct information. It still has to be programmed for that. Just FYI. Okay? It's not going to magically do this. Even if it is analog, and it is, it still has to know that information and what to do and where to send and everything else. So it has to be set up together with your motherboard and the operating system. Okay? Which means the cooler has to have programming to run. So it is an analog. It can't do it like the passive one that was analog. So it wouldn't do any calculations. It would only ever just make sure it cooled. This one's now active. It is doing calculations. It is analog. In those calculations, it can only do these things. But it's digital because it needs to dynamically change its given type of calculation in where it sends, specifically for the given program and type of program it is working, and the processor it is working with. Okay? So, and that's the whole end of that one. That's the corpus callosum. Okay, so the corpus callosum is effectively both a sensor detector, but then like it has a chip, because it of course has to make light and energy has to go somewhere. So it performs a given type of change of frequency and movement, of course, there within, making light get captured, of course, right? But yeah, light being tunneled, light doing anything takes energy. Any of that takes energy. So it's effectively always just balanced. It could always have faster, it could always do something more, it gets hotter. So it always has to be balanced to never go past its limit. That's it. And now it's cooled. It's almost like I'm forcing it to be more stable and cooled, like an ordered, what is this thing called? Dunk. It's a big vat of liquid. What is that? Hydrogen, helium? Oh, you got iron over there or something? You wouldn't happen to have any superconductors, would you? Going on over there. It's almost like it's one. It's not, of course. But it's a workaround that makes it act as if it is a superconductor. Can't do that. There's still heat, but it acts like it. And that's all that you need. Okay? But this is the other caveat here. It's built for any of those ships again, and of course, every program has to be made. All of it has to be done. Everything. So, yeah, you know, what's up, chip manufacturers? How you been, man? It'd be nice if you were to do that. You know, wink, wink, nudge, nudge. Hey, what's up, guys? You know, hey. You know, get into some quantum physics, why don't you? You know, like, hey, I'm over here. You know, hey, just chilling if you want to, like, get to know me or something. Kind of a thing, right? Because, of course, I'm going to throw my hat in that ring. Yeet. But, fun stuff for me, but that's the max. Genuinely, we're now no longer letting light that we could otherwise have used go as something that is a waste for the energy that we're using. The energy is now performing even work energy type that then helps the actual CPU. That also means we no longer have a clock frequency cycle that's the same. It's effectively doubled, but not really, because of course we can't really do the same thing. But, right, it is also able to go higher frequency for less volts, which it won't know that there's less volts. So nominal there in terms of things that you think you should see, but you know, obviously aren't going to see that. But the difference here is clock frequency and cycle is massively extended. The first passive cooler would have, by an order of magnitude, given you a bump. The next one gives you a near second order of magnitude bump. So if we're talking, let's say it was a nominal 4 gigahertz Threadripper, you know, maxed out Threadripper, okay? We got now for, what is it, terahertz? This is with the T, so G to T, right? And then we got another order of magnitude, practically, which I don't know what that one is. So is it a P, petto, something hertz? Whatever hertz that is. You know, the PETO. But is it, or is it peta? Because there's giga, there's tetra, which is 4, giga is billion, so this doesn't make any sense. Right? But anyways, one step above that. Which is the reason why I did it. Yeah, it's the very definition of, yeah, no, I know you like your quantum supremacy, but my one little chip will rule them all. It'll destroy your exawatt hour, fucking massive exascale fucking supercomputer things. No, we're not doing exawatt hours. Are we really not doing it? Oh, fucking hell, no. I know, they're going to get there one day. It's going to be fucking abysmal. I'm not kidding, though. It's scary. Every time I think about, like, supercomputer scaling, it scares me. Because it's like, oh, to get to exaflops, right? It's like gigawatt hours sometimes to run them. I mean, they're not all like that, but still, megawatt hours sucks. So, it's just that thing where I don't want to really even think about it. Most people don't, but we have to. Got to do the hard thing, unfortunately. So it's like, yeah. So we're gonna have to do the whole. How the fuck did? Yeah, right. Like it's bumped exactly, but it's not going to see that on your programming. That's the thing, right? And the only reason why is because of that plasticity and the ability to keep raising clock cycles higher and higher and higher and have them remain stable. Okay, which there's a reason why it turned into, well, if I'm going that hard, why don't I just get a damn active and with an analog, then you know what I mean? And so that I did, because you have to, right? It's like, oh, that's a lot of light, and it's a lot of radio waves. It's not going to be dangerous or anything, but still, that's something. Like, if I'm already tunneling it into that to make that, why don't I do that to make calculations? So I'm gonna go do that. You know what I mean? Like, right? So then I did that. It just took a bit of time to figure out really realistically how best to do that. And once you do, it's another version of, oh, so yeah, it's basically forcing the vast majority of waste to be turned into something that can be useful work energy. And there's still heat, but it's in the form of light, electromagnetism, radiation, right? And then it gets more troublesome from there, mostly just because it's an order of magnitude of speed bump, right? So, uh, and then the moment you have the flow, so clock cycle opposing, which makes total sense because there's a resonance at that point. There's clock cycle resonances, right? So it's like four, and then really it's an order of magnitude, but not of frequency of the four, frequency of the gigahertz. Totally different because it works off of the frequency of the gigahertz, not the four of those gigahertz. So that means instead of it being 8, which is what you would think it would be, because we are actively but also passively doing this cooling but also ordering and speeding of the transistors, that means it scales to the gigahertz, not the 4, but the actual oscillations that you have, the frequency thing. So it will then bump to a whole terahertz. Oh, right, tera, which is not 4, right? But still, yeah, it is. It's doing that. But it's like, yeah, and then you're going to do another one, whatever that fucking thing is. So, really high up. But there's a caveat always. Oh, yeah, no, there is for this one. I wanted to get into quantum. So I started getting into quantum by treating quantum tunnel as superpositions and other light and polarization superpositions and more. So I got clock cycle beyond terahertz frequency superposition able to be detected multiple times to error correct. So 3 different times. We have field, we have the movement of the sensor for the light, and we have the movement of a field, which can only be able to happen based upon, which is different than the field itself being elicited and then detected. But light going through and the field produces another field movement, which gives you another sense, and those are all able to be checked to each other to equal 3 times checking for the error of the superpositional qubit. Which now means it's error corrected higher than terahertz frequency superpositional qubits that are at room temperature. And that was the max I could do. That was it. It's a really small cooler. You know, it's basically flat. It is the plate, the IHS integrated heat splitter, as it were, or sink, depending. But also, it now is, you guessed it, quantum supremacy. Working. Oh yeah, woohoo! Alongside ridiculously high clock frequencies. So, you know, it's just got to do the cooler right, and then it'll work now. Yeah. Put it into your phone, get the Threadripper. Works off of like ridiculously more watts because it's a Threadripper. So, you know, you might want to shrink that just. You know, just a small scotch, you know, just a smidge more shrinkage. You don't need a Threadripper for your phone. But that's the point I'm trying to make. With a type of chip like this, with quantum supremacy levels of error correcting clock frequency cycle qubit superpositions that you can program for both the standard regular byte system programming and qubit programming, they will work together in harmony and balance, thus being able to deliver volts correctly to you as per normal and usual, which is a huge step up to what we currently have. We could do it now if we honestly had enough money and all the rest of the people to do it. But that also means you have beyond exaflop calculations for almost no energy compared to them. You do have energy though, for what it's worth. You have to put energy in. It's what it is. Okay, so you're not getting around that. But compared to the gigawatts and all the rest of that is no longer, because they don't ever factor in if they want to ever do a quantum and, you know, hybrid quantum and super, you know, exaflop range. They're not talking about how much actual energy, which is in the exawatt hours, because of the helium and or hydrogen you use, not to mention all the rest of it. Where are you going, huh? So anyways, that's what that would be. And I'm not happy about it. So, but this then means a standard desktop computer will absolutely be able to get you there. And I just so happen to have a wonderful tiny little all-in-one built mini PC here. That instead of having this big hunk of a radiator off to the side, it's just going to stand tall and proud, giving you lots of light too, that you can turn off, of course. But it's just a block. It just sits there looking like it's not doing anything. You know, with some fins, which, you know, it's passive cooled. Bullshit, you're not even using it. Yeah, if I'm being honest, yeah, no. It'll turn on. It won't even thrum. You won't even know that it'll turn on like that. But, like, still. There you go, right? And that's all you need now. That one little fucking PCB whole thing is able to calculate, I guess, for the entire universe or something, because that's what they say theoretically is possible with quantum computers. So this would easily be able to do that. Here's your Threadripper. Here's your whatever graphics card. You know, let's go with the combo. We'll go with the Max NVIDIA workstation and Max AMD workstation. And I'll stick on Intel on the AMD with the Threadripper area, you know, and then there's apparently a glaring flaw in the M2 that is not patchable, which sucks. Because I was planning on doing that, but I guess I can't do it now. But instead, I can use ARM-based and Qualcomm-based transistors in there, which will actually help both of those out for how they're programmed, right? And then that's the heat spreader, integrated thing. And then that's the memory, of course, and all the rest of it that works together, along with the power delivery, which this is the chunky cable, because these are maxed out. These are chunky cables because they're maxed out. Like, to put perspective, I added in the Radeon regular consumer instead of workstation, and NVIDIA GeForce regular consumer maxed out on that too. So it's basically as maxed on both sides, and they're all going to talk to each other because that's kind of necessary. And because fuck it, why not? Basically, like, hey, you're gonna pay me how much? $20,000 for this? Well, I might as well go all out then. There you go. It sits there, looks pretty. It will do all the calculations. It's cool. Okay. There's the Wi-Fi, and then the 10 gigabytes a second. Can do both regular electrical cable and fiber optic lines to them. The fiber optic jumps it up to 1,000 gigabytes. That's right, bytes. I said 10 gigabytes. I did not stutter, and I didn't stutter for 1,000 gigabytes either of transfer speeds. Because you're going to want that with the overwhelming amount of floppage you've got here. It's just doing massive flops. Floating point operations, just so we're clear on what that actually means. Okay. But, oh yeah, boy, will it ever do that. In fact, simulations, pshaw, I'll just turn my game development kit into a simulation. Like, I'm just going to do drivers that force it into a simulation so it looks better, whatever, I don't know. Something like that. Because it's like, well, whatever you want to do, you can do it all for $20,000, which you think is a lot, but they would pay literal billions for less in all aspects and ways for exascale fucking floppage computers. So my one little and done will do it. So have fun with that, I guess. Fun? There's fun? Yes, well, I'm programming my sentient self-aware good Roku, kind of AI over here. Why? Give me that, you fucker. Still programming, you can't stop me. No! Look, I'm simulating the universe and you can't fucking prevent me. I know all the things that are gonna happen. Look at me knowing things. You're gonna try this, you're gonna try that. Yeah. I'm gonna hack everything. My way, for $20,000? Yeah, I'll fucking. Oh, I need to program you for that. Meanwhile, me who made the thing and everything else. As if I'm not already doing it. See what I mean with this? We have to get on board quick and figure out how to, make this good. There's always some smart motherfucker that shows up and just, fucking murders everything for ideas and paradigm shifty fucking crap. With his geniusnesses. Rage bait, rage bait, rage bait. So there's that. But still, it's not, because that is absolutely possible, and also it is genius, and also it is going to be a paradigm shifter. Deal with it. There's that. you suck, you're terrible. Yeah, I don't care. But that's the actual end point. I was not able to do more than that. I had to make other chips specifically to try and get more of any kind of sort out, which is why I have the perpetual motion chips. There are quotation marks there with a caveat, because it is not. And of course, energy is coming from the universe, and it's all vacuum, quantum foam stuff thing that makes calculations off of that. And it gets, technically speaking, more energy out of it than you put in. And by technically, it's definitely more, but that's why it's more like a sensor and detector of quantum foam and nothingness stuff. But actually, I'm using that to calculate, because I'm setting up the fields and all the rest to do this calculation in the quantum and regular standard transistor type way. On really, really small, really, really fast fucking amounts. It is like a little tiny, fucking goddamn bot could go around with more calculation power than the entire universe. Alongside of more storage than a black hole. Which sucks for you, but not for me, and I don't have to care. Behold, my same thing that I do in my mind is what I said in that video. So, because you could do that, theoretically speaking, with your fields generated in your mind, and ionic exchanges, until eventually you get to the same point. So, I'm not doing that. I can't do that? No? Which I've talked about this so many damn times. It's insane. It's been like a few months, I think, at this point. But there you go. That is the best cooler I've ever made. And in terms of a concept, but of course I'm trying to do it with my body and my brain too. So, energy has to come in though. I kind of think, but I'm going to move on, of course, to it's the best I can really kind of do, I think. I don't think you could really, reasonably speaking, get further for what it's worth. And it is fairly highly technical. You have to be genuinely incredibly intelligent like me to even pull that shit off. So this is not going to be, oh, I thought about it a little bit and then, but kind of is actually, because for what it's worth, I thought about it a little bit and then, so, but it's more of it's going to work when you do it eventually. You'll get there. It's going to be what it is. I'll probably be involved, as there's no way to do it without that. If you want to make an actual physical or even your own brain version. So there's that. But as for other things, it's able to be done now, which is the reason why I'm talking about it. And it is also able to have been done when I talked about it back when I lived with my parents in Chandler. And didn't record and put it on YouTube. And then thought about it without knowing that this is actually what that meant when I was a young kid. So there's that. So, if we were right now to start doing it, we would be able, ultimately, for research and development, if I'm involved in more, to get there fairly soon in the possibly 5, maybe 15 years range. Unless you ultimately were able to get enough funding and enough people, then what we're talking about is actually genuinely very doable within maybe a year to 5 at most. Okay? But that's people that are smart, that know about this, that can work together, are actually knowledgeable on this and are willing to do it with enough money to build and do all of it as necessary. So that last one turns into, so no, huh? Yeah, no kidding. So, have fun, I suppose, on that one. But, yeah, that's kind of the zenith point. This is the signing off point. I've been talking for a while. I kind of want to be done. Like and subscribe. Please share the tag along I did not use that maybe some people did not enjoy the fact I didn't use it. Suck my dick and balls. Yeah, I went there. And also that this is able to be done far better than you might expect, as you can use quantum foam energy to effectively calculate as well using this and impart that back in for your silicon transistor. The caveat for this is that it's not able to run off of that. I had to build that specifically to then be able to feed back into itself, to then be able to do something where it was able to run off of its own captured energy, sort of like a big radiator that is a heat pump that eventually got big enough that the captured, and with the right refrigerant and everything, energy that was then stored was able to be captured efficiently enough to then move and use that energy. Able to be captured efficiently enough to move the pump to ultimately continue its operation. Able to run itself. But I also got a little bit more than just run itself over enough time. Okay, so it will pick up and start grabbing more, but it's not coming from nowhere, it's coming from quantum foam and nothingness, and of course, there are a ton of fucking neutrons, other virtuals, electromagnetic, light, all the things. So, you think it's perpetual, although technically quantum wave fluctuations are able to win this thing, so it will do that. It just has to build to that level of insane, kind of thing. It just, give me a second. All right, so that was the dad calling. I might discuss that later, but we're done on the cooling. Okay, it does work out that with surface area and depth, I can gather enough energy to run it, and it's essentially kind of like a cold box. It absorbs anything that it can get its hands on after a point, and transfers it into energy to perform more calculations. So it starts off, you have to put energy in. It starts getting more, and from there, that kind of thing. So after that, there isn't much else to discuss about it. It's not really necessary, and the quantum foam totally can work. Okay, it can calculate, and it can sense as a result of doing that, depending on how you want to do it. And it can project some light and interfere with things around it, which is why I talked about it as a nanobot to a degree. But the reason why I'm talking about it is because that's something that is really good for quantum noise field and more observations as a sensor and detector, but also really good for even us, right? Like it can sense and calculate from almost like it's an eye. So it would be able to know while being alive where you are without needing in any aspect any cameras. Please don't fuck it off. It looks and observes at you. Do you sense the hairs on your neck prickling? Eh. But yeah, no. It's really just to be more efficient. It's to make more quantum calculations and to make less heat and interference occur for the given calculations going on this fast. Okay. If you wanted to do it, I usually don't. I'm not a big fan of it. It doesn't really help as much as you would think. It doesn't really seem to do much, and it for sure takes a lot of effort to put together. So it's usually best just made into its own chip thing as a result. But I suppose you could go pretty hard on that and figure it out. But to each their own. I just personally would prefer instead to actually make the thing, and instead of claims or whatever, it's let's do this. Don't just believe me. Let's research and develop. Let's get it going. Let's do the thing and go from there. Let's have hope for this and its potential, but let's be realistic in that we must do it and see how far we can get within our given lifetime with the money and the progression and the programming materials and all the rest that we are able currently to do. The physics works, the math works, the programming works, everything can do what it is I'm saying. The, of course, always ever-present thing is doing the thing. Just because something is theoretically, it does not mean we have done it. Kind of a thing, unfortunately. I'm a bit of a rain on your parade guy sometimes. So, see you later. Have a good one. Bye.